Okay, hello everyone. Can you hear me? Test. Okay. Um, hey, I'm from Germany. I would expect that normally people are 5 minutes before the time here, so I'm still surprised. I see everybody adapted quick to Paris. Um, just second day, Rejekts, very excited, and we already start with a great topic. So Philip Nikolic is going to present us demystifying CNI, writing a CNI from scratch. Sounds awesome. So welcome, Philip.
Thank you so much. Thanks so much. Happy to be here and welcome to the final day of the conference. So, as already mentioned, what we're going to talk about is demystifying CNI. And the way how I want to present this to you is by writing our own CNI from scratch. So, in order to first of all as well understand what a CNI is, we'll get to that. My name is Philip Nikolic, and I'm currently working at Isovalent, the creators of eBPF and Cilium. In case you have already heard about Cilium, it is one of the most popular CNIs out there. But we will not talk about Cilium specifically within this talk. We'll take a step back and really look at it from a more general perspective. What is a CNI actually? What does it do? What is the goal that you want to achieve, and why does it exist? So, to get on with it, we'll have to know what a CNI first of all is. CNI stands for Container Network Interface. It sounds very simple. And it may as well be a bit misleading with the name it has. It may let you think perhaps or lead you on that it is necessary for all sorts of traffic that is being generated. But that's not the case. It actually does not perform any of the load balancing, as you know. What it actually does do is setting up configuration. It's setting up configuration so that your pods, once they start, can actually use and facilitate the networking layer underneath it. So it is not necessary to have a CNI running if you already have all of your applications there. This is the first myth that I want to bust here, all right? It's very important to understand, as we'll see in the next couple of slides. And furthermore, when we'll look at a CNI, we as well have to understand that there is a so-called CNI spec. It's basically a definition of an interface between a so-called runtime and a CNI, and CNI plugin, and how this works. It just defines, similar as with protocols that we may know, what is expected to be happening. Now, to better understand this, let's look at this picture. Some user is applying a YAML file. So you have your pod, you have your best application ever in your version 1.0.0, and you want to apply it. So you're writing a YAML file, and you're sending it over to the Kube API server. You're sending it over, and then the Kube API server will do whatever is necessary for it to do. It will, at a certain point, the scheduler will pick a node where the pod is going to land on, and then it will send those commands to Kubelet on the specific node. Kubelet, on the other hand, will delegate its work. Kubelet does not create containers for you. It does not. What it is going to do, though, is it will trigger another interface, which is called CRI, which stands for Container Runtime Interface. So Kubelet will tell CRI, hey, I have the job of creating a container, and I'm letting you do it. So the CRI will then go ahead and create a container. Once it does certain amounts of work, it will then invoke the CNI. So the CNI is actually invoked by the container runtime. The container runtime will then go ahead and invoke the CNI, and the CNI will do inside of the container what is necessary in order to ensure that network configuration is being put in place so that traffic can flow as we expect it to flow. Now, when I say container, it is as well very important to understand what a container is. Due to time constraints, I cannot explain all of it, but we'll get into what's important for this talk. When I say container, I mean a network namespace. Please keep in mind that namespace here does not have anything to do with Kubernetes namespaces. The way how containers work is that they are leveraging a couple of kernel features. One of those features being namespaces, kernel namespaces. It is basically providing some kind of an isolation within the kernel itself. You have to be careful with that word because it is still using the same kernel underneath it. However, what it's trying to accomplish is that once you create a namespace, you will see a different kind of view from within that namespace compared to outside of the namespace. So when you usually work inside of a system, you execute whatever it is that you execute, all of this is going to have an effect on the entire system. If you were now to create a namespace and execute something in there, it will only affect it within that given namespace. And the important namespace for this talk that we're going to talk about is the network namespace. What the network namespace allows you to do is it allows you to configure something within that network namespace without it directly influencing the network namespace of the host. So you can, for example, assign certain interfaces to that specific network namespace, and it will not affect the things on the host. You can assign certain IP addresses within that network namespace without changing the IP address of the host network namespace, and so on. It's truly important to understand this. We'll get into some more details further on. So what the CNI then does, after the CRI finishes to create this network namespace, which is oftentimes as well referred as a pod sandbox, it will create that pod sandbox, it will create that network namespace, and then say, hey, CNI, now it's your job. I created the network namespace, now it's your job to please configure the network configuration inside of that network namespace. So the CNI will then go ahead and create certain interfaces. Those interfaces usually being virtual Ethernet interfaces. We'll get into a second exactly what those things are. In case you're not really familiar with interfaces, with virtual interfaces, and so on, we'll cover that in a bit. But what's important to understand is that the CNI just goes ahead and now does things both on the host side of things as well as inside of the network namespace in order to enable the communication. So usually, what this means is that we would create a certain set of devices. We would create those devices both inside of the network namespace as well as on the host, on the node itself. To look at a node, for example, how those different network namespaces can usually communicate with each other, this is how they would do it. So we would have multiple pods on one single node. We would have them there, and then we would assign their own set of virtual Ethernet pairs to each of them. And then we would as well, oftentimes, for example, use a bridge in order to have those virtual Ethernet pairs that are on the side of the host being connected to a bridge. Now, this is a common theme that you can observe with many CNIs out there, and it will facilitate that the network namespace can now talk to each other. As well, if we now talk about a multi-node architecture, what we're going to see is then that the network namespace, if the left one wants to communicate to the right network namespace, it will go over the bridge from one virtual Ethernet pair to the other, over the bridge, and be able to connect to the other network namespace. And if you now wanted to communicate to another node or outside of your own system, then you would go over your interface of the node itself, which are connected, and you would be able to access other pods on those machines. Now, as you can imagine, that's quite a lot, and we're quite timely constrained, so I won't be able to dive into multi-node architectures here, into bridges, and so on. There's many different architectures how you can set this up. You don't not actually need to use a bridge at all. This is oftentimes just a convenience tool when you deal with multiple pods. So to keep it simple, we're actually going to deal with just one node and writing our own CNI plugin so that we can actually start one pod on that specific node and ensure that the node can reach whatever is inside of the network namespace. So let's go ahead and go back again to the CRI. The CRI is going to create a network namespace for us. After it is being created, it will trigger the CNI. Now, how exactly does it do that? Well, what I want you to remember is that there is two paths. There is two paths that are very important when it comes to CNI. The first one being /@ etc/cni/net.d. Inside of there, it will look for a configuration. The CRI will look inside there and just take the very first alphabetical file that it finds within the directory. Then it will load that configuration, and once it loads that configurations, it will know what further to do. So the CRI will look inside of that folder. And now let's start with writing our own thing. Well, to be honest, I didn't want you all to get bored while I'm making 50 typos, and in order for us to then debug things, so I simply put it on slides instead of doing a live demo. The very first thing that we therefore have to do is we have to create a file inside of that directory. How we name that file is not really important. However, what is important is that it has a certain structure. It has to have a JSON structure and certain set of things inside of it. I simply named it 10-demystifying.conf. Now, something that you'll see very often as a convention is this prefix of a number and then minus whatever name. That is because, as I mentioned beforehand, it will list the very first file that it finds in alphabetical order and load that configuration. So in order to make sure that we're loaded in case there would be multiple configurations, we can prefix ourselves to be at the very front by, for example, putting a 1 or a 0 or something like that in front of it. And then we'll put a JSON in there. The JSON is very simplistic, as you can see. We'll simply say CNI version and specify the version of the CNI that we're going to have. There is a regulated version set that you can use. Those are defined by the so-called CNI spec, which defines what a CNI is and how it's supposed to work. And so we'll just put in our version in there, and then we'll put in a rudimentary name. The name doesn't matter all too much. However, what does matter the most, which is highlighted here, is the type. Because you see, the type is the next thing that is very important in the order of events. Once we specify the type, for example, setting it to demystifying, it will now look in the next directory that is very important. I mentioned beforehand that there is two important paths when it comes to CNI. The one being at ccni.net.d, where we are right now, and the next one being inside of /opt/cni/bin. The type is important because what you define as a type within the JSON is now what it's going to look for inside of that directory. So inside of that directory, it will now search for an executable called demystifying. Now, what do you mean by executable? All I mean by that is that you can use whatever you want, and as long as you can trigger it, that's going to be fine. So it doesn't even have to be Go. And as a matter of fact, I want to as well bust the myth that everything in Kubernetes must be related to Go. So what we're going to do from now onwards, as well in order to save some lines of code, we will go ahead and write our CNI plugin in Bash. Once the CRI now knows which CNI plugin we want to call, which is the demystifying CNI plugin, it is as well going to set a certain amount of environment variables and send them over. Those aren't all the environment variables that are set, but they're the ones that are important for our talk. As we can see, it will set an environment variable called CNI_command, and it will do an add, because that's what it's essentially going to happen whenever we create a pod. It will tell the CNI, hey, there's a new thing, now please go and add the network configuration. As you can imagine, this suggests as well that there is different kind of CNI commands that you must think about. There's not only add. Add is being invoked whenever you create a pod in order to set up the network configuration. Similarly, if you were to delete a pod, you would have delete in there, and then you would have to take away the network configuration that you applied. However, to keep it short, we'll just focus on the add here. So we have the CNI command called add. As well, the CRI is going to tell us which network namespace it created. It is doing so with the next environment variable, CNI_netNS. It is just telling us where this network namespace is located so that we can actually know which one it is. What you always have to think about on a larger scale is that there will be many different network namespaces because they're created for each and every pod. So you will have to know which network namespace the CRI just created in order for you to be able to apply configuration to it. As well, lastly, we have CNI underscore IF name. IF stands for interface, and so this will come in handy during the end of the talk. So now our demystifying plugin is being called, and it receives those environment things. It as well receives the JSON that we saw beforehand as a standard input, but we'll ignore this for simplicity reasons right now. So the next thing that our CNI wants to do is actually create certain devices. We want to create something, and what we want to create is a so-called virtual Ethernet device. Now, what exactly is that? It is a very special device that tells the kernel whatever reaches one end of the virtual internet interface will be sent over to the other end. Now, this may seem a bit useless at first, but we'll get to why that is so important and crucial when we're working with network namespaces. Because essentially what we can do afterwards is use those things and tweak them in such a way that network traffic really goes where we want it to go. So we first have to create those virtual Ethernet pairs. And when we create this, we'll have a very simple command. We'll have an IP command, IP link add virtual Ethernet underscore host, which defines how we're going to call one of those interfaces. Then we're specifying the type, that it's a virtual Ethernet device that we want to create, and we'll as well specify a peer name. Now, the peer name is the other virtual Ethernet interface. So whenever we want to create a virtual Ethernet device, we'll have two interfaces that are being created. And we can give those names as we did here. Now we have two interfaces on our host system. We have two new interfaces on our host system, and honestly, they're pretty useless right now. They're called VF host and VF netns. Now, the next thing that we want to do here is we want to move one of them inside of the network namespace. We want to move it there, because why would we want to do that? Well, so far, we don't really have some nice interface inside of our network namespace. Usually, when a network namespace is being created, all it has is the loopback interface in there, which is not really useful, right? We want to be able to somehow send traffic out of it and into it. And so in order to do this, we somehow need to have something there, right? Similar as how we would have a cable between certain machines, between certain systems, we need some sort of a cable between the network namespace and our system, which is running in its own network namespace. And in order to do so, we're now pushing one of the virtual Ethernet interfaces inside of the network namespace. And how do we do that? Well, the way how we accomplish this is, again, with an IP command. The IP command being IP link set virtual Ethernet netns, which just specifies which of those interfaces we want to push where, and then we're telling it to push it inside of a network namespace. And this is exactly where those environment variables are helpful for. As you can see, we have the environment variable that tells us which network namespace has been created by the CRI, and now we know where to push this to. So by doing this, we have now successfully put one end of the virtual Ethernet pair inside of the other network namespace. And now we want to assign it an IP address. This IP address is essentially what we're talking about whenever we talk about a pod IP address. So we need to set an IP address there, and this will as well be what is displayed whenever you do kubectl get pods -o wide, where you can then observe those IP addresses. So in our case, let's set it to 10.244.0.20 and give it a subnet mask /24. Once we do that, again, question comes up, how do we do this? So how we do this, again, IP command, very easy. We're having the IP command, and again, we need to specify, since we're doing something inside of the network namespace, to do this inside of it. So again, we have IP -n, and then the specific network namespace. Then we'll add an address, and we'll add the IP address there as specified, and we'll add it to the device called virtual Ethernet underscore netns. Very simple. And as you can see, a lot of this has a common pattern on how we work with things. Now, what we want to do as well is obviously assign an IP address to the other end. So we want to assign IP address to the other end. How do we do this? In a very similar fashion again. So we have the VF host, and we'll assign there an IP address as well. In our case, we'll call it 10.244.0.101. But we will assign it a /32 notation. This will come in handy in just a bit. The reason why we're doing this is because, you see, we as well need something else further down the line. But before we do that, let's rename our interface. Nothing really has changed here, besides that the interface inside of the network interface is now being renamed. Why do we rename it? Well, if you remember, I told you that there is another environment variable that we're going to look at, which is CNI underscore interface name. Whenever you are inside of a pod and you were to list all the interfaces in there, you won't see such a weird name as we decide to give it, like VF underscore netns. No, you will see it as an Ethernet 0 interface. And so in order to do this, the CRI is telling us, hey, after you've created that interface inside of the network namespace, please name it accordingly. So question again rises, how do we do this? As you can imagine, again, we're using the IP command. We're using the IP command specifying which network namespace we want to interact with, and then we're just going ahead and setting the name accordingly. So we set the name to Ethernet 0, which we derived from the environment variable. Now, why exactly do we have the IP address on the host side with a /32? Well, the reason why we want to do this is in order to not confuse ourselves when it comes to routing. Now, if we wanted to access a service that is running inside of the network namespace, let's say you were going ahead and deploying an HTTP server in there, whichever one it may be. Let's say it was an Nginx server. You have an Nginx now running inside of the network namespace, and inside of the network namespace, we could reach it then either via localhost or via its own IP address. But how could we do this now from within the node? So let's assume you want to curl it from the node. Now, in order for you to be able to do a curl onto 10.244.0.20, you will need to let the system know how it will reach inside of that network namespace. So what you want your kernel to do and to know is that it must send all kinds of packets over the virtual Ethernet host, right? Because if we go back and remember again what a virtual Ethernet device is, it just says that whatever reaches one side of it is going to be transmitted to the other. And this is exactly what we want to accomplish. So what we want to have now is that the system knows how we're gonna be able to send things to the network namespace. So we'll have to add a route in there. And we'll have to add a route with a /32 prefix, because we do not want anything else other than the designated destination of 0.20 to go there. So we'll do IP route add and add the destination for the pod, for the network namespace. We'll add that as a destination in there, and we'll tell the kernel, hey, whenever you want to send traffic to this specific destination, please use the device virtual Ethernet host. Now, once we do this, and once we're done, the question is, what now? We've now successfully set up everything and put in place what is necessary. So once that is done, the CNI now needs to give a return to the CRI in order to signify that, hey, I'm done, I did my part, and I'm done now. So how it is doing this is by returning JSON data. and you're just returning this as an std out. So we're going to have to write a JSON now, and we're going to have to return this. Once that is done, we finished our entire process. So to summarize, we have created two files. The one file being a config, which is a very simple JSON. The other one being our script by putting together all those things. As you can see, this is a very simple bash script, because again, it just needs to be an executable. You could write this in any language you want. You could do this in Go, you could do it in Rust if you wanted to, you could even do it in Java. It doesn't matter. But it just needs to be an executable that can be called inside of that specific directory. So in there, if you want to, you can go ahead, copy paste this. It's a working CNI, and it will create a single pod onto that node where we create this, and it will work. All of this is just a summary of the commands that we went through with a couple of additional comments. As well as I mentioned, what we need to do in the end, once we've finished all of our network configuration, we will have to return a JSON. For that, we'll have a template in place. So we have a template where we simply tell the CRI, hey, I created those interfaces. They have this MAC address, and I created it with this IP address, and so on. And this is important, so that the CRI can then go back to the kubelet and say, hey, everything has been successful, everything has been created as it's supposed to be, and now Kubernetes is aware of the IP address that we assigned. So, summary, two important paths. CNI handles network configuration, and very important, it is not a runtime requirement. It is not important when it comes to things such as actually directing or load balancing things from within the servers or similar. For that, we have other systems in place, like, for example, kproxy with IP tables, IPVS, or certain other things, like how other CNIs, like, for example, Cilium, use this. Once the things have been created, the pods have been created, you could actually remove the CNI entirely from your cluster, and everything will work fine. You'll then, however, have issues deleting and creating new ones. Thank you so much.
I'm sure you have questions. Other than that, no questions, then thanks, Philip. And
thanks so much.
We have continue at 10:05. Okay, all right, welcome back. We have now a nice, interesting talk from Miguel Luna. Um, I cannot remember the title. I'm like a goldfish. I tried it, but okay, I will read it now. Kubernetes resources entities applying system thinking to observe Kates beyond metric traces and logs. Sounds awesome. Welcome, Miguel.
Hi, folks. Thank you very much. I'm very excited to be here. My name is Miguel. I'm a product manager at Elastic, and let's talk today about system thinking and Kubernetes observability. Okay. Oh, it doesn't seem to be working. All right. Oh, yeah. So pretty sure that today you're going to see a lot of these presentations talking about Gen AI generated images and content. I did not want to be left out, so I tried my best, and I asked ChatGPT and Gemini to see if they could help me with a nice icebreaker joke. Whew, man, that was tough. So basically, Gemini told me we'd start with a grin, which was kind of weird, and then the jokes didn't land. I'm not gonna put you through the pain of reading them myself, but what I can tell you is, if you're a comedian, your job is safe. You're still not gonna be taken by Gen AI. So let's get cracking. That's it, I'm not gonna quote more Gen AI. So a little bit about myself. I'm Colombian. I've been living in London for 20 years. I'm an industrial engineer. I also studied computer science and worked in supply chain system management for a while. This is where I bumped into systems thinking, then eventually moved to the telco world and bumped into Kubernetes, liked what I saw, started working in cloud computing, and moved to observability. Basically, a little bit of everything, so you're a stereotypical product manager. Today, we're going to cover 3 sections. First is why systems thinking, and talk about the challenges of using only traditional observability when observing Kubernetes. Then we're going to talk about some of the core concepts of systems thinking and look into a way of representing systems. And finally, we're going to explore how to use systems thinking to observe Kubernetes. And we're going to have a feature appearance by our friend OpenTelemetry here. So let's do a little bit of correlation. Raise your hand if you're here to attend KubeCon. No one here just to see me? Okay, all right. Keep them up, keep them up. Okay, keep it up if you're familiar with the 3 pillars of observability. Okay, so we got good correlation still. Keep it up if you have been to Japan. Okay, we have a good correlation. So, but you folks know that correlation is not causation. So I do have a reason for these 3 things. And that reason is the Shibuya crossing in Tokyo, which I love. So I love an analogy. And basically, one thing about the Shibuya crossing is the biggest crossing pedestrian in the world, up to 3,000 pedestrians crossing every 2 minutes, 260,000 to 390,000 per day, or 1.5 million per week. So that's impressive numbers. I love an analogy, and I'm going to try to use the crossing to explain systems thinking and to explain the challenges of using traditional observability with Kubernetes. So the first concept is this: we get challenging levels of abstraction. So either we have tools that are very good at doing 1 or 2 things, but if you want to do something else, you struggle because it's very monolithic. It's an abstraction that is simplified, but it's simplified to do 1 or 2 things. On the other hand, you get a lot of low-level signals. So you're lost in an ocean of low-level signals that are too complex, and this is what I call DIY observability. So basically, you need to correlate yourself, and good luck, you gotta be an expert not only on the tool that you're gonna use, but you also gotta be an expert on Kubernetes. Another topic is, it used to be normal only for large enterprises to be the only ones that could have 1,000 servers, 1,000 virtual machines. Today, any of you folks in the room can open up your laptops, go to a cloud provider, deploy a Kubernetes cluster, and deploy tens of thousands of pods. So if we think about scale, 30,000 pods, for example, emitting 50 metrics. We're talking about 1.5 million metrics every 5 seconds, depending on the scraping frequency that you have. And the last aspect is static and rigid views. So traditional observability was built for well-defined entities that were not changing. So you have basically your pets versus cattle. It was more meant for pets. So think if you have, I have instrumented my Shibuya crossing to read faces. All of a sudden, it starts raining, you get umbrellas, I have to re-instrument everything. So think about it from that perspective. Right, so why system syncing? So system syncing can help us with some of these challenges. So I'm gonna show you some techniques to get to the right level of complexity, also some others to help us focus on what is relevant to observe. And finally, we'll explore a way to represent these systems that is easily adaptable. So we have arrived to the system syncing, to our second section. When I did one dissertation, I remember I had a professor that deducted me grades because I quoted Wikipedia. But I trust that you folks, you love community, you love the power of community, so you're gonna give me a pass on this one, just because I really like how Wikipedia puts it. So Wikipedia defines it as a systems way, as a way of thinking to reduce complexity in the world by thinking of things as in terms of wholes, but with interacting parts. So, but before we go now into further concepts, I just want to set some caveat, if you want to call it. So system thinking is vast. So we are going to focus on the core concepts, and we're going to explore a way to represent these systems, but these representations are not architectural diagrams. So don't take, or modeling, don't take them as such. They don't have the persistent semantics. They don't have the rigid syntaxes. They are mostly to enable us to have shared understanding, also to facilitate discussions. So when we have a complex system, we need to find a common ground where we can have those complex discussions. And these representations are going to have a short shelf life just because systems are dynamic. Let's start with the first concept. The concept is called function. So function is what the system does, and it contains two parts. One is the process, and the other one is the operand. The process is the change itself, the thing, the activities, the transformation that is being done to the operand. The operand is the thing that is being transformed. So in the case of our Shibuya crossing traffic, we have a process which is controlling flow, and we have an operand which is traffic. So the function itself is to control the traffic flow. So that's the function of our crossing. We represent function as a white square. You can also find your own representation if you like. And another concept is form. So form is what the system is. So it's all the physical or informational embodiment of the system. It will include material, configuration, instructions. So sometimes it's referred as mechanisms, molecules, infrastructure. In the case of our Shibuya crossing, I'm going to take everything that is part of the scramble crossing. So it will be like the traffic lights, the crosswalks, the signage, street markings. And voila, if we put together function and form, we have our Shibuya crossing system. The only challenge is it's too high level. So but like I was saying, it's one of the challenges that we have with observability. It's very monolithic. It's hard for me to observe something when I don't know what's going on inside. So here is where we have a technique that is called decomposition. And what we do is we can identify the entities that are part of our system. Now we are going to observe this Shibuya crossing and understand all these entities. So in this case, I have selected pedestrians, cars, traffic lights, zebra cross markings, and drivers. I could go even further. I could decompose this into more complex parts, but I want to keep it at that level. Why? Because sometimes there is this Miller's law that talks about the right number of entities that a human can process is 7. I'm not sure if that's proven, but I like 7. I think this is a good number. So the recommendation that some folks give around is try to keep it between 5 and 9. So we have our entities. Now we're going to talk about how do we define which of these are most relevant. This is where we can define our boundaries. So in my case, I say I'm someone who is in charge of maintaining the Shibuya crossing. So I'm thinking the entities that are part of my system are the things that are actually under my responsibility. And I don't have anything to do with maintenance of a car, even though it's an entity in the system. So I define my boundaries to be here. One key thing, it does not mean that just because I define my boundaries, I'm going to forget about everything that is outside. So actually, that's what we call the context. So now you have your system and you have the context. So I could just not go and say, yeah, pedestrians are not important because they're outside. No, actually, if you are going to design, you're going to understand how your system behaves. You got to understand how many pedestrians are going to cross. So this is quite why the context is quite important. We move on to functional relationships. So there are two types of relationships. One is functional and one is formal that we will look into next. So the first one, functional, are relationships that how the entities interact with each other. So, and they're usually represented, or not usually actually, I want to represent them that way with black arrows. And in this case, a functional relationship could be, you have drivers whose function is to guide the cars through the traffic lights, and you have traffic lights that signal stop and go. So the relationship here is that the drivers will guide the cars as long as the traffic light is green, or it will stop when the traffic light is red. The other type of relationship is the formal ones. So these are more structural. So these are the type of relationships that will help you understand what is the impact between components. Like if they're next to each other, for example, if we have the same case, we have the cars and we have the drivers. If there is an impact on a car, if there is an accident, you know that there is another entity in your system that is going to be impacted by this. So it's good to understand these relationships. Finally, we have my favorite concept, which is emergence. Some people call it a phenomenon, but the way that is described as well is when you have a system and you have components that are working together, you get the emergence of extra attributes or extra properties that did not exist before you had your system. And there are 4 types of emergence. So the first one is emergence of function. So it's something that the individual components could not do on their own. Now you can do them. So in the case of my Shibuya crossing, we have synchronized pedestrian flow, which we didn't have before. On the performance side, yeah, I guess you can say, yeah, pedestrians can cross on their own, but are you going to get 3,000 people every 2 minutes? Probably not. And the third one is emergence of the ilities. So everything that you think about non-functional properties like availability, reliability. In the case of our system crossing, I'm talking about reliability because I could change my traffic lights to be a policeman, but then I'm going to lose that. Am I going to have someone at 3 in the morning marking every 2 minutes for people to cross? Probably not. So that's where you lose the availability and reliability if you change your system. Finally, is emergence of emergency. So it's the things that we don't want to happen. So unexpected or undesirable behaviors that we didn't anticipate. So if there was a malfunction in our system, the pedestrian lights were green, the traffic lights were green, you can imagine we have an accident, so that we have an emergency as such. So takeaways for our next section. Aim to understand the entire system, not just the isolated components. So that's holistic thinking. Break down into manageable parts and create meaningful abstraction. So don't abstract it too high. Don't put it into unmanageable parts. So this part we can achieve with decomposition and composition. The third one is define the relevancy of your entities. So focus without losing your context. So this part is define your system boundaries. And the last one, understand the emergent properties of your system. So emergence. So let's now move into the applying of this system thinking to observe Kubernetes. I'm pretty sure you folks are way familiar with this more than I am. But I do think that the temptation will be like, oh, okay, we got it. System thinking, architecture, fine. We have our system now. You got your control plane, you got your boundaries. Well, no, the good thing is that now I have given you much more flexibility to think of Kubernetes in other ways. So not necessarily solely about how you represent the things architecturally. So we can start thinking from the perspective of relationships, and we can start thinking of ways that we can capture those meaningful interactions for us, our case, for our specific problem or question at hand. I'm going to do a little bit of abstraction here and focus on these meaningful abstractions tailored to a problem or question. And if we move to the world of Acme Incorporated, who's using Kubernetes, we talk about two user roles: a cluster user who just wants to have applications running on their Kubernetes cluster, and a cluster operator who wants to provide that infrastructure. In this case, let's focus on the cluster user who is keen on having application orchestration. So they love Kubernetes. They don't love the rest of the parts. They love to get the application orchestration. If we define our system and we identify some entities, then we can see an example that the cluster user can go and use kubectl to store their intent in the form of manifest in etcd. Then you're going to have the controllers querying the API to understand if there is a diff, trigger the kube scheduler to create some pods and put them on nodes. But I do feel that this is still very complex. I have way too many entities. So as this cluster user, I'm probably not too worried about all those extra components that I have outside. So I could compose, and you can see on the right-hand side, I could decide that I just want to have all these entities as one entity that is the control plane. Or I could also be interested in, actually, stateful set are quite an important entity for me, so I'm going to decompose stateful sets into its parts, and I want to see them to understand the relationships inside this stateful set. One thing is we have achieved now what we call our meaningful abstraction, but remember, we want to set some boundaries to define what is relevant for us. So in this case, I'm pretty much going to say I'm a cluster user. I'm not interested in the control. Well, I am interested in the control plane, or I'm not interested until I am, or until I have to. So I'm going to just put it as part of my context, and also nodes. Nodes for me I use nodes, and I want to know what's going on with nodes, but I'm not necessarily 100% keen on observing nodes. Could be meaningful if you're a cluster operator, then it's quite the opposite. You're more focused on the infrastructure, and you don't care what's going on, what users are using the infrastructure for. You only care about how the resources are being used. Or even if I was chatting with someone else earlier and said, do you deploy your own Kubernetes clusters? And they're like, no. Well, I mean, like, do you deploy them vanilla? And it's like, no, who does that? And say, like, well, basically, if you're doing managed Kubernetes cluster, then probably you don't want to be understanding what's going on about everything in the control plane, but you want to keep it in your context. So final section, let's observe my application orchestration system. And this is where our friend OpenTelemetry has entered the chat. One thing that I like a lot about OpenTelemetry is that it's not just about collection. We also have this amazing, fantastic context layer where you have semantic conventions, so a shared vocabulary, you have resource attributes, and you also have the execution context being added where it's possible. And this is all being done uniformly, so we are able to tag all our signals in the same way. So if we keep these resource attributes and we see that they represent the entity emitting the telemetry, what this allows us is to now do a pairing. So we can identify, and I'm pretty much in luck here, because I can see that my resource attributes happen to be specified in the semantic conventions resource attributes. My entities happen to be specified in the semantic conventions resource attributes. So yeah, so I'm a lucky guy this time. And what we can do is, some of you folks that are familiar with OTel and the OTel collector will be familiar with this picture on the left-hand side. So in the OTel ecosystem, there is a part that is, you have processors, so to process data, transform data in a way, but one of the nice things that I can find as interested in monitoring Kubernetes is this Kubernetes attributes processor. So what it does is it will tag my signals with the data that represents my entities. So the specs that I just told, the resource attribute that I just called up now are being added to my signals. And what this does is that now we have everything uniformly being tagged with the entities that are part of my system. But one thing that I want to do is we should flip this on its head because we want to move to an entity-centric observability. So now I have my system, and imagine all the creative ways that you can get to put together this telemetry in a way that represents your system and to understand the relationship between these entities. So basically, this is giving us like very, very nice creative ways to do this. We could have, for example, a way to visualize my entity, which is a pod, but not just the pod and the metrics of the pod. Like we mentioned, like it's not about just observing a pod in isolation. We need to understand the whole system. So we could start bringing up other entities that we feel that are relevant because now we know those functional and formal relationships. So we start thinking, okay, maybe we should, if this pod just didn't get there on their own, so we maybe want to pull this replica set here. We want to understand also what's happening with the node where our pod is running, even though it's outside of my context. And a more forward thinking is we could even consider telemetry that bakes in the functional and formal relationships or a model system that captures them. So it's a way to create I know this looks like a service map, but it's not something created by traces. Ideally, it will be something that helps me identify the relationship between the entities. So as we were talking about the car and the drivers, then I could understand that there is a formal, a structural relationship there, and I could represent that, and it will help me understand which entities are going to be affected when one of those goes down or when one of those is malfunctioning. So recap. Kubernetes needs complementary techniques to traditional observability, as we looked into. We want to reduce complexity. Don't be afraid of things being looking like too easy, if we want to call it. You don't want it too easy, though. So we need to get to a meaningful abstraction. The third one is systems are not rigid, so we are able to adjust this representation, and we should do it often. And finally, explore leveraging the OpenTelemetry resource attributes in creative ways to help us not just understand emergence of your system, but even better, predict and avoid emergency. Thank you very much.
Thanks, Miguel. Do we have any questions? Feel free, ask a question. If not, then yeah, thanks again, Miguel, for presenting the talk, and we see each other in a couple of minutes for the next one.
Thank you, folks.
Okay, hey, welcome back. Now I have a talk. I'm personally also very interested in this cross-plane cluster API. That's really cool. Carlos is going to talk about too many CRDs. I say not enough. Leveraging cross-plane cluster API for effective platform delivery. So welcome, Carlos, and go on.
Thank you very much, Antin. Can everybody hear me well? Yep. Okay. Well, welcome everyone to my talk. I am Carlos Mestre del Pino, KCD NL organizer and platform engineering consultant in ITQ. And well, I'm going to present, as Antin said, about cross-plane cluster API and how you can make more efficient usage of your CRDs. I find very exciting to be here in this such gaming location because, well, people will not know this, but my cousin is actually the current European champion of eFootball. That is, well, kind of the rebranded Konami Pro Evolution Soccer. He's also been professional player for Bayern Munich for 4 years. And as you can see in the image down there, well, he was there in Paris. That was actually his first international performance. And, well, he came third. He didn't win. Then again, I also did not get accepted to talk in KubeCon, so I think we're sharing something in there. And you can also see in the image, he made €150, right? So must be nice. So let's move on now then onto the presentation. Before, I would like to start setting a little bit of, what is a platform? We're going to come and put the absolute definition in here, but let's set some premises. So according to Gartner, a platform is the self-service interface through which developers can access internal developer platform capabilities, so tools, etc. It is golden paths to production, and it's techs and tools which are glued together in a way which will lower the cognitive load on developers. What does that really mean? Now, again, I'm not going to refine the definition, but let's look a bit at what a platform usually provides, right? So a platform provides the infra tools that you need to manage your customer workloads and the platform itself. Again, the tool services and blueprints that your developers need to run their applications, as well as governance, policy, and security guardrails such as RBAC, etc. That doesn't come without any challenges. So there's a growing set of disaggregated platform components which are running everywhere, anywhere. So that can be on premises, on cloud. You might be consuming directly of some kind of managed service. And they have to be glued together, and most of the times as well, highly available, both for us as a platform team as for the developers. There's also other sets of challenges, such as organizational challenges. So how do we do tenancy? This is not only multi-tenancy within a Kubernetes cluster, but how are we organizing resources across, well, let's say, the whole data center and other services which will be consumed by the clusters. There's also operational challenges, such as complicated RBAC models. For example, when you have like a third integrator party, say that the security team needs to install a certain component into every cluster. Well, when you're in the GitOps model, you're going to run into a bunch of issues. Like, for example, there's, of course, you're not really giving cluster-wide permissions, but they might need to install create cluster roles, cluster role bindings, etc. So you need to work a little bit around that. And of course, there's a cognitive load, so large amount of tools to learn. In this case, both for you and as well as for your developers. So this thought, too many CRDs. I guess most people might have heard this before. It comes, I think, a little bit more from well, people that's beginning and it's starting to understand, okay, there's all these new objects which I have in my API, as well as potentially with people that's a little bit more hesitant as well, still in Kubernetes. But I was wondering why. Why does this happen? Why is it so special about CRDs, right? Well, when you're looking at your resources, your core resources, well, they're in fact just someone else's abstraction, right? Why are you not thinking differently about a pod, a deployment, a service? What did that ever mean to you before you started learning Kubernetes? So of course, the moment that you're installing other CRDs into that cluster, well, you're going to have to learn what these CRDs do in the application that I've installed, etc. So Are there too many CRDs? In my opinion, there are not enough, because CRDs will be able to, they will allow me to manage, let's say, my platform, my application as a cattle, right? Let's get on with that. So what do we know about cattle? Well, there's this tale, of course, this whole pets versus cattle concept. First, as well, a little bit on how we're managing servers. Eventually, as well, with applications as well, workloads running on Kubernetes. So we know that individual members of the herd are replaceable. I must be able to move them from one place to another. So within the ranch, go into the feeding area, go into the milking area, etc. And I must be able to do this as a group, right? I don't want to take individual members and do this, right? So what did turn your pets into cattle in the past? Well, I think there's like 3 main points, I would say. So that's the infra as code, you're provisioning your resources in a declarative way with infrastructure as code. You're configuring them as well after they have been provisioned. And in the case of applications, there's of course, containerization, which essentially was taking all what I need for the application, code, dependencies, etc., and packing them as a unit, which I can then deploy. So what is causing your platform to be treated as a pet, right? Because we talk about how our developers should be building Kubernetes native applications, but sometimes I'm wondering, are we building Kubernetes native platforms? It's this guy. So if you're managing cattle, your platform, it's in fact your shepherd, right? And of course, we all know and love dogs, so we look at them as pets, but in reality, for the shepherd, the person, they're another tool, right? And they also cannot get too attached for them because they're a resource for work. So where's your platform a pet? Can be probably caused by lack of portability, which might be caused by a cumbersome bootstrapping process, which itself might include some manual intervention. So I cannot create and export my platform onto other infrastructures easily. So how can you cattlefy your platform? Let's start seeing if we can manage it in a little bit of a different way. So some of you with Crossplane, well, that's my opinion. Crossplane is a Kubernetes native infrastructure as code with which you can manage non-Kubernetes resources as Kubernetes CRDs. And you can create CRDs without writing controllers. It also allows you to expand the scope of what you believe of what you think a platform is. So it does not have to be just within the constraint of the Kubernetes cluster, but of course as well all those resources outside. What does that allow you? It allows you to build a platform which is composable, it's modular, and it's versionable. It's composable because, well, it's something that I'm going to talk a little bit more about later, which is the crossplane compositions, which you all might have heard of already. I can bundle a bunch of resources together and treat it as a different resource, right? As the abstraction which I've built. It is modular because, well, as saying that you're bundling resources, you've already created, you bundle resource, you create a CRD, well, you can create that CRD also as part of another composition. So you can already get kind of like a hierarchy or like a nesting of your resources, which would be useful in many cases. Of course, for using Crossplane, you install Crossplane providers, and well, we're usually always thinking about the public cloud provider. So a provider GCP, I can create resources in GCP or in AWS, etc. But in here, I want to be talking about the provider Kubernetes. So I can create objects in my Kubernetes cluster. So in the same way that well, not in the same way, similar to how you would be creating. No, you get Argo CD, you give Argo CD the responsibility to create your resources. So provider Kubernetes, yeah, allows you to create resources in any Kubernetes cluster. It allows me to patch any resource with any field from any other resource. And that's a bit of a mouthful, but I will show a little bit later. And it is very powerful in combination with other Crossplane providers. And as well, I'm going to be talking a little bit on Cluster API, with which you can define the cluster as a Kubernetes native resource. You can deploy in different infrastructures, and it's not incompatible with Crossplane. Yesterday, I don't know if you were in the You Choose session here with Victor and Whitney, and we had to make a choice between crossplane and cluster API. So you might not always need to do so. And in my case, in the case of the use case, which we're going to see later, I was building this, deploying this on premises, so I don't have that provider GCP, which you might have. But cluster API can do that for me, so I can create cluster API and a cluster API resource, Kubernetes resource with the provider Kubernetes. So let's look a little bit into this use cases. So how are we currently provisioning clusters? So most of the times you're going to, well, first you're going to be creating this cluster. After that, there's going to be some kind of configuration of the cluster of other services which the cluster is going to consume. And at the end, you can deploy certain managed resources in the cluster, or your customers, consumers of the cluster can start deploying into there. But it is a lot of tools that you need for this, for building and maintaining pipelines, right? So I need to have a pipeline engine in which I'm going to run something like Terraform or other, so I will have multiple state files, which I'm going to have to store into a S3 bucket. And well, if I'm also deploying that myself, for example, in the data center, I also going to have a backup solution. So it's a lot of tools just to get the one or the few pipelines running, right? So there's also certain failures, right? So sometimes you might have the network failure, which just caused your pipeline to fail. Or there's race conditions as well, which you need to take into account. And as well, something fails, you're going to have to do the resource cleanup. So these extra things that you need to add, it's not just the pipeline, it's not just this process you want, right? There's so much more things that you need to handle in that sense. But what if I told you that there is another way? And it's all about abstracting your control plane, your tenants, your clusters, even your applications. You can create definitions, of what you believe an application is, what you believe a cluster, a tenant is. That's with the cross-plane compositions. So in my example, I created a bunch of compositions, which we're going to look at soon. And I have a control plane, which can have one or two, well, multiple tenants. Each tenant can have a bunch of different clusters within, and that can have applications within. Tenants, in this context, you could look at it kind of like a different department, a different team. It depends. It will make sense in your head according to, well, depending on your organization. But yeah, you potentially might have teams which have like multiple Kubernetes clusters, and if it's a certain department, they may need to consume certain resources, or the services have to be configured in a different way for depending on different departments, etc. So let's look a little bit at how what this look like. So I start with, let's say I have my two external providers, such as Vault, cluster, and counting cluster API as an external provider, just because of how my Kubernetes distribution is working. Let's say within my hypervisor, I have a cluster which has a cluster API instance, and I just consume from there. So I'm treating it as an external provider in the same way that you would have like a GCP there, also for the purposes of this presentation. So I actually start with Argo CD, because of course I have all my configuration, I have everything in Git. So Argo CD, I will install Crossplane, and I will start installing different Crossplane providers, such as the Kubernetes one, or Helm, so that I can install Helm applications in my cluster. After that, we give the responsibility to Crossplane. So Crossplane can start creating then other components which are part of my control plane, such as Keycloak to provide authentication services, have external secrets to pull secrets from Vault or any other backend, and I have Como plane, which we will hopefully see later if there's time. And that's a project from Commodore, so shout out to them for making a nice UI to look at the state of all your compositions in your clusters. After that, well, we still need some providers for this, for Vault, and I'm also going to be doing some provisioning on the Keycloak instance, which it's self-managed in this case. Of course, Keycloak could be outside, of course, as an external provider if it's managed by a different team. So the point is that in here you can adapt your platform the way you want, or the way that depending on the architecture, let's say, that you have at your customer. So sometimes you need to deploy and manage things yourself. Sometimes you're going to consume them from outside. So After that, I have created the composition of what I believe a tenant is. And a tenant, in this case, it's doing some configuration in the backend. So how am I consuming resources from the data center, as well as just creating one Vault namespace, one Keycloak realm, which then the different clusters from my tenant can consume. So the different department, right? Well, sometimes maybe it makes more sense to you, depending on your setup. OK, I want a realm per cluster, or I want it, like outside in like a tenant. So it's up to you. You have the flexibility to build your setup in that way. And then what I'm providing in the clusters, well, I'm providing crossplane as well, so that I can install certain compositions in it. If you define what your application is, then you can create it directly from the customer cluster instead of from the one parent control plane. And in there as well, I'm installing a bunch of CRDs, Nginx ingress. I have external secrets, DNS, etc. How am I doing the cluster provisioning? Well, like I said, I have an external instance of cluster API, and actually I have my management cluster, which is where I have crossplane running. I have external secrets operator running. So essentially, crossplane, it's targeting the cluster API instance to create a cluster, retrieve the kube config, and once all of that's configured, then it can create resources into the cluster. Again, this is very specific for my setup. You're probably going to be doing it a different way, like potentially having cluster API just in your main management cluster. So how do I define a tenant, right? In this case, I'm just doing very simple. Also for the purpose of this, I just saying what storage policy I should use and what let's say namespace in my hypervisor I'm going to be using. So that's as well. So the namespaces as well constraining resource utilization in the backend. And how am I creating a cluster? Well, I have a DT cluster in here. It's not just cluster because that's already a cluster API object, right? So I don't want to have resources called the same. It's called DT cluster. It's my API deepthought.magrathia.lab. I'm a massive Hitchhiker's Guide to the Galaxy fan, and I'm missing the talk at the other in the other room. So that was funny. And so in my cluster, I specify under which tenant I want it, and I can specify as well size of VMs and how many replicas do I want for that cluster. You can expose as many variables as you want to the consumers, to the person that's going to create these clusters, right? So we can now place clusters under our tenants, and this is really done through like a patching kind of strategy in Crossplane. You're not doing this very smart name convention across all your different Helm charts, or something, so that you get things working. But you can really relate your new CRDs, to each other. But it does not really stop there. I'm here talking about tenancy. I'm talking about like provisioning of clusters, etc. But you might have so many different use cases for which you want to create your own CRD. You bundle a bunch of resources like you would on a Helm chart, for example, and then let Crossplane create that. So how do you design such a platform? You need to define the abstractions based on organizational and developer needs. So you need to constantly speak with your developers and with your architects, with everyone, of course, to gather what does your organization really need. Because at the end, your platform, your developers should want to use your platform, right? They should not be enforced, and they're only going to want to use it if you're providing the services and capabilities that they want, not the ones that you want to enforce as a platform team. Of course, you're going to need to do some of that with the security guardrails, etc. But to me, that's not the main focus of the platform. So you need to listen to the developers' pain points and try to figure out how you can help them. And my recommendation would be to self-service those abstractions as Crossplane compositions. So what about the platform interface? So you already have an API, just a Kubernetes API, a database, which is your etcd, so you can do your create, read, update, delete operations on it. You don't need to create all of this externally. You already have a Kubernetes client libraries and can easily extend them for your new CRDs with like some kind of like code generation tool. So it's a really minimal effort in coding here. And of course, once you have this, well, you can just build a minimal wrapper around this if you don't want your developers to directly target the Kubernetes API. So actually, I'm going to go into the demo now. So I have this running on my lab. Let's see, can everybody see? I don't know, oh, that might be too small, right? Okay. So let me, yeah. Okay, so let's look at my first composition. So this DT cluster. Let's see what do I have in the DT cluster. What do I consider? So as I said, this is what's running on my lab at the moment. So it's not one-to-one, but I have mostly everything running in here. So I have a project cluster, a cluster kubeconfig, which I said I'm going to import after that. And apart from that, I'm going to have provider configs for Kubernetes, for Helm. So that is configuring my targets, right? So it's like utilizing that cluster kubeconfig so that I can after create Kubernetes or Helm resources in that cluster. I have a management namespace. I have a config map. I have some like initial client, and you can see I'm also installing Ingress and GNX and Crossplane, in this case. And I want to look a bit at what I mentioned before. That's not about this naming convention, but the patching strategy, right? So let's make this even a bit bigger. So let's say that this is your definition of your crossplane composition, which, as you said, you just have an array of different resources. And that can be directly, if it's any other CRD, so let's say you're creating an Argo CD application, you can create that directly. If you're creating a Kubernetes resource, like from the core, then you need to use this provider Kubernetes to create a wrapper around it. So this is this kind object. And in an object, I'm going to place, what you are usually used to, which is then I have here my cluster API, cluster, and then I'm specifying, CIDR blocks, like a cluster class, etc. Sizing of the VMs and all of that. So you have these patches, which, let me go back perhaps. Oh, spoiler alert. Oh, that might be a bit complicated to show like this. So you have these patches. So I can take from the definition of what I said a cluster is. So let's get the example. This mostly, as I said, it's not exactly that. So I'm missing in here the size of the nodes, etc. But you can pass, let's say, the values here for the tenant, right? So how am I doing this patching? On the patching which you can do on the on the provider Kubernetes, as I said, I can patch anything from any Kubernetes resource. I don't need to have a config map to retrieve a value from somewhere. So I can get it directly from the definition of another resource. So that's how I made the link between my tenants and my clusters. So you can see that I have these patches from. I am going to patch all of this definition of a cluster from the definition of from a kind tenant. I want to get like a storage policy, or I want to get a tenant name, etc. And you can see in here. Oh, I don't have a name. How's that happen? I want to be patched from a tenant, but I haven't specified the tenant yet. I specify the tenant here on the definition of my DT cluster. So you're essentially patching the patch, so as to say. And now let me show a little bit Como plane. Oh, sorry, perhaps also interesting to show. So, sorry, your CRDs. Yeah, these are the objects from the Kubernetes, from the provider Kubernetes. You're getting some information. So, what are you actually creating? Your kind, API version. What's the like meta namespace? Where is it going to be deployed in the other cluster as well as the provider? So I have like a bunch of local objects which are part of my control plane. And then as well, I have resources which you can see here, provider Kubernetes dev 01. So for the newly created cluster, I have a newly created provider Kubernetes. And just by creating the one DT cluster object, I'm creating the cluster and I'm bootstrapping it with Crossplane. And as well, you can see your your Helm releases, which you have deployed. I was talking about like Keycloak realms as well, so I have one here per tenant as well. And now let's look a little bit at Como plane. Again, really amazing interface I found. So you can see you have in here like your composition. So my control plane, my tenant, my DT cluster. So you can look at the YAML as I've just showed you now. But then, yeah, you can see your claims. So what instances have I created of those compositions, right? So I have my control plane. Let's hope it loads. Again, I'm running this on my lab, and I'm just like port forwarding, so connection might be a little bit flimsy. It's not a real data center. So let's see in here. Let's zoom in a bit. Oh, that was better. Yeah. So what is my control plane? You can see I have deployments for Cert Manager. Again, I didn't not want to include everything on the previous picture, not to clutter it, but I have Cert Manager, have external DNS running. I have secret stores, ingress, Keycloak. So just about everything which I need to manage my platform. And then after that, I don't have Vault running in my lab. So in this case, the definition of the tenant is just the Keycloak realm, as well as the constraints which is on a place in the cluster when the cluster gets created and it's referencing this tenant. And then we can look as well at what do we have in this cluster, right? So we have the cluster kubeconfig, we have this provider configs, and anything that you end up creating over there. It's very handy because you can as well look at just your statuses, any events which are happening, and of course again look at the objects which have been created. So again, well, this is a view of just every individual resource which you're managing with Crossplane, and you can as well, of course, see all the different providers that you have configured, and if there's any kind of issue going on with that. Getting back. So, takeaways. What did I learn? What was I left thinking after doing all of this? More CRDs are actually better in this case because Crossplane becomes more powerful. The moment I start defining my platform not in the constraint of my Kubernetes clusters, but outside, that makes it extremely powerful. And as I said, with the provider Kubernetes, I really recommend. I have a single way of defining blueprints for infrastructure and services in a composable way. I am reducing the amount of tools because I don't have to do these cumbersome pipelines anymore. I have one control plane to rule them all, and rule them all. That can be, you're not gonna go deep on that almost finishing, but you can have a control plane of control plane situation. So there's that. And not mentioned before, but you should be planning your data model accordingly. And what I mean with this is you're getting data for your cluster from your tenant definition, and the more resources you have and you're retrieving values from another resource, the more kind of spaghetti bowl situation you can get. So you need to be very clear about what is feeding into where. that was it for me. Thank you very much, everybody, for joining, and I would like to hear if you have any questions.
Do we have any questions? I see questions. I come.
Thank you for the presentation. I was just wondering, let's say you have 100 clusters to create, like how many CRDs are you going to get inside your main cluster?
Sorry, I cannot hear. Can you repeat a bit louder?
If you create 100 clusters, 100 tenants and 100 clusters, how many CRDs are you going to have in your control plane cluster?
Well, I mean, so it's still just the same CRD, right? So you have defined what a tenant is once. You have defined what a cluster is once. But then you're going to have, you said you have 100, then you have 100 instances of that CRD. You have 100 claims of your cross-plane composition. Does that answer your question? Yeah, perfect.
So I have another question. Basically, we saw the cross-plane definitions, but what about the copy concept called cluster classes? You already used this, but they also have patches you can apply, and you have all the possibilities to change by, well, the definition depending on your tenant.
Cluster class, yeah,
Yeah.
exactly. So in this case, this is still like a very simple kind of, well, demo in that sense. So I am only creating, you saw that I was creating a cluster and I was defining a cluster, just mentioning the cluster class, right? Well, you can create your own cluster class, which again, you might, do you want a cluster class per cluster? Do you want a cluster class per tenant? Do you want a cluster class per other construct, which you might make? You can, so you can define exactly what you want in that sense.
Okay, yeah. Just interested in comparison how it works.
Sorry?
Yeah, just interested how in comparison it works with cross-plane and how much you can scale those approaches. Because I felt personally that cluster classes are pretty much enough in many scenarios.
So I don't have, so I don't have that much, experience, like I said, with defining the cluster classes with it. Probably, something to look into.
Okay, any more question? Other than that,
There's one.
whoa, okay, sorry. Didn't want to.
How do you document all of the CRDs that you have available for the developers? So before creating a new CRD, a new composition, how do I define, how can I see which compositions are there? Otherwise, I can just create my own compositions that are very similar to my neighbor's compositions and so on.
You mean your own platform composition? Sorry, can you repeat?
I mean, I'm making a platform available for people to create compositions on top of.
Yeah.
Right? How do I make sure that the people that are creating the compositions, they know about the other available compositions so that they don't repeat the work that has been done by other people?
Well, how are you doing your how are you usually doing your documentation? If there's an API to how you can do your documentation, you can also add the definitions within your crossplane. You have a provider for your documentation provider. You can automate all of this as much as you would want, right?
Yeah, I mean, how have you seen that done? I mean, for Kubernetes, I can just point people to Kubernetes documentation, and there is the CRDs there. How have you done?
Well, I mean, you need to, of course, you need to show the developers what they are creating, and you might not need to show to them like what is exactly being created in the background, right? But yes, of course, they're gonna need to understand what this means for them, right? What this means in the context. So, for example, for an application, right? You can constrain an application. Let's say with the example of Keycloak, let's say that per definition of application, I create even a client, right? So I'm automatically providing kind of authentication services for the cluster, and just feed me an image, right? But you can also bring that further, and if you're doing if you're building the images automatically with something like build packs, etc. So that's different. Right now, I just need you to give me the code, right? So I'm not sure in the way of how you think, or what you asked, in terms of how I keep, with updating this. But of course, it has to become very clear to your developers what kind of objects can they instantiate.
Got it. Okay. Thank you.
Okay, then thanks, Carlos. And if you're interested in crossplane, stay here because we are now having a talk from Stefano about crossplane functions. So back to coding then. Thanks. Okay, hello everyone. This is back-to-back crossplane now, so we have again a crossplane talk today, and it's some kind of a Stan Lee moment because we have Jared Watts here joining the stage. He's, let me say, co-founding engineer of Upbound, so that's really, really awesome. So you get first the chance to ask any questions. So, and Stefano, of course, and we're talking about crossplane composition functions, so welcome.
Thank you. Yes, very excited to be here. Thank you. Yeah, I'm Stefano Borelli. I'm one of the solutions architects at Upbound. I've been there for 3 years, and just reintroducing Jared, he'll be co-presenting with me. He's one of the founding engineers of the Crossplane project. I think made the first commit.
First commit to the repo.
Right. So we'll be talking about Crossplane composition functions, which are, for me, probably one of the most amazing things that have landed in Crossplane in the last year. So just a little bit, I know we've been talking about, there have been several talks, but just a really basic introduction. Crossplane is an extension of Kubernetes that allows you to manage anything. And it's really ideal for folks who are building internal cloud platforms. All the abstractions that it provides, the architecture of it, it's a very strong fundamental building block. And really what I want to talk about too is the last 12 months of the Crossplane project, because we've had incredible growth and maturity in the technology. The first thing that we saw coming last fall was massive provider improvements, and these allow us to scale to tens of thousands of managed resources. So this was a big breakthrough for a lot of our largest users. The next one, this came out from a lot of talking to Crossplane users and customers of Upbound. We invested a lot in developer experience. And I know Jared's been very involved in that, making sure the developer experience. So the Crossplane CLI has gotten a lot of new features, everything from top functionality to tracing to being able to render compositions in advance. So the CLI has really improved. The signature feature of 1.14 has been Crossplane functions, which we're going to talk about today, and it really changed Crossplane almost to like a 2.0. It's really a major development in the platform, and it's really, we've seen among the people who we work with in Upbound, we've seen almost everyone move to functions within a few months. So it's been extraordinarily successful. And the last one, something that Jared is leading, we were a candidate for graduation in the CNCF. So we have a very strong case for that, and I think we're just waiting for the vote.
Yeah, one simple step, the TOC voting.
All right, so let's get in it. We're just going to do a couple of concepts of Crossplane. I'm going to talk for 15 minutes, and then Jared will talk. The first one is a managed resource. A managed resource is the fundamental building block of Crossplane. What it is we take an object that's outside the Kubernetes cluster, and we create almost something like a digital twin of it on the Kubernetes, right? And a managed resource is a high-fidelity representation of the remote object, right? So in the case of an S3 bucket, the CRD, we use CRDs a lot within Crossplane, is basically a one-to-one mapping of the remote API. Right? So this is the fundamental concept of Crossplane. Managed resources map one-to-one to some object that you're managing outside the Kubernetes cluster. The second big concept is this is the controllers, like we talked about CRDs. These are the APIs that Kubernetes provides. Providers are how we do things, and the way providers work is that the Kubernetes API server we leverage very heavily here. So your clients that are coming in to consume your platform go through the API, so all the things you have in terms of like controls, authorization, and things like that, those are managed by Kubernetes, so you have one platform API you expose. The second thing is that the controllers, they watch, right? So the way Kubernetes works is it handles a lot of the things like creates, updates, and deletes. So your controller, when it comes up, it just says, I am going to manage all the S3 buckets, right? And it watches, and then when someone comes and applies a new bucket, it gets notified on its watch, and it'll go talk to the AWS API and create it. So these are the two fundamental concepts, CRDs that map one-to-one to external objects, and providers that will reconcile, like the Terminator, to the end of time. Like they will continually try to get to that desired state that you asked for. And a real quick demo of this, and I have a bucket here. And you can see, I created this in advance because the Wi-Fi could be kind of a little unsteady. So what you see here is that when you create an object in Crossplane, it's a full Kubernetes object, right? So we have things like conditions. So like you're not running a shell script and examining the output. Every single managed resource has its own status and conditions and events. So you can see here we have transition times, and we actually have a lot of really good metric systems where we have a project called Xmetrics, where you could actually expose all this information to Prometheus. So you could have across all your clusters the amount of time it takes resources to get ready, the state of all your resources, right? So it's incredibly powerful that when we integrate this with things like Prometheus. You can see here we have two things. We have an at provider. This is what comes back from the cloud provider. And this is everything that when you provision something, it's going to, in this case, we're going to have a bucket. And then the for provider is what we sent. And we have things like annotations, labels, GVK, all the common things with Kubernetes, right? So this is what a managed resource looks like. So the next thing is, and this is good because I was speaking to another speaker here who is also Italian, and he was talking about, he's also going to use a food analogy, so I think. We want to talk about what do we do, because you've seen we want to build complex infrastructure at scale. Like we want to manage tens of thousands, hundreds of thousands of objects, right? And we want to provide complex things to our customers and have a simple API to that we give to them, but we want to have the freedom to be able to create complex things in the back. Like that they ask for a database and they just say, I want a 30 gig database, but in the back we're creating network security rules, default users, passwords, and things like that. So the best way to think about cross-plane compositions, which is what we use to make more complex infrastructure, is like a restaurant, right? Your menu, you as a platform engineer, is what you offer up to your end users, right? So this is what we're going to talk about. How do you create, the meals that you're making, right? You have a recipe, and then you have different ingredients, and then what gets produced out of that is a meal. Right? And then someone comes to your restaurant, they order it, and that's what happens. So in cross-plane terminology, this is what we have. So you're going to see composite resource definition and XRD. Anytime you see an X, that's a cross-plane composition concept. So the XRD, the composite resource definition, is your menu. Right? Those are the CRDs that you create. You just saw the talk that Carlos had right before us. He's creating a dev cluster or whatever for his tenants. You create that yourself, you apply it to the cluster, and you can create anything. You can use Open API. There have been some talks about Cell, so I've been looking at using Cell also for validation. So you could use Caverno, right? Like, so your clients, you could validate it, and it's all in YAML, so it's low code. The next thing is the composition, which we're going to talk about the functions. The compositions are what actually put all those resources together. And then the combination of this creates a composite resource, right? So when your user comes in and makes a claim, they're going to get attached to that composite resource, right? All the things they ask for that get mapped through, Carlos was showing his patches, that actually creates the composite resource, right? So I hope this is explainable because a lot of these composite, the wording is so similar to each other, this often gets confusing for people. But I want you to think in terms of the interface, the recipe, and the result of it. So, how do compositions create desired state? So a user asks for something, it goes through the composition, it comes out, we create all the resources, and then those resources are provisioned, they go back, persisted back to etcd, and then the providers have watches, and they create it. Right? So this is part of cross-planes architecture too. You start seeing isolation of responsibility, right? Providers are only responsible for doing provisioning, and the composition is actually combining the resources. So we use functions, right? So this is the big change that came in 1.14. We used to have the patch and transform engine, which is still in there, but functions are a really big breakthrough. So if you've used to like GitHub Actions or any other CI systems that are defined in YAML and they have like a pipeline, this is very similar. So this is what we do. Your user claim is going to come in. It's going to go through a function composition pipeline. At the end of it, there's going to be a series of YAML manifests that get provisioned, and those go out to the providers. All right. So functions, one of the cool things about functions that really makes them powerful is they're extremely lightweight. Like think about like lambdas for infrastructure. So they're very similar to Unix pipes. So in here I have a JSON manifest, right? And what I'm going to do is I'm just going to pipe it through JQ, right? Like with JQ you can actually add fields to JSON, and at the end of it we come out with something. So I'm just going to add a label to something, right? And this is the basic way that functions work, right? Like you take the previous step of the function, you mutate it or add new fields to it, and then you send it on to the next level of the function. And at the end of the pipeline, whatever's constructed goes out to the providers, right? So functions, and if you're using one of our SDKs, functions, a lot of the internal workings of gRPC and all that stuff is hidden from you. All you need to know is, can I manipulate a map? And I have another example of this. Let me see here. I have this little pipeline.sh here, and what you see here is I'm just doing 2 JQs in a row, right? Like I'm saying I'm adding a label and an annotation. This would almost be like running 2 functions in a row, right? Like you take the output from one and you put it into the next one. And if I did something like, pipeline sh in basic, here, you see we'll add a label and an annotation, right? So this is the foundation of how functions work. Obviously, we have a little more complexity to it, but if you can do this, if you could create YAML in this way, or JSON, you could write a composition function. All right. I'm just going to leave this slide here just because one of the really nice things about functions is you could either write it yourself in Go, or you could use built-in ones like for KCL or Q or Go templating. There's a bunch of different languages you could write them in. So you have a vast swath of complexity that you can work with. All right. Just something really simple here. This is an example of a Go one, and a lot of Go functions are small. But what I want to point out here is if you know anything about Go, this gets invoked by the SDK, and there's only 2 things you have to do. You get a run function request, right? That's your structure that comes in, and you return a run function response. So this is the internal workings of a function, right? So as long as you do that, this is a very small one. You're just returning it at the end. You take the structure in, you modify it, and you pass it out to the next step of the function. That's it. So most Go functions are like a single code block, and they're usually 100, 200 lines of code at most. There's Go templating. Like if you ever used Helm, this is like 95% the same. You could just like have Helm templates that are rendering things with loops and conditionals. There's KCL, which I'm about to demo, right? So KCL is a new kind of configuration programming language that is in the CNCF right now, and you can see here what we're doing is we're creating VPCs and gateways. So yeah, let's do that. So I am going to demo KCL, like using KCL on a composition function. And yeah, the repo's here, and obviously we'll publish all the slides. So what I want to show here is I have a KCL composition. If you saw before, Carlos was showing a little bit, it looked a little different. So what we have here is we have a function pipeline, and the first step is to render with KCL. And what we're going to do is we have our input, and you can see here, we just have the programming language in there. So here we're going to get some fields, and we're going to read the parameters that come in from the user claim. And then what we're going to do is, based on the count, we're going to loop through and create VPCs, right? And the same thing for API gateways, and we're doing some matching here because the way Crossplane internally can match gateways to VPCs, we could do dynamic selectors like you can with other Kubernetes resources. And at the end of that, we're just going to get the VPCs plus gateways and just send it back onto the next of the function. And the next function we have is something called auto-ready, which just makes sure that all the resources are working. So what I could do here is I can actually, if we're looking at this, this is one of our new tools that we have is called Crossplane Beta Trace, right? So what I'm doing here is on the command line, I'm just watching this, and I created this in advance, but we have a gateway, and you can see how it's structured. And what I could do is I can come here and change like the XR with gateway, and I can make it say 4. If I do XR with gateway, right? So we just configured immediately there, and then the function should pick it up, and it's going to start rendering all the extra gateways, right? So when we talk about multi-tenancy or building up lots of things, so the functions work automatically. So that is a really brief introduction. So obviously, there's Q that Elastic is developing. We have a Q function too that we can use, and there's someone at this conference who's working on a pickle function, Apple's new configuration language, so we're very excited about that. So the ecosystem is really growing very fast. This makes Crossplane incredibly powerful, and you can see these are all available now, right? We can track it in real time, every event, so you're not like waiting 20 minutes for a state file, every resource is provisioned individually. So that is the end of mine, and I will pass it on to Jared.
All right. Thank you, Stephen. Let me get plugged in here real quick. All right. Hopefully it'll remember that I told it to mirror my display. Oh, yes, it did. It seemed to. All right. Cool. All right, so Stephen was showing everybody, all right, what Crossplane is, what compositions are, how functions work, etc. So now we're going to go into the steps of actually how to build your own function. I think this talk is called something like Crossplane Functions Step by Step. Steps. Let's get to steps. So I think a big takeaway here is that there are a bunch of new tooling available. within the Crossplane ecosystem to basically help you get your platform built and do it quickly, right? And so just going through 1 to 5 here, we'll walk through them all for real. We'll basically start by using the tooling to scaffold out or initialize a new function project. And then number 2, that's the part where it's like unique to your needs, your organization, your platform. You know, Carlos is showing us his platform. He built something unique to his needs there. That's where you use your language and your choice, your tools of choice to write the code that's unique to your organization. And then that's, you know, the part that's specific to you. After that, then you use more of the tooling to go in a local development iteration loop, you know, on your laptop. Be, you know, testing it, you know, seeing there's bugs, fixing things, keep going, right? So then once you feel like you've got it working on your local laptop, you can use the tooling to go ahead, package it up, push it out to a registry. A Crossplane package is really just a, you know, OCI compliant image, so nothing too fancy there, and then install it into the control plane. That last one's maybe misleading because like it's really all that tooling is doing is applying a function manifest to your cluster. Everyone just does that through GitOps, so you probably don't use the tooling for that one. All right, but let's get into the actual demo here. So we're in the same repo that Steven had us in, and let's go ahead and hop over to that here. And so I'm going to copy and paste some stuff and talk about it, so for speed here. So basically what I'm going to do first is I'm going to go ahead and you know, initialize this new repo here. I'm going to say I want to write a Go function. So go from the template for Go functions and put it into this directory for me. Cool. Looks like there's some init script in that repo for me too. I'm not just going to run it. I'm going to look at it first. What does it do? Oh, cool. It looks like it just like updates the go.mod and my function stuff and the imports, whatever, to customize it from the function name I've granted. Yeah, so I'll run that. That sounds good. Yes. Cool. So now we have a function set up, basically. So let's go ahead and, in another tab, let's run the function. So it's actually up and running and can listen to requests and send us back responses. And then in this other tab here, let's actually look at this thing. So was it XFN demo, I think it was. So yeah, let's load it up here, Visual Studio Code. So 3 main things to look at here real quick. So we've got a main.go for this program. It's basically going to start up a function server that's going to be sitting there and listening to requests and sending back the responses from our custom code. We've got the function body here, which Steven kind of showed a slide on there, right? Where this is the unique logic in our function is inside here right now. This is the templated one. It works, but it doesn't do anything particularly interesting yet. It basically reads in the request from, you know, coming from the user, you know, Crossplane sending it to us here. It's, you know, reading in that input there, and then it's going ahead and logging something out and returning a response that everything was okay. Then the last important thing to look at is that, you know, we need a composition to pull all of this together, right? So here's a simple composition that basically has a function pipeline that has one step of run our function, right? This is the one we're running right now. So run the function in this composition, get the and send this input to it that I have here, and then get the result back Crossplane. So we are going to do this all locally because you know, we want to get this, you know, in a tight development loop, right? We want to do this on our laptop, make sure that everything's working. So let's just copy this real quick, and let's go to CD example, I think. Now let's run this render function here. And what this is doing, right, is it's using the Crossplane tooling to go send a request from Crossplane to our function and get the result back. Nothing particularly interesting yet, right? We said hello world. Okay, cool, that's nice. But let's start modifying it, right? We are a developer. We're going to start changing things here. So as a platform engineer, I'm taking this composition, and I'm going to say, OK, I'm going to pass different input into this function here. So like Paris Rejekts. Hello, Paris Rejekts. Oh, I misspelled that. I added that to my user dictionary, too, so it doesn't correct me anymore on that. OK, cool. So then we should be able to run it again. And what we should see this time is that, you know, we've changed the composition, we've changed the input that's going into the function, and the function returns something back different, right? Hello, Paris Rejekts. Still not that interesting yet, right? Because we're just modifying the composition itself. We haven't actually changed any of the code, so it's still not really doing much interesting stuff. So I'm not going to type this code in front of everybody. That would definitely take way too long. It'd be too error prone. So in our little demo here, I'm just going to quickly grab this code, throw it there. And then I'm also going to basically, I'm going to do a go mod tidy because I've got some new imports. And then I want to go ahead and essentially Yeah, run the function again. Okay, so the function's up and running with our new code. What is this new code that we have here? Okay, now this is going to do something sort of interesting. So here in Crossplane, we're using Go code to dynamically compose resources of real infrastructure in the cloud. We're going to do that with Go code using our tooling, doing everything that, linting and compiling and verification and unit tests and all that sort of stuff. Right now, we can write logic and code that does real things in the real world with infrastructure. So basically what this does is this creates an S3 bucket programmatically with this Go code. It says like what region it should be in, et cetera, and then it go ahead and returns that back to Crossplane saying, hey, the desired resources here, I want there to be this bucket in Crossplane. This is desired now. Please go make that happen in the real world. So that's essentially what this code does here, is it programmatically creates an S3 bucket and then sends it back to saying, Crossplane, please make this happen in the real world. So once again, we can use our tooling. With that new function running, we can use our tooling, and instead of returning back a hello Paris rejects or hello world, it's now returning useful stuff. It's returning this actual S3 bucket. Cool, that looks nice, but I mean, is this right? Like, I don't know, it's running on my laptop right now. It's like this, it could be totally wrong, right? So more developer tooling in Crossplane to build your platform successfully and quickly is, let's grab this real quick, and a little extra file here. Yeah, let's drop it right here. So basically in this file here, I'm telling Crossplane where to find the schemas for all these resources. S3 bucket is in the S3 provider for Crossplane. So I'm just kind of telling it where the schemas live. And then now we can do some enhanced development flow where, let's see, grab this one here. So basically, now we're running that same render again. We're running render, send the user input to my function, execute the function, return it back. Now, do something with that output. So we're going to pipe that output into the Crossplane validate command. And so that will be like, okay, let me look at this thing. You got an S3 bucket. Yeah, that's compliant with all the schema. There's no crazy fields, so nothing's wrong, indented wrong or whatever. This is a valid bucket. So we've taken this whole workflow here and on our developer laptop, kind of started building a platform. Didn't have to do anything in the real world. We got some validation that it's actually correct also. We did it all with code. So one last quick thing to show is that if you're not a Go person, that's totally reasonable. You also have a SDK and function implementation in Python as well. So Python demo. Let's just open up Visual Studio Code in there. So yeah, if you're a Python person, which I'm not, you would see here that you've got like the main entry point for the Python function. It's going to go ahead and start up a function runner, function server as well. And then here's your main entry point. No, I don't want Python extensions. I don't do Python. So then here is the same similar thing that we saw in the Go function. It's a Python function to write your own unique logic for your platform, compose resources together. Do that in Python. Use your Python tooling, whatever that is, and you can be happy with Python now too. All right, that was super, super quick of going through all the code and all the steps there. So it's really, really important to, I think, reiterate these key takeaways, I think, from what functions do in Crossplane. All right, two super important things. So one, with functions now in Crossplane, instead of the regular patch and transform logic that Carlos was showing us in the last talk, so Crossplane is way more powerful now and way more flexible than it ever was before. You can literally do things that were impossible before in Crossplane. There's a long-standing request to, hey, Crossplane, can we add this extra logic to your patch and transform composition, add this, add this. Instead of bolting that all on together, we've kind of given you the opportunity to use your language, your tools of choice, do it exactly how you want to. And then we've seen the functions ecosystem really start taking off now. So there's a function for almost a lot of things now. The other super important key point here, though, is that before functions, you had to take your manifests, I want to create an S3 bucket, an RDS database, this, that, and the other. You had to take all those and then to test them, go apply them to a real live cluster and create real resources in the real world and see if they worked. Not particularly effective or efficient or a lot of things that's not good for. So now, as we saw here, I didn't touch the cloud. I didn't touch the real world at all. I just used, on my laptop, being able to do all this local development stuff and rapidly iterate. Get this thing to correct, get this thing to production ready, and then, put it into the real world. So that is I think, a great accelerator for if you've like worked with Crossplane in the past 3-4 years. You might have had that pain point of, cool, I'm going to try to create an EKS cluster. 30 minutes later, it didn't work. All right, I'll change this one line in my composition. Try. Yeah, you're laughing. You did it, I think. So it's way, way faster now, way, way better. So much, much more improvement. All right, lightning round. We've got a lot of functions that have been written now. Let's see some of the ones, like what do they do? Here we go. First one, filtering with common expression languages. So we see here we've got some patching and transforming stuff that's creating a DynamoDB table, a S3 bucket. And then the second step in the function pipeline here is being able to use common expression language to filter out resources. So hey, let's not create that S3 bucket unless the spec for this, the user has said that they want to export to S3. So have a function for that. Filter stuff out. Conditionally create resources. Cool. We can use Q now. So here's some Q script stuff to basically dynamically build up and create IAM policy objects with various configuration information flowing in. So if you're a Q person, you want to build your platform with Q, you can do stuff like that now also. Here's the kind of interesting one, resource sequencing. So typically in Kubernetes, the controllers, eventual consistency is awesome. Try to create something, try to create another thing that depends on it. They'll figure themselves out as they're actively reconciling and driving towards eventual consistency. Not always the case. Sometimes if you create something that depends on another object, like if it might fail if it really needs that object to exist, and get into a terminal failure state. If that happens, no worries, there's a function for that. You can go ahead and say, hey, there's this core, I advanced the slide. There's this core resource here, and then there's these other resources that depend on it. Hey, second step in the pipeline, the sequence function. Go ahead and make sure that core resource is created before the second resource, and that core resource is created before the third resource. Don't even try to create those resources until core is done. Another one, environment information. You all may be familiar with environment configs, being able to specify general information about the runtime environment that a cross-plane control plane is going to be running in. There's a function now to select, merge, pull all those together, and then pass it to subsequent steps in the function as well. So this is an example of that, getting the environment configs, passing it to a Go template function. Last one. This is from the community as well, where this kind of enables you to turn on and turn off resources that are inside your composition. But it's kind of elevating that up to the consumer's level of when the consumer is creating an object that will invoke a composition that will compose resources together, they can have a little bit of control over which objects get created as well. So the point here is there's a lot of functions. Ecosystem is building a lot of them. Next goal function, maybe it's one of yours. If you're building one, feel free to reach out and we can collaborate on it together. That's awesome. But to do so, get involved in the Crossplane project. So here's all our links, crossplane.io. We're on Slack heavily. And then final thing is if you are using Crossplane, we want to know about it. It definitely helps our graduation proposal, and that's all we got.
All right. Thank you, Stefano and Jared. Any questions?
Thanks for your talk. I have a very quick one. Can you go back to your demo and try to inject an error in the validation? Like when you validated the S3 bucket, for example?
Yeah.
I know it's a tricky question, but I would love to see how you handle the error.
Yeah, I think so. There's maybe a couple ways to do that, actually. So one really important point here, I think, is that because we're using our language of choice and we have all the tooling like up front before you even get to Crossplane tooling, I could be like, okay, cool, let's try to do like foo, this string, I don't know, whatever. And like, oh, we've got a red squiggly line because foo is not a part of an S3 bucket. You can't do that. So before we even get to Crossplane validation tools to run against the schema, like you're already linking or importing against the Go modules for S3 buckets and all the AWS, GCP, whatever objects. So in your environments, with your tools of your choice, you can get a native feeling experience about you're doing something wrong.
Okay. Cool.
I hope that answers the question because it's like shift it all left, right?
Yeah. Otherwise, I would have said like put US East 5 or something, a region that doesn't exist.
Right.
Or whatever.
Yeah, you could actually use open API definitions and cell. Like if you have a manifest, like a cell manifest, you could add it. You could validate against it in Crossplane Validate.
That's nice. Thanks.
Yeah. Really good question, man. All right, running out of time, maybe.
Any questions?
Thank you. Hello. Thank you for the talk. Are functions going to replace the cross-resource definition at some point? Because we could like do the composition directly in functions. I don't know if that makes sense, but
Yeah, so I think a good way to think about functions is that it is definitely like the way forward of creating and defining your platform and composing resources together. You still will need to like define the abstraction that you're offering to your developers. So like the composite resource definition, that's not going away at all. Like that's like defining the API, the shape of your API for your platform. But like the way that you want to compose things inside, you could still do things with the native patch and transform and the way you've always done things. Like you can do that because there's a function for that too, so it mimics the same experience. It doesn't change it at all. But then you have all this new world of code and scripts and functions to do stuff for you that wasn't available before. So it doesn't really replace it, as in you can't do that stuff anymore. You can do more stuff now.
Okay, I have a question, Jared. To make a specific certain demography happy, when is the REST SDK coming? Or is there a Rust SDK?
Community contributions are definitely accepted.
Okay. Thank you, and stay tuned for a cool Jenkins talk. So. Okay, every time I think a rocket starts, but okay. Welcome back, everyone. Last talk before the lunch break, and this one is something I'm really excited about because I started my stuff with Hudson Jenkins classical way, so I'm really curious to see how Oleg is going to explain how we can bring Jenkins to the cloud. So I say welcome Oleg Nenashev, sorry if I said it wrong, with the talk Cloud-Friendly Jenkins.
Thanks all. Yeah, so before we start, who has ever had any experience with Jenkins? Most of the people here. And for many, it was 5 years ago, 10 years ago, before Cloud Native, Argo were a thing. But imagine the irony. It's just 30 minutes before the launch, and you cannot go there because there is Jenkins discussion. So let's start. Today, I'm actually going to talk about cloud-friendly Jenkins. I'm not really going to talk about cloud-native Jenkins or how we can make it cloud-native. My name is Oleg Nenashev. Actually, I spent more than 10 years in developer tools and ecosystem. I started with Jenkins. Now I'm test containers, YAML co-maintainer. And I also work on many projects. And I've recently joined Gradle to help with developer ecosystem, experience, and community building. And there is a lot of slides, but you can find slides there. So I won't be spending too much time, and there is quite a lot of background. One thing I want to discuss today is actually that for most of the services, you do not have to be cloud native. Maybe I will be expelled from the CNCF ambassadors programs after that, but I think that cloud-friendly is actually enough for the most of the use cases. I spent a lot of time in different communities, and actually among them, none of the projects except Open Feature has ever had to be cloud native, and many of these projects have a lot of relation to the CNCF ecosystem. So what I'm talking today definitely doesn't represent my employer. It doesn't represent the official position of the Jenkins community. We do not have official position on that matter for what it was. Any contributor is welcome to share their opinion. And I'm not representing any vendor there. And another thing, my slides and my information might be dated because I have been on sabbatical in Jenkins since 2 years ago. And yeah, I plan to be back. So, okay. Yeah, this is the second iteration of this talk. Oh, now it works. Yeah. Have you ever been to Bilbao? Probably you should. There I present this talk first time, and actually, if you meet Bart, he's from Bilbao, he's organizer of CNCF Meetup, and he makes great cookies. So ask Courtney, who can confirm it from the recent experience. And this is a great meetup to be at, and this is a great city to visit. And yeah, there we discussed cloud-native Jenkins. There we had quite a lot discussion at beers and pinchers, which is again a great thing to do in Bilbao. And one of key takeaways was that actually nobody really thinks that Jenkins should have been cloud native from the experience. In the Russian language, there is an idiom like a plywood over Paris. It's not exactly clear what it means, even for a Russian speaker, but you just miss the opportunity. Je se valais Paris comme deux contreplaques. There is, when I say to French people, they do not understand me at all, mostly because of my French, but still. So it's definitely me missing kubecons, and it's definitely Jenkins missing kubecons. I have no idea what happens, but yeah. So yeah, Jenkins has been always rejected from kubecons. We had quite a lot of coordinated applications, and most of the time Jenkins wouldn't be accepted. Same for this talk, but I think that for Rejekts is actually quite reasonable. So yeah, this is what I said in the beginning. Being cloud native friendly is actually a must, and what we want to discuss. So do you agree with this statement? No. Do you know what cloud native actually means? Because there are also quite a lot of opinions on that. And today we will magic. Yeah. So today we talk specifically about Jenkins and experience, and I will just do a really quick background. Okay. Yeah, I really have no idea. Maybe I should have changed to the PDF, but yeah. I talked on evolution of continuous integration, continuous delivery many times, and every time we talk about different generations. Let me just restart the presentation, maybe it helps. Okay. So yeah, there are multiple generations of CI/CD tools on the market, and of course, these generations have changed a lot since the last time, because there is a lot of demand on the market, like CD, DevOps, now platform engineering. All of them come from different use cases, demands, architecture expectations, the infrastructure changes too. So all the systems operating in CI/CD space have to also change, and yeah. I have no idea. Let's try again, because there is no animation there. It's just plain slides, but yeah. Okay. So yeah, Jenkins, as well as other tools like TeamCity or Azure DevOps, GitHub Actions, have been evolving along the new requirements, the new expectations, and they try to catch up. So some tools die off, some tools continue evolving, everything is okay, and all tools currently try to switch to 5th generation, which is what we normally talk at events like KubeCon. So for example, in the case of Jenkins, we introduced quite a lot of new features like pipeline as code, configuration as code. There are modern distributions, including Helm charts, separators, and there are public distributions for all the platforms. So supposedly we are a match for the modern environments, and supposedly if you run Kubernetes on Google Cloud, you should experience no issues. But of course, it's not exactly true. Because just going to 5th generation doesn't mean adopting the infrastructure and making it possible to run there. It actually also means that adopting the mindset of this infrastructure. So when we talk about 5th generation of tools, usually I say that it's Unix way, but in the cloud. So each tool is modular, like a microservice or not a microservice, but they achieve a particular goal. And we rely heavily on integrations, on encapsulation of tools. So you put everything in the container. You don't care what technology is used under the hood. You expose open protocols. And basically, tools interact with each other as building blocks. Yeah. No surprise. Yeah. But yeah, Generation 5 has a lot of great examples. Of course, it's Argo, Tecton, Dagger, GitHub Actions as open ecosystem is also 5th generation for me, Flux, Artilius, and many other tools. They evolved in the same way. All of them are great in the area. They do not try to go in another area. Instead of that, they integrate with tools. So there is a lot of open protocols like Cloud Events, Open Telemetry, etc., that actually address the use case. And for example, if you take Tecton or if you take Dagger, it's just a pipeline engine. It's a commodity, but it does this thing well. It might be fully cloud native, might be adapted, but it's the use case where it focuses on. For Jenkins, the situation was a little bit different because Jenkins itself has been a big framework that included a lot of things. So it was out-of-the-box solution. So if you use GitLab, everything is there. And it's great. If you use GitHub Actions, everything is also there. But if you need to add something in addition to that, then your problems start. There are plugins, there are actions, there are compatibility issues, and this is what created a lot of issues. At the same time, there are new demands, and we want to transition our infrastructure there. And in Jenkins, our approach was that we want to have a general-purpose CI/CD engine, so basically Jenkins as it was. Personally, I call it an automation server, but yeah, this is a statement of the founder of the project that would run on Kubernetes and embrace different architecture, but retain all the extensibility you had with Jenkins. So this was a statement for cloud-native Jenkins project we wanted to build. And of course, we clearly understood at this point that it's not just providing Jenkins in a Helm chart. There is a lot more. And there were multiple approaches. So our definition of cloud native was, firstly, providing best service for each need. at the same time, it would be compliant with CNCF definition, so it would be pay-per-use, it would support infinite scaling and scaling down to 0, so that we could release resources. At the same time, it would release easy to use, easy to maintain, and fast to develop. Well, these are great goals, but any developer could feel some contradiction there, right? This is what everyone has to choose, what you prioritize among these goals. And we had a few projects where we tried to do different priorities and got to very useful, quite well working results, but they have not been actually a replacement for Jenkins. What do I even mean here? Oh, yeah. Classic Jenkins architecture, so there is Jenkins controller, it has web UI, it has permanent agents, or now it can have on-demand agents. So agent part of Jenkins has always been cloud native. The problem for us was actually Jenkins controller. It was heavy. It included basically all the backend part, all the storage interaction, also front end, plugin engine, and it had a pipeline context. So everything was in a single instance, and this single instance, of course, became a point of failure for any additional use cases and applications. And when we talk about Jenkins stability, it's mostly about Jenkins controller, because it crashes, it needs 1 terabyte of memory to process your coverage report, et cetera, et cetera. So depending on the use case, depending on the imports, you would experience different issues that normally in a cloud-native tool wouldn't happen. Because you have a container that processes a report, it crashes, okay, we apply failover, and everything works again. But Jenkins became a single point of failure, and this is not something we wanted. So for Cloud Native Special Interest Group, which was founded in 2018, the main objective was to actually decouple and re-architect the Jenkins controller so that it actually become more suitable for running in cloud environments. It includes not just having shared context or having a bunch of microservices instead of one, but actually having an approach that would be resilient, that would be highly available so that we could upgrade instances, replace instances, which wasn't possible in common Jenkins. And this group was around for 5 years. At the moment, it's archived, but many of the results are there. And other groups like platform group continues working in Jenkins. So in fact, all the stories continues. What stories did we have in this group? Pluggable storage, Jenkins X, maybe some of you remember it, configuration as code, open telemetry integrations, cloud events, support for multi-tenant controller, et cetera, et cetera. So there were a lot of projects. Some of them succeeded, some of them not. And I would like to just share key takeaways from this project. So first of all is Jenkins X. So this project at the moment continues as a continuous delivery foundation project. It's a separate project with separate governance. There are still several contributors who keep pushing it forward. But initially it started as an experiment in Jenkins, which tried to address these cloud native Jenkins ideas. And the idea was to build a quite opinionated solution that would provide out-of-the-box CI/CD for common application use cases. So there would be big build packs implementing continuous delivery, for example, for your Golang applications, for your Spring Boot applications in Java, and many such common technology stacks. There would be everything provided out of the box, including support for staging environments, including integrations with IDE, developer portal integrations, and it would be a tool that would just work. Under the hood, at the moment, it has 3 pipeline engines. There was quite a lot of drama around that because it started as basically just a classic Jenkins engine. In Jenkins 2, they removed it, left only Tecton, and it didn't quite fly because while Tecton is awesome, it didn't achieve any of expectations of Jenkins users who wanted to migrate and have some level of compatibility. So in Jenkins X3, they actually reverted it and made Jenkins pipeline, Jenkins X pipeline engines pluggable, and at the moment, 3 engines are supported. Classic Jenkins, Jenkins File Runner, and also Tecton that you can use. And if you want to connect something else, like Argo pipelines or Dagger, you can also connect it there. It's just a small matter of programming. The problem for us, while Jenkins X didn't fly, there were a lot of problems, but the key problem from the Jenkins community that it was too opinionated. And the reality was that many of people were excited about Jenkins X. So we have Mauricio in this room, and a few other people who actually contributed to this and pushed it forward. And it was quite successful in the cloud-native space and use cases. But at the moment, it didn't address use cases of 98% of Jenkins users. And basically, this is why it was rejected as not a Jenkins replacement. It still continues, but for us, it didn't quite work. For me, the key problem was that Jenkins X wasn't actually a general-purpose CI/CD engine. So it wasn't Jenkins, it wasn't framework. There are advantages, disadvantages, but for us, it wasn't a solution we wanted to get. So we had to continue the search. And another thing in the Jenkins community was, OK, what if we just made Jenkins controller on demand? So instead of having this big Jenkinstein who provides all the context, who runs continuously, who eats up all your memory, who sometimes needs to run on virtual machines. So what if we make it on demand? And there were a few examples how we split it up to multiple microservices, etc. But another approach on the table was to actually, why do we even need a controller? Instead of that, we could just have a pipeline execution engine that would be triggered on demand, that would execute pipeline, report all the results back, and no controller. After that, you connect it to whatever hypervisor, for example, to Pro, to GitHub Actions, etc. And you can just use it as Jenkins. You can get quite a lot of Jenkins capabilities. But at the same time, there will be no permanent controller at all. And you would be able to package controller with all the plugins, etc., because for us, it would be just a Docker image that you can run anywhere. So this was Jenkins File Runner. And yeah, this project is available. It keeps evolving. So it takes Jenkins file, your workspace, configuration files. Then the magic happens. It executes pipeline, and it returns the results to std out, to workspace, or to external storage. So there are plugins like S3 artifact storage plugin, which you can embed into a Jenkins file runner, and then they get uploaded to your destination. Or the same, if you want to use secrets, you don't have to store secrets in a Jenkins image itself. Instead of that, there is Kubernetes credentials plugin, which you also connect, and everything works out of the box. So this idea was quite good, but it also didn't fly. And why it didn't fly? Because it wasn't Jenkins, again. For us, one of the issues was that it wasn't a CI/CD solution on its own. It was just a pipeline engine. And there is a great difference between these parts, because pipeline engine executes your workload. It does something, it returns the results. But it has no reporting capabilities, it has no storage capabilities, it doesn't really have user authentication, authorization, integration with other tools. So you have to build everything around this to get your CI/CD system. And when you just change the engine, yes, you can do that, but then you have to build all the harness, which can be done, but it takes a lot of time. Also, there was no web UI, there was no queue, and there was no build throttling or whatever. So, and it was designed for a single container use. While there were opportunities to connect agents through Kubernetes plugin, etc., this approach also didn't work. And one of the key reasons is that we had no foundations, like pluggable storage, that would actually allow to implement that in a Jenkins compatible way. So at that time, for example, we had no way to build logs and build results somewhere outside Jenkins. We had to hack the file system. We didn't have job storage, log storage, fingerprints, etc. And this story and many other stories basically killed the project because it became really impossible to implement all the things at the time when this prototype was viable. So basically, it didn't fly. And main takeaway for you, if you really consider moving your application, don't forget about architecture debt you accumulated, because then at some point it will come back. Another project we had is Jenkins Operator. Who has ever tried it? No, nobody. But yeah, Jenkins Operator was a project started initially by the Virtuous Lab. It's a company in Poland. They created a service for Microsoft Azure that would be Jenkins SaaS. This is just a concept of how you could use it, but actually this is an operator that provisions your controllers based on a bunch of YAML file and CRDs. So nothing really specific in the cloud-native environment, and then everything should somehow connect there. This approach worked actually quite well, but there were some issues that didn't let it to succeed. Firstly, there were two operators, one by VirtualLab, another one by Red Hat, and these operators competed with each other, and we were too late to introduce community governance and get everyone working together. So by the time we started doing on that, none of initial contributors were actually interested in that. So basically, the project got stale. And at the same time, Jenkins core vendor companies, they also didn't invest in that because we were doing Jenkins X and other stuff, and basically we had a few engineers working on Jenkins at the time, which created quite a lot of issues. So again, architecture killed it, and also investment of resources. Another thing that we saw there is that basically you don't have to scale to zero because it's actually a better approach. In a CI/CD system, which continues working all the time, it always receives some events, it always has some users hitting endpoints, accessing storage, etc. It doesn't really worth to scale your instance to zero. Scaling to one, scaling to something small makes sense, but to zero, no. And when you put effort in that, most likely this effort won't pay off because a lot of architecture complications, to have a watcher, to discover all the APIs, to provision, but in the end, it doesn't need. So we tried a lot of projects, and these projects didn't work as expected. And by now, we don't have Jenkins successor, and voila, in 2024, Jenkins installation numbers keep growing, and Jenkins keeps holding more than 50% of the CI space. And with all the improvements we do in architecture and developer experience, etc., it's actually quite reasonable. What I want to say, did we fail? Actually, no, but we didn't succeed either, because none of Jenkins replacement and cloud native was successful. And my key takeaway is your users don't actually care about infrastructure. So if you try to sell cloud native to your users, you will fail. Instead of that, you actually need to say benefits and what they need. For most of the cases, they just need green check boxes, and they do not care from where it comes. Developers is what you have to focus on, so no, same as everything else. Oh, yeah. And they don't have all this house of cards. They need something stable. They just use it. They don't want to do platform engineering at all. We talk about platform engineering. We have a lot of professional information, but our users don't care about that. They just need green checks. So if you can build something that is friendly to your users' cloud-native environments, then it should work for you. And for our takeaway, so it's not being cloud-native, it's being cloud-friendly. So scales is needed, best for your needs, and easy to develop and maintain. So this is what I perceive as Jenkins, and this is actually quite a lot that's happening at the moment. So you can check out in the new developments, like high availability Jenkins announced by CloudBees, which is actually based on quite a lot of multi-tenant approaches, etc. So if you're interested, chat to me after the presentation, and I'm happy to discuss that. And yeah, all the interoperability is what you need for your projects. Because instead of creating a lot of stuff, do generation 5 and do a lot of integrations. So in Jenkins, like OpenTelemetry, Cloud Events, Tecton plugin, et cetera, so there is quite a lot of stuff that is ready and quite a lot of stuff that you can check out. And in your projects, this is also something I would highly recommend to do if you develop a new service. Do not waste time in creating functionality that is already available in the cloud-native ecosystem. Instead of that, join existing CX like OpenTelemetry, et cetera, and work on integrations with other tools. And basically, yes, this is what I wanted to say. So do be cloud-friendly, don't care about scalability, focus on developer experience, and yes, pay your architecture debts like Lannisters. That's it, and of course, it's always a great time to contribute to any project. Any questions?
Yeah, thanks, Oleg. Do we have any questions, or is everybody so hungry and wants to leave for lunch? If no question, then I want just to backtrack on one thing you said with our customers don't care, and this is really true. They just want that it works. They don't give you props how sophisticated you did, so completely agree on this one. So, last chance. If not, then thanks, Oleg. And for everybody else, have a nice dinner, and we see each other, I think, around 2 or so for the next second part of Rejekts. Bye.
Yeah. Thank you, and bon appetit.
Excellent. Welcome to our talk today. That's called External Traffic Engineering with Cilium. My name is Michael Kashin. I'm the product manager for networking and security at Isovalent.
And I'm Piotr Jabłoński, Cloud Solutions Architect at Isovalent.
All right. Let's first have a look at the agenda. And these are the things that we're going to be talking about today. We'll start with a bit of level setting and explain what do we mean by external traffic and what types of external traffic we're going to be talking about. We'll then move on to talk about external protocols, what can be used to orchestrate external routing, and then finally we'll talk a little bit about deployment scenarios. We'll cover some of the more what we consider advanced scenarios, and maybe even we'll have time for a little bit of the lab if the lab gods are going to be on our side today. We'll see. Right. So let's start with the definitions. What do we mean by external traffic? And the easiest way to think about it is like it's everything that is not an internal traffic, which still it's quite a big vague. So we'll try to zoom in a little bit. So firstly, it's the typical ingress traffic, and that is the traffic that is going into the cluster and that's originated from outside of the cluster. Another component of external traffic is the egress traffic. That's kind of the opposite of the ingress, all right? It's the traffic that's going outside of the cluster that was originated inside. And whenever we deal or we design a solution that involves ingress or egress traffic engineering, these are some of the problems that we often think about: failover, security, performance, and cost optimization. We'll try to mention, as we go through the scenarios and discuss them, we'll try to mention these problems and how we approach them and how to optimize and solve them. And finally, a few words about traffic engineering, like for people who are not quite familiar with it. It's a very vague term. I don't think it has a proper dictionary definition. It means many things to different people. But for us specifically, what it's going to mean is that traffic engineering is a way to modify the default behavior or default forwarding path between a source and destination. So usually, once you build a Kubernetes cluster, there will be a way the packets will take by default. And this is kind of the standard out-of-the-box way. Traffic engineering is a way to augment or change this behavior to make the traffic go a different way based on some sort of user criteria or user-defined configuration. And the first traffic that I'll start explaining about is the ingress. It is by far the most popular type of external traffic that people know, and this is one of the things that we'll learn very early on during the Kubernetes journey. It is the traffic that's coming from outside of the cluster, and then we usually have some sort of resource which is either ingress or gateway, API, compliant implementation, and all the traffic hits that endpoint or those pods and then gets forwarded to one of the backend pods. And it's depending on the policy and how it's implemented, it can go to either all nodes or a subset of the nodes. And generally, traffic engineering in this context refers to the ability to steer the traffic to the most appropriate nodes in a Kubernetes cluster so that they can process and send the traffic on back to the backend pods. And one of the examples of ingress traffic engineering, it's probably the easiest way to understand what we will mean by traffic engineering in this talk, is external traffic policy. So it's a setting that was introduced, I can't remember when, a few years ago, that augments the default behavior of a service. By default, with external traffic policy cluster, whenever that service is configured, the external network is expected to send traffic for that service to any node. And any node can receive it and forward it to the backend pod. The optimization to this rule was the introduction of external traffic policy local, which allows external network to only selectively forward traffic to the nodes that are actually running the pods. And the idea was that when you send the traffic, you can preserve the original client IP. You don't have to do natting on the node as you receive the traffic and forward it to the pod. But this is probably the easiest and the most gentle introduction into traffic engineering for people who are not quite familiar with it. And it's also like one of the basic and simplest use cases to understand. But then come the more difficult bits, and this is the egress traffic engineering.
Yeah, before we come to the egress, this is a picture which can be complementary to the ingress as well, because ingress traffic requires information which is sent in the reverse direction. What information in the reverse direction? Information about the prefixes we want to reach in our Kubernetes cluster. So we need to find a way how to advertise these prefixes outside. So ingress traffic requires information which is sent outside. Reversibly, if we want to reach the destination like this one, 203.0.113.10, which is egress traffic, because we are originating this from inside to the outside, we require the information in reverse direction, which is, again, announcement of prefixes, which is this one, inside, from external network to the Kubernetes cluster. So you see the complexity is quite difficult, quite huge, because Kubernetes cluster as such is not enough. We need something in between also to manipulate the information about prefixes. It's beyond the scope of Kubernetes, but we need to take care of this. And with Isovalent, with Cilium, we are trying to help you out to reach or to simplify this announcement of prefixes. So how to reach Kubernetes cluster? The first question, we need to advertise prefixes of the pods or services outside. How to reach a destination? We need to advertise this prefix, which is related to the destination, to the Kubernetes cluster. Typically, to reach a Kubernetes cluster is a simple way because, okay, differently, how to reach destination? It's a simple way because it's enough to advertise a default route, isn't it? Typically, the Kubernetes cluster does not require full BGP table. We don't require hundreds of thousands of prefixes. Default route is enough. The different story is if we consider the first question, how to reach a Kubernetes cluster, because Kubernetes cluster can have dynamic IP addresses, dynamic pools, provider-independent pools, IP addresses, which are public IP addresses, which can be advertised through different service providers, which can be filtered out by some service providers as well. And we cannot enforce that directly in the Kubernetes cluster. What is the impact of that? What can be a trap for the egress traffic, for example? The trap can be asymmetric traffic. In this particular picture, we have one Kubernetes cluster which is spanned across two sides, but this can be, this can be also multi-cluster environment. With Cilium, you can achieve multi-cluster as well solution, which is spanned across multiple zones in particular cloud or multiple areas, multiple regions. In such particular example, if your traffic is going outside, you don't have guarantee that the return traffic is going via the same path. Why? Because the return traffic is not looking at the path which was used to reach the destination, but it's looking at the destination IP address, which is actually our source IP address for the egress traffic. So the source IP address is exchanged, swapped with the destination. As an effect, it may occur that the destination will choose a different path to reach our Kubernetes cluster. Okay, so what's the problem with that? The problem is then when we are using, for example, stateful firewalls, which is a typical design for enterprise class company. A stateful firewall which is sitting in different regions can have a keeping of the status of the connection in each particular site. And as the effect of that, for this asymmetric traffic, the traffic will be dropped because the firewall at the bottom side don't have such entries in the connection table. So this is quite important to understand the relationship between ingress and egress. Ingress traffic, as Michael mentioned, we are sourcing the traffic, we are originating the traffic from outside to inside, and egress traffic is reverse direction, so we are initializing this traffic from inside to outside. For each of this kind of traffic, we have different components in Cilium, but also in Kubernetes. In Cilium, we are reaching with ingress traffic, we are hitting service kind of components like load balancer, like cluster IP, like node port, yes, this kind of IP addresses. But with egress, we can optimize the traffic which is going outside using different component, which is egress gateway. With this component, we can steer the traffic in a better way, in a more optimized way. Why? Because we can decide which side should be used to exit our environment. So comparing egress gateway to the situation where we don't use egress gateway at all, let me give the example. Without egress gateway, if we have a cluster composed of hundreds of nodes, each of these 100 nodes can be the exit point for this traffic. Whereas with egress gateway, we have just, let's say, 2 nodes, hefty nodes, which are used to send the traffic, to use these IP addresses as a source NAT, to translate the IP addresses.
Is that it? Right, so let's talk a little bit about how you can achieve traffic engineering and what protocols can you use to interact with what we've been so far referring to as external network. And one of the easiest and at the same time least flexible approaches to use static routing. Usually it refers to either a directly connected prefix on the interface of your, let's say if it's a physical data center, that's going to be your top of the rack switch. If it's a cloud environment, that's going to be the subnet of that VPC where the Kubernetes cluster is deployed. And the problem with it is like it achieves a lot of this, a lot of the functions that we need. It establishes reachability from the external network to IPs located within the cluster, but it's very inflexible. And it usually is used only in some corner cases where other approaches cannot be used. But at the same time, when you talk about the cloud environment specifically, that is the only tool that we have. Sometimes, not sometimes, but the majority of the IS, traditional IS, not taking packet into account, clouds, you cannot use any non-static route protocol to change the direction of the traffic. So that is the only thing that you can have. But there are better solutions if you do have a chance that you can use dynamic routing, which Piotr is going to explain now.
Yeah, which is the solution for our previous problem statement for asymmetric traffic, because with BGP, you can not only advertise the prefixes, but you can also decide which site is the primary site where you advertise your prefixes, that's the first point, and which site will have a better attributes. There are several attributes you can use with BGP. We don't manipulate attributes as part of Cilium at this moment, but still you can decide on the upstream device what will be your policy. So thanks to the BGP protocol, you can decide which site or ingress point will be used actually by external devices. And you can make this traffic more symmetric or fully symmetric. Plus, on top of the BGP protocol, you can use egress gateway to help out to make a decision even more symmetric, even more easier for BGP to make a decision. And just for your reference, this is the configuration snippet with the example of the configuration for BGP peering. There are several attributes. Some of them are extended already with a newer version. The most important message here is this is pretty simple and standard configuration of BGP, which you can find with any other vendor. So you just defined with virtual routers and local ASN what is your local autonomous system number. You configure the peer ASN, peer address. You can configure both external as well as internal BGP sessions. So depending what are your peer ASN numbers, you can configure both kind of sessions. You can use additional attributes which are related to the optimization, how the BGP session is established and kept alive if there is a failure of one of the neighbors. And what is important from the perspective of advertisement, we have line 15, 16, 17, which explains or mark the traffic, mark services which will be advertised, not the traffic, actually the services which will be advertised externally. So by service selector, we mark what are the labels taken from services which will be used, which will be identifying our services for advertisement of these IP pools which are associated with these services. And this is short snippet from Cisco CSR router. How does it look like when we advertise the prefix from Cilium? Nothing new, just the standard BGP prefix received by the standard BGP router. We have next hop, which is the physical IP address or virtual IP address sitting on the Cilium node, and networks, which are standard things. You can decide whether it's /24 or different mask. If you are advertising service IP, it will be rather /32, so the host route. But you can aggregate them on the BGP level on the upstream device simply. So we also included into this presentation kind of laboratory. So if you are ready, you can go to the link. If not, just put the note about this lab. It's a lab which is consisted of egress gateway plus BGP advertisement. We added additional feature there, which is pre-version 1.16, which is not released yet officially, but we had an agreement to give you this feature already. And you can play with it by advertising, for example, cluster IP as well, which was not available so far. So going to this link, you can click, you can register. You don't need to put all of the data, but you can just start the lab, okay? Because it takes 3, 5, 6 minutes roughly to spin up all the VMs, to instantiate all the components. So we will go back to this shortly, okay?
All right, so now we're going to talk a little bit about deployment scenarios, so something that we've mentioned during the agenda. And to keep it short, we'll just target the 2 different scenarios that we've seen quite a lot our customers and users use. So the first one is going to be egress gateway high availability.
Yeah, high availability is an extension to the egress gateway feature, which is required, of course, to keep everything redundant and healthy if there is a single point of failure. Of course, we cannot afford for the single point of failure, so that's why we have egress gateway high availability. In that particular scenario, we have active standby scenario where we have 2 options of the configuration where we have just one max gateway node, which means just one node can be active. The other is standby. And how we configure this standby, it depends on us. It can have the same IP address, or it can have different IP address. In this particular configuration snippet, we can see the same IP address is configured for a failover scenario, which is 20.0.0.1. We can also describe this failover node by the interface name. So we don't care about the particular IP address, but the interface number, which is in this example, Ethernet 1. You can notice that the traffic to the egress gateway is tunneled through the VXLAN and encapsulation, and that's the necessary component of the architecture, because in between the worker node and the egress gateway node, there might be routing decision in the underlay, which means the traffic will be forwarded back straight to the internet. We want to avoid that. So that's why the traffic must be tunneled to the egress gateway. And the second part of the story is when we are using multiple egress IPs, so we want active-active scenario. In this case, there is load sharing from the worker node of the traffic to, which is distributed across different gateway nodes. All nodes can be active depending on the scenario again. There are 3 examples in the configuration where we have, in the first example, 2 different IPs because there cannot be the same IP address because it would result in the duplication of IPs. In the second example, we have the equivalent of the previous scenario where we have indication of the interface. We are not deriving IP address from the configuration, but we are indicating what is the IP, what is the interface where the IP should be taken from. And in the example 3, we have even 4 nodes combined, which can be active, grouped into groups, okay? So the first group has 2 gateway nodes, and the second group has 2 gateway nodes.
Right. And another feature that we wanted to talk about, which also has very interesting application and can be described as a pretty much traffic engineering for egress, is the topology-aware routing. This feature is inspired by a similar feature upstream. I don't know if you're familiar with it. The topology-aware hints or routing, it's an ability to kind of steer the proportionate number of traffic to the right place in your network or to the right availability zone. What we do with this feature is the reverse of that. We can allow pods that are in one availability zone to preferably or to try and select the egress that is also based in the same availability zone. And typically, the reason why we do that is because it helps with latency, because you don't have to cross the interzone boundaries, but mainly it also helps with the cost savings, because every time you cross the AZ boundary between different zones, there's some costs involved, whereas if you exit locally, then it becomes a lot cheaper. And for this problem, typically we've had 2 solutions. One of them is DIY, which we've seen some of the customers do when they write their own controller that relabels pods after they've started because it tracks on which nodes they end up being scheduled on, and then labels them with the availability zone label of that node so that they could get selected by the right policy. But another option is to build a product that has this feature built in, and to use the product that has this feature built in. And this is what Cilium Egress Gateway Policy can do today. It's accomplished through a certain flag called AZ Affinity, and it has several different configurations, which is probably not worth covering in this slide, but just so that you know, it's pretty flexible. And the way it works is, as I mentioned, when the pod gets scheduled on a particular node, our egress gateway implementation knows that this node belongs to a particular availability zone, and it will try to select the egress that is in the same zone, and only when certain conditions are met, which could be all egress gateways in the zone are dead or unhealthy, then only then would it forward the traffic to another availability zone. And again, this is all very configurable. You can select whichever option you want, and in general, it is a very good example of how to augment the default egress behavior of a traffic from a pod. And back to you, Peter, about the lab.
Yeah, so to summarize all these features, they are here to help you out with engineering, traffic engineering. With egress gateway like this one, you can make a policy which allows on the firewall which is sitting in between or somewhere along the path, like on the destination side, that the traffic only from 10.03.42 will be allowed to access the pod. The direct access, which is initialized by default, which is coming from the Kubernetes kind of configuration, won't be allowed. This is one kind of simplicity or feature which you can use. Additional thing is that, again, with cluster node, which is composed of hundreds of nodes, you will have the situation where the direct access is triggered using hundreds of source IP addresses. Here, with egress gateway, you can have just a couple of these IP addresses. And this laboratory, which we are referring to, is exactly doing that stuff. So if you go to this link, you will reach this laboratory, which is, by the way, available for you for not just for today. You can do this whatever time is preferable for you. And during this lab, you will be...
I don't think we'll have time because it's still warming up. It's 4
yeah,
minutes.
we will possibly don't have time at this moment, but I would like to briefly mention that this lab is composed of several different tasks where you can try not only egress gateway, but also you can notice and see what is the advertisement of prefixes all about through the BGP, how this configuration is simple. If you have any questions, we are open to that right now.
Yeah, we've got like 1 minute left, so.
Just last comment from our side, all the labs are also available during the KubeCon event and online through this link on the isovalent.com website. Any questions, please?
Thanks, Piotr and Michael. I'll take questions. I go to you with the mic. If there are any questions, so people hear it on the recordings. Calling once, calling twice. Lazy consensus. Thanks, Michael and Piotr. Next talk will start in 5 minutes. We'll stick with pushing packets. This will be about the Gateway API and migrating your ingress to Gateway API. Welcome again to the arena in the Rejekts EU24. I have Leo and Matteo today talking to you about Gateway API and how to migrate your ingress.
Nice. Nice. So hey everyone, I'm Leo Lieberman. I work as an SRE in Google, and specifically on GCE, which is Google Compute Engine, so a little bit down the stack. And I'm also an Ingress to Gateway maintainer and Gateway API contributor.
Hi, my name is Mattia Lavacca, and I'm a software engineer working at Kong. I work in the Kubernetes team, and I'm mainly involved in the Kong Kubernetes Ingress Controller and the Kong Gateway Operator. Also, I am a Gateway API contributor and an Ingress to Gateway contributor. Have been involved in creating the Kong provider for the Ingress to Gateway tool.
And today we're going to provide a practical guide to migrate from your Ingress configuration to your Gateway API. So I want to start for a moment and to ask you if, basically put your hands up if any of you have ever ran into any frustration with Ingress before. Right. So yeah, so Ingress was great. I mean, it was really simple to implement. It was widely adopted, but it has its own limitations. So first, Ingress lacked of core features. A lot of core features weren't included in Ingress. That led to custom extensions being everywhere. Those extensions were usually in the form of annotations, and they weren't portable, so you couldn't just easily switch to a different implementation. It also lacked the protocol diversity, and it had insufficient permission model. And that's the reason for developing Gateway API, right? So before giving a really quick overview of the API, I just want to lay down a few facts. So Gateway API is a CRD-based API. This means it develops out of tree, out of Kubernetes upstream. And this gives us much faster velocity, and it's shortened the feedback loop, essentially. It's a persona-focused API, so different personas have different responsibilities. It is flexible, and it is extensible. And I'm going to talk a lot about the extensibility, but essentially Gateway API learned the Ingress lesson, and it provided and designed a standard way to extend the API. And lastly, it had large community support. I think we're over 200 contributors now. So yeah, starting with Gateway class, the first resource we're going to talk about. So Gateway class is nearly identical to Ingress class, which you might be familiar with. Gateway class lets you represent class of gateways that can be instantiated from this Gateway class. You would usually find in Gateway class the controller name, which is the controller that's responsible to reconcile gateways created from those classes. Next, we have Gateway, right? Gateway lets you represent your load balancer or proxy config as a Kubernetes resource. Here's an example of a simple gateway. You can see we have the Gateway class name is GKEL7 load balancer. We could specify listeners so that the gateway would listen in. So in this case, we have HTTPS listener on port 443, listens to all the host names ended in example.com. And in Gateway, we could also specify what routes could be attached to the gateway. So for example, and we're going to talk about routes in the next slide, but for example, in this case, we're saying we could attach all the routes from all the namespaces to this gateway. And lastly, we could also specify TLS configuration if we want to terminate TLS in the gateway or not. So next, we have routes. In this example, I highlighted two types of routes. We have HTTP route, TLS route, but we have much more routes than this. And routes is a way of telling your gateway how to pass the request from your gateway to your backends or to your services. So let's just take a look of a simple HTTP route example. So we have an HTTP route of a login service. It's a weight-based routing, two different versions of the login service. And here highlighted, we can see that the routes, we can specify a parent reference. In this case, we're referencing the gateway that the routes should be attached to. We can specify the host names. So this route will only be applied to host names for example.com. And there is the first section of the rules. We're saying, OK, we'll match all the requests with a pass prefix of login. And lastly, we have the backend references. So we have 90% of the traffic goes to login v1, and 10% of the traffic goes to login v2. So wait a minute. I'm sure a lot of you might be saying, like, this API looks familiar. We could achieve it with Ingress. And right, you're 100% right. This API is familiar, right? So we could achieve the same thing with Ingress. We could achieve the same thing with different CRDs that was developed throughout the years to overcome Ingress limitations. But do you remember I told you that Gateway API is portable and flexible? So I want to go through really 2 simple examples. You might be familiar with them. Just showcase how simpler it is and how portable it is. So the first example, if you want to add a host, right? So in this example, we have Ingress configuration, an HP route equivalent configuration to just provide the same identical configurations for again an auth service. And if you want to add a host, so if we weren't in a non-Gateway API world, we'd have to duplicate the section again and just provide a different host, but all configurations are the same. Whereas with HP route, we'll just add another host. For this example is barexample.org to the host names repeated field, right? So the next example, I want to talk about, it's actually an example I really like. So if you were to change an implementation. So this is an identical configuration again, if I'm deployed with S3 virtual service or if I'm deployed with HTTP route. So if I were to, tomorrow, I wanted to try Contour, try a different implementation in my cluster. So with a non-Gateway API world, I had to go to Contour docs, deploy the Contour CRD, and understand how do I map all my S2 fields, S2 virtual service fields to Contour. Whereas in Gateway API, I'll just add another parent ref or replace the parent ref. In this case, it will be the Contour external gateway. And the Contour external gateway is probably deployed as part of the installation with Contour. And in this case, I could just test the traffic passing through the Contour gateway.
Yeah. So, well, Gateway API has many more features than the Ingress API. It has this extensibility possibility. There is this extensibility which is built in the Gateway API. So it looks great, right? It looks shiny. So the question here is, well, but should I really migrate from Ingress to Gateway? And the answer is yes. Yes, you should. You should migrate. But everything has upsides and downsides, of course. So let's start with the upsides. Gateway API is already GA. It has been promoted last year during KubeCon North America 2023. And a new version, 1.1, is going to be released right after KubeCon. So there is a larger variety of features compared to Ingress, as Lior pointed out before. And there is a very large and active community. We have around 200 contributors as of today. The number keeps growing over time. And yeah, I mean, there is a lot of attention on this API. And there have been many different talks, for example, in the past KubeCon, and in this KubeCon as well. It's widely adopted because along with the large community, there are many different companies that are working on the Gateway API. Indeed, we have over 25 implementations so far. These implementations have different levels of support. Some of them are just alpha, some others are beta, some others are GA. But yeah, there is a lot of attention on this API. And of course, there are also some cons. Well, first of all, not all the implementation-specific features or annotations are supported by the Gateway API yet. You may be wanting a specific feature that is provided by a specific implementation that is not properly converted, is not properly handled by the Gateway API yet. So maybe the time is not right for you yet, even if there is a lot of opportunity for you to come to the community, to Gateway API community, and basically advocate for what you need. And also, the second point is that the migration can be painful and very error-prone, because you have to go through a lot of different, maybe Ingress configurations, and properly convert them into the proper set of Gateway API resources. And here is basically the reason why we are here, because there is a tool which is called Ingress to Gateway that is your buddy to help you throughout the migration process. Here is a migration checklist. During this talk, we are going through this list, and at the end of the list, when we'll get at the end, the migration process will be completed. First of all, we need to check that your Ingress implementation, your preferred Ingress implementation, actually supports the Gateway API. Then you have to ensure that implementation is conformant with the features that you need, with the required features. Then we'll be writing the corresponding Gateway API configuration. We'll apply them, and they will test them. And at the end, we will be finalizing the migration, and we'll explain how to shift traffic, and we'll delete all the Ingress configurations. First of all, let's talk about implementations. Here is a QR code with a link, and you can go to the implementations page in the Gateway API documentation website, and here you can find the list of all the implementations of the Gateway API so far. Some of them, as I said before, some of them are alpha, some others are beta, but you can look for your preferred Ingress implementation and check that it is also compliant with the Gateway API. Or maybe, if it is not, you can also choose another implementation. But the problem is the level of support for your implementation, because there are many different features in the Gateway API, and there is a proper mechanism to understand the support level for each implementation. This mechanism is basically the conformance test suite that is provided by the Gateway API, and it's a suite of automatic tests that can be run by any implementation against a specific Gateway API version. There is the concept of profiles. Profiles can be HTTP, TLS, mesh, and probably we will be adding gRPC in the near future. And each profile is basically a container for sets of features. And every feature is a container for sets of conformance tests. There are different levels for the features. Features can be core features that are needed to claim core conformance for a specific implementation. They can be extended, and they are optional. It's a plus that an implementation provides to their user, and they are implementation specific. While there are conformance tests for the core and extended features, there are no conformance tests for the implementation specific features, because for obvious reasons, I mean, they are implementation specific. And the output of the conformance test suite is called the conformance report. And this is the tool that is needed by a user to understand the level, the actual level of support for a specific implementation. So you, as a user, are supposed to go through this reports page and navigate through the conformance reports that have been uploaded by the implementations, and you can check all the supported features for each implementation. So reports are broken down by API and implementations versions, and as I said, they are stored in the Gateway API GitHub repository. And they are actually uploaded by the implementation themselves. Here is a couple of screenshots. On the left side, we can see the structure of this folder. For the version 1.0.0, we have a bunch of different implementations that provided their conformance reports. On the right, we have an example with the Kong Kubernetes Ingress Controller, which for the Gateway API version 1.0 provided two different conformance reports. The first one is for version 3.02, sorry, and the second one is for version 3.1.1. Then there is another very useful tool for a user, because yes, I can see that this implementation with that specific Gateway API version supports a set of core conformance tests and extended tests. But should I trust them? I mean, they just uploaded by themselves, and who checked this? This can be checked by following the reproduce section contained in the README file. So basically, this is a tool for the users and for the Gateway API community as well to check that every single report is properly created by an implementation and is legit. It's not faked. Because yes, an implementation can fake a report, but it can be figured out by people very, 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 very soon. So it's a tool for the user and for the community to enforce the trust around the Gateway API conformance test. So here is the updated migration checklist. First step was, let's check my implementation supports the Gateway API. Yeah, we have the page, we can go through the list and we'll choose it. Then we can see that our implementation supports all the core Gateway API features, yes, and maybe it has also a plus with some extended features. Now, the next step is actually start performing the migration.
Thanks. Let's see how much time we have. All right, that's great. So yeah, Ingress to Gateway. Ingress to Gateway, as Mattia said before, is your body to kick off the migration process to Gateway API. Ingress to Gateway is a simple CLI tool, really simple, that reads ingress and implementation-specific configurations from the cluster or from a file and outputs corresponding Gateway API resources. And one thing to note about the name, it's called Ingress to Gateway, but it's not only Ingress API to Gateway. It also supports different CRDs. So it's Ingress configurations to Gateway API. And this leads me to the other bullet. Ingress to Gateway is extensible. So if anyone in the crowd is an implementer of the API, I encourage you to add your support because we're getting constant requests from users. And here is a list of 4 implementation already supports the API. So we have Istio, we have Ingress Nginx, Kong, and Apache API 6. And now let's do the migration, right? This is what we're here for. We're here for the demo, not to hear us talking. So for the migration, here's the environment we have. We have a kind cluster installed. We have metal-on-B installed, just to provide public IP addresses. And we have Kong Ingress controller installed. This Ingress controller would only reconcile ingresses. We will install together the Gateway API, the Gateway controller. So let's start by installing the controller, right? It's the first step in the checklist. We pick the Kong Ingress controller, and we just install it. And then we're going to wait until it's ready. And once it's ready, step 1 is finished. Now we're going to deploy base manifests. Those base manifests will be used throughout the whole demo. We have 2 demos, so remember them. We have a simple TCP echo service that exports a simple TCP deployment on port 1025. And we have a simple service that exports a simple HTTP service time deployment that just replies with the current time when you query it at /now. Let's apply them real quick to the cluster. So yeah, we apply the service. We'll also apply an ingress as part of this demo, as part of this clip. And this ingress will just provide us L7 access to the public IP. And as we can see, the ingress will have basically the same path prefix at /now. We can see it's the ingress class name named Kong. It's a Kong ingress. And it's referenced to the HTTP service backend, which is the time deployment. And yeah, so this is just for completeness. I want to check that the ingress actually working. So this is probably, we're trying to make an environment which you might have right now if you are using ingress and not Gateway API. So as you can see, I grabbed the public IP of the ingress from the ingress status field, and we just URL the ingress status at /now, and we can see the pod is replying with the current time. So now we want to use Ingress to Gateway tool, right? We want to start writing Gateway API configuration. We want to have our base point. So we're going to use the tool. We're going to use the print command of the tool with -a. That means the tool will read resources from all the namespaces, right? We're going to specify the provider. Provider equals Kong. So this means we're looking for Kong-specific features and maybe specific ingress annotations or specific CRDs. And we're going to pipe the output to Gateway API.yaml. And then we apply it to the cluster. So let's start by executing the tool. So here's the same command I showed you before. And then we're going to just cut it to the screen. So let's focus on what we have right now, right? So what we have is a gateway, the gateway named Kong. And the gateway class name is Kong, which was installed as part of the Kong gateway controller installation. And we can see we have one listener. The gateway listens on one listener, port HTTP. Then we have HTTP route. The HTTP route is just exporting, configuring a route to the HTTP service, the time deployment. And we have the parents ref field, as we saw before. The parents ref fields references the gateway that is just going to be applied. And we have the backend references, and we're matching all the path with a prefix of /now. we applied it to the cluster, and now we're going to continue to check whether it works. So similarly to Ingress, gateway has its own IP in the status. So we just grab the IP, we see URL to the gateway. So here we grab the IP. We're going to echo the IP to showcase that the IP is different. And this will be really useful when you want to shift your DNS gradually, if you want to do it. And then we see URL the IP and /now. We can see the pod is replying with the current time. Now I just want to follow up with deleting the ingress, just to see that nothing is broken in the control plane. So the configuration still works. So we'll delete the ingress. We'll see URL to the ingress to see that the ingress is not working right now. And then we'll see URL to the gateway. And obviously, it should still work because it works independently. And yeah, over to Mattia for the TCP ingress demo.
Yeah. Here is another feature of the ingress to gateway, which is the CRD conversion. Because as Lior mentioned before at the beginning, the ingress lacks a lot of features. And among these, there is the impossibility to set the protocol into the ingress, right? Every single ingress is only HTTP. So Kong created this resource, as many other implementations did in the past. And this is basically just an ingress to work with TCP traffic, just an L4 ingress. Its structure is very similar to the regular ingress. It has a set of rules, each with a specific backend. Here we are going to use the TCP echo that we deployed it at the beginning of the HTTP demo on service port 1025, and the ingress will have the port 9000. The TCP ingress can be also configured with TLS, just to provide TLS ingress, something like that. But for the purpose of this demo, we are just going to use the plain TCP traffic. As a first step, let's perform some cleanup on the previously created gateway API resources. So let's just delete the gateway and the HTTP route, and then we should see that we are going to apply this TCP ingress. I've just showed it to you just a couple of seconds ago. Let's create it into the cluster. And so here we have a cluster with a TCP ingress configured. And we are supposed to be able to reach our TCP echo server that we deployed before, right? So let's export the TCP ingress IP by grabbing it from the TCP ingress status. Let's print it. It has a IP ending with 0, 100. And if we curl it with telnet on port 9000 because it's L4 traffic, we can see that the TCP echo pod is replying with the pod name. So everything is working as expected. Now we have to perform again the migration from TCP ingress to the gateway API corresponding set of resources. And to do so, we have a command very similar to the HTTP one. So let's just print everything by setting all namespaces, only Kong provider, and let's redirect the output to a YAML manifest. At the end, we are going to apply the manifest created. So let's print the resources, redirect the output to a manifest, and here we can print the manifest, and this is the important aspect, because with the HTTP demo before, we created a gateway and an HTTP route. Here we are going to create a gateway and a TCP route, which is the L4 route deputed for TCP traffic provided by the gateway API. So it's very similar to the HTTP one, just Kong as a parent, and the rules contains only one rule with a backend ref on the TCP echo on port 1025. We applied the resources into the cluster, and now we are supposed to say that our gateway configuration is properly working in our cluster, right? So let's grab the gateway IP from the gateway status. If we print it, we can see that it is different from the ingress IP, is 0101 instead of 0100. If we curl it again with telnet, the pod is replying as expected with the pod name. And yeah, at this moment, we have the TCP ingress and the gateway API configurations that are working in parallel and are pointing to the same backend ref, right? So next step is to delete the TCP ingress and verify that everything is still working as expected. So if we delete the ingress, we curl again the TCP ingress IP on port 9000, it doesn't work. But if we curl again the gateway IP address on port 9000, it works as expected. So we just deleted the TCP ingress, we have the gateway API resources in place, and the migration is completed. So here is the migration checklist updated once again. The fourth step was apply the configuration and test they work. And yes, we applied it and it works as expected. For the last step, let's go back to Lear.
Okay, so, right. So, yeah, this was a nice demo, right? But in the real world, we might have more considerations. And we just focused on two of them. I think they're main considerations, but DNS is one of the main considerations. So if you're using your gateway, your L7, like your ingress L7 traffic, I mean, everyone with its own needs, but you might want to consider doing gradual traffic. So shifting the traffic gradually with DNS weight-based routing. And I'm sure a lot of you are familiar with tools like external DNS, so consider using them because external DNS do support gateway and its API route types, so it's really cool to do so. And right, we have the TLS certificates. It's a bullet, but it's a NOAA bullet, kind of. So if you've ever used TLS secret to terminate TLS in your ingress, so it should be working as expected if you just reference from your gateway to the TLS. So this is an OAuth operation. So, now again, the migration checklist, just going over it real quick. We checked the ingress implementation supports the gateway API. We picked one. We ensure that the implementation is conformant with the features we need. Well, Mattia explained us how we actually browsing it. We start writing gateway API corresponding configurations with ingress to gateway tool, and we might even iterate it, with the documentation or something that wasn't converted as expected. Then we apply the configuration, we test the work, and lastly, something we didn't cover for sure, but the thing you need to do is shift your traffic on your preferred way and delete the old configurations. Now I want to talk about the road ahead for a minute. So the main upcoming plans for ingress to gateway right now is onboarding more implementations. We're getting more and more feature requests on the repo to onboard different implementations. So again, if you're an implementer, consider doing so. But we are planning to work with implementers to basically support them. Next, we're planning to support gateway API extensions, and this will increase the coverage and provide a more complete picture of how do I transfer ingress and CRD configurations to gateway API. Next, we have the notification systems to report conversion results. So whenever you do the conversion, so some of the things might not be converted as expected. So we don't want the users to just read logs and try to figure out what it is, because if it's a large cluster, it's really hard. So we are planning to actually build a package that properly reports conversion, what was converted, what was partially converted, and what wasn't converted. And lastly, we want to support more gateway API routes. I think in 2 weeks from now, if I remember correctly, we're going to release the second route GA, which is gRPC route. It's going to be the second route after HTTP route. It's going to be GA, so we do plan to backfill the support to that tool. Lastly, if you want to get involved, there are indeed plenty of opportunities to get involved, plenty of opportunities to do so. We are part of Gateway API community. We're doing EMEA-friendly time meetings, so you can just check out the Slack page or the repos. And yeah, if you have any questions, feel free to shoot them.
Thank you, Mattia and Leah. I am going to take questions from you now. I go with the mic. There's one.
Hello? Yeah, thanks a lot. I have a question in your example. You create a gateway, and I think you named the gateway Kong, but it's just a name you picked, but it might be confusing because there's no need to know what type of implementation is behind the gateway, right?
In the name of the gateway?
Yeah.
Right, and the name is arbitrary.
And the name, and we could see Kong, but there was no parameter to set to say it's actually a Kong or it's something else behind it.
So the only thing that is useful is the only thing that will be useful is you need to specify the gateway class reference from the gateway to reference the gateway class, and then you can call it whatever you like. And then from the HTTP route, you need to reference to the gateway, right? So the name is arbitrary, right? So
Actually, the name of the gateway is taken from the gateway class today in the Ingress to Gateway tool. So if the gateway class referenced is Kong, the gateway is named Kong as well, just by the tool itself.
it's just the output of the tool, yeah. But you can change it.
It's arbitrary. I mean, it doesn't really matter.
All right. Thank you both for presenting and having kind of a live migration here. That's amazing. All right. Next talk will start in 5 minutes.
Thank you.
Thank you. We're around. We're also around for questions if anyone.
Yeah.
Welcome to our next talk with Ramiro and Arsh on runtime security and OpenTelemetry. Give them a warm welcome, please.
Hi, everyone. Thanks for coming for our talk. We are going to be talking about security, and in particular, OpenTelemetry and container-related security. Quick couple of introductions. Ramiro, you want to go first?
Hi, everybody. Thank you for coming to our talk. Very excited to be at Rejekts. It's always my favorite part of the KubeCon week. My name is Ramiro. I am the CEO and co-founder of Octeto. At Octeto, we built a platform for dev environments on Kubernetes.
I am Arsh. I work as a DevX engineer at Octeto. I am also a CNCF ambassador, but all of these are things which, like, if you know me, like, you know about this, but like, there's one thing which Ramiro and me have not shared with a lot of our friends and people from the cloud native community, and that is that we are actually very scared of AI and AI taking our jobs, and that is why a couple of months ago, Ramiro and me just sat together and we brainstormed what could we do like when this AI takeover happens. And both of us are really good at making like telescopes from our hand. We might not look like those people, but it's true. So we came up with this startup where we are going to sell like handmade telescopes. So we worked on this startup, and we have a lot of like good number of outlets all across the world. Like, you might not see them, but if you like look closely, you might. But now we have all of this, and I created the front end for the website. I created the back end, microservices, and all of that stuff, and he was responsible for deploying it, scaling it, and all of those boring aspects. But once we did this, business was booming, and we got a lot of sales, we got a lot of traction, and everything was going great. But last night, I got a call from him, and I do not accept calls after like work hours. So, Ramiro, do you mind telling me why you called me?
Yeah, well, I was calling you because I was getting all these tickets from our customers. Well, not customers because they were not able to pay, because something on the website was failing. Like, they were trying to add things to their cart, check out, which isn't working. They really like our telescopes, so they were trying to like buy it. And now business is not booming
What
that
are
much.
you saying? That is not possible.
I don't know, one of those like late night commits.
Let me just, I did not commit anything. Let me just go to our website and see, okay, I'm at the product page. I am refreshing, and everything seems to be working.
Why do you keep refreshing when the image is not there?
I did not, no, I'm just, everything is
It
working.
just happened, right? Like, because, are you guys seeing it? Like, it just happened.
Stop lying, please. Like, you need to be serious about this. Like,
It's there. It's there on the big screen. Like, the image is not there.
you don't trust me. Let me just show you the pods. Like, see the pods? Everything is running. So can you please just stop messing with me and like calling me after work hours?
Step away from the keyboard. This is what you do every time. Let me show you what's going on here. Because I knew this was going to happen. So yesterday, on my flight from Oakland, I actually instrumented our code with OpenTelemetry and set up dashboards, collectors, so we can get some real data on what's going on. Because, you know, like, pods is not all that matters. Like, the pod might be running, but this application we built is very complex. It's a very sophisticated
application I built.
Sure. It's a very sophisticated application I built. And it's not easy. It's not just the pods. It's not just the logs. So let me show you what this beautiful thing
Okay, let's see.
gets us to do. So we have Grafana. This is something installed yesterday. So the first thing I did is I actually instrumented our code to use OpenTelemetry. OpenTelemetry is a standard that allows you to get data in a standard way across different vendors, across different tools. And I like Grafana, it's open source, and I built this great dashboard to show us what's going on with our application.
Cool. Let's see who's lying, who's not.
So now this is what we have, and if you can see there, we have this beautiful dashboard that I put together yesterday, where you can see the latency of the services, error rates, request rates, and this is great because we're no longer just looking at logs and waiting for customers to open tickets angry.
I would like to stop you because you're just making a joke out of yourself. See the error rate? It's 0. I told you everything is working. your own tools are against you because I am right.
Am I the only platform engineers that hate talking to developers because they always think it's somebody else's fault? Is it just me, or anybody here relate to this? This is one of many services, and this is something that, I know that the world of monolith kind of like was like that. A single service does everything, but this is a sophisticated website. It has multiple services. So sure, the ad service, it's not erroring, which I'm grateful because we get a lot of money from those beautiful ads. But if we go and look at the product catalog service, you will see that, see this? This is showing us the number of errors per second on our backend. And you can see here that it's not 0, as somebody was claiming before. And you can see this across every service. That's, to me, one of my favorite parts of OpenTelemetry is now you have this distributed tracing. You can do things across. And that becomes really useful when you're looking at problems like this. Here you can see that, hey, payment service is not having data because nobody's been able to pay because they can't load the catalog. But we have more things here. And that is the value that I see on this. This is why I spent a good chunk of the 10 hours that took me to get here to build this so that we can have real, clear, self-service data. I'm like, hey, this is failing. So now with this, it's failing. Now it's no longer on me.
Maybe for once you are right, but but what does this mean? How is all of this working behind the scenes?
So before that, and I don't want you to go after this code feeling bad, I actually tricked you a bit here because as on top of implementing OpenTelemetry, I also implemented OpenFeature on our service. It's feature flags. It's another standard driven by CNCF. And in this case, I made it fail every now and then, mostly to teach you a lesson.
You've been lying to me all this time?
Lying, educating, potato. And see, this is a new tool for you because now, in this case, I'm going to put 100%. You can go. You can make it fail all the time. It reproduces every time, like developers love. Now you can go and fix it, and then we can set it back to 0. So
I don't know about you, but
failures.
After this talk, I'm definitely going out to look for more partners. I am having serious trust issues after this.
Well, back to business booming. So what happened here, right? OpenTelemetry is kind of here to save the day. It's something that is kind of getting more and more notoriety. And it's something very important for all of us to look and do. This is roughly, I took this from Signos, which is one of the vendors implementing OpenTelemetry. This is kind of how it looks like behind the scenes. You have collectors. They're kind of collecting the data, pushing it to a backend. In this case, we're using Jaeger and Grafana to process everything. But there's multiple ways this could work. You can have pool model, push models, all these other things here. The beauty of this is that it's a standard. So today we're using Grafana. Today we're using Jaeger. If at some point we don't want to run it ourselves, if at some point it doesn't scale because business is booming, we can always switch. And that is to me one of the biggest values that OpenTelemetry brings to the table. Because OpenTelemetry is an open source framework. It's a standard that gives us the ability to have all these tools for collecting, for routing telemetry data. And I took this definition from the Datadog website, and it's something that it works all across the board. You can use it for devices, you can use it for your website like here, backend, any of these things.
So why is this conversation more important than ever? We feel that, had we been working on a monolithical application, maybe this topic was not as relevant there because it was just easier to get visibility into the application. The entire life cycle of that application was just easier to track, which is not the case with microservices, which is what everyone seems to be shifting to. So if you are working on a really complex app which has different microservices, these kind of things become very important to consider as you are building out your code. Secondly, microservices also increase the attack surface, right? Because now attackers could target one single microservice, whereas if you are not instrumenting your code, if you're not using such solutions, you would not have an idea of where the attack started, how it propagated, and all of that stuff. And lastly, when you use multiple languages and multiple frameworks for different microservices, you need something which aggregates all of this data, and you need a standardization which provides this data in a form where you can go to where you don't get logged into any vendor, right? You have this data, and then you can use this in any form you want. So if you see, like, this is the application which we were talking about, and we don't want you to read this graph, but what you want to show is that it is complicated, right? Like, there are a lot of things which are at play here, and simply without this tool, it would not have been possible to, understand what is going wrong and like how things are failing and how is it looking. So that's what I covered. Like, you get distributed tracing, which basically means you're able to follow and see how like one thing failing led to the other and how the attack propagated. You get observability, and you get standardization in the terms of like the output you get, the data you get. You can use it anywhere you want. You can use different tools. You can use open source solutions. You can use vendor solutions. So you have the flexibility to do all of that.
And something I want to like stress, just real quick here, is this. By the way, I'm going to come clean. We do not have a Telescope store. This is the OpenTelemetry demo. I highly recommend you download it, install it on your Kubernetes cluster, run it. Because it gives you a great idea, a good learning space of what modern applications look like. And this is something that, I talk about this a lot in our talks. Applications are getting more complex. And that's not necessarily a bad thing. Like, you have multiple services in this case, you have different responsibilities, maybe different language stacks, definitely different databases. So one thing is very important as we architect these new applications is to stop going from I look at the logs of one app, I look at the logs from another service, and into solutions like this, where we can have much better observability of what's going on with our application. Because this is a demo, it's kind of a dumb demo, you fail a request. In reality, in production, failures, especially at scale, tend to be a lot more sophisticated. Sometimes they cannot be replicated because it's a race condition, it's something where multiple services maybe are cascading, or one of your dependencies, it's like flaking. And that's where this class of tools really, really help. And it took a while. I mean, we've been doing tracing, and if you've been around, there was before OpenTelemetry, there were other standards that were competing. But more and more we see, especially CNCF, Kubernetes, really like standardize on this. So I really recommend all of you to start thinking about this, start instrumenting your code, start running collectors, because it's a muscle that you built. And as we learn how to like troubleshoot applications this way, as we learn how to do it, it'll be a lot easier because it's a when, not an if, when you get that page at 2 in the morning that your application is on fire and you don't know what's going on. The more we use it, the more we try it, and the more we contribute to these tools, the best. Like, if you go to the CNCF landscape, we couldn't fit a screenshot because it's so big these days. There's a lot of tooling around OpenTelemetry. A lot of companies, vendors, open source, whether you're a build or a buy kind of like person, there's a lot of solutions there. And I really like the fact that it's a standard and that it's not that hard to switch from one to another. Moving your data, moving your history, a whole different story. When you're picking a vendor, keep that in mind. Like, moving the data is expensive. But if you don't care about historical data and you just want to kind of like get your telemetry running from a different place, it's not that hard. And that, to me, gives me a lot of confidence on this space and why this is so important. And, Datadog's kind of like the big one, but there's Cygnus, open source, Lumigo, there's a bunch of them out there. I mentioned those because I have friends that work in those companies, so those are the ones I know, but there's like a huge universe of OpenTelemetry providers, and it's a really large project, and it's something I really encourage you to look at, contribute, and please start using it, because it's going to make it a lot easier for all of us to troubleshoot our applications, especially when the components you're depending on already come with telemetry. But is this enough? Do we have OpenTelemetry? Great. Are we off the hook? Are our applications ready to roll? I wish it was the case, but no. Security is the other aspect that is very important. When we talk about telemetry, when we talk about observability, many times people think about it from the perspective of just logs. Is my application healthy? Are my API calls returning where they're meant to return? However, we also need to think in terms of security. Here's examples of some of the members of the CNCF security landscape. This is kind of it's been around for a while in the Kubernetes world, but it's still, I think, in its infancy as a community, is the idea of cloud-native security. There's, again, some examples of tools that I like: Cubescape, Falco, Spiderbat, open source, or our vendors, but it's also a thriving environment. And it's very important to think of them, the same way we think about our telemetry story. We need to, the same way we went from like normal telemetry to cloud-native telemetry with things like OTel, we need to do the same thing when it comes to security. And why this is important? Like, this is the same slide we showed before, because I believe the same reason why OTel is important is why we need to think of this as well. Because now it's harder, it's tough to get visibility into the apps. We have an increased attack surface, not only for errors, but also for bugs, for images with like vulnerability. A lot of the times, like the big attacks are not even like because you have problems with your code, it's something in supply chain. Maybe you have a base image that's shipping with a vulnerability. Maybe you're using an old software that hasn't been patched, and all those things are very important to consider. Because we have broader applications, like if you remember here, this is what, like 10 microservices? Yeah, something like that. Each of them has, in this demo, a different base image, a different programming language, different SDKs, and each of them can have issues. So that's where it's really important to think about it this way, because we live in this world of like visibility is complicated, attack surface is large, and we have a lot of languages and a lot of frameworks that we have to keep track of. And that's where these tools really help. I really recommend you do look at this, look at ChainGuard as well. But think of security the same way we're thinking about observability. It's not anymore just one piece. It's as a system, tooling, and all those things.
Just to drive this point across more, we want to talk about like 2 CVEs, which are like in projects which you might be using and which were patched, but it's just like to emphasize more on this fact that, this is more common than you would think. So how many of you have heard of like kubefs? Okay, not a lot of people, but so it's basically a file storage system which is part of the CNCF landscape. But there was a CVE there where hackers were able to do a timing attack. And what a timing attack basically is that if you are comparing the strings in constant time, and not just like you could be comparing raw strings or you could be comparing hashes, but if the comparison is in constant time, then hackers can determine the correct password based on like, if the comparison is not in constant time, then hackers can determine the password based on how fast, like whatever they're trying gets rejected. So if you see this graph here, like as each letter gets rejected, I can see the amount of time it got rejected in, and that would give me an idea what the actual password could be. So this is a pretty famous CNCF project. The other CNCF project I'm sure you all would have heard of, and that's Crossplane. So Crossplane had a CVE where you could specify a base image for a Crossplane package, and that base image could, there was no checks, nothing like that. So this is where like something like ChainGuard could come into picture, where like you get the images from the right places, but basically the image you specified would take a lot of resources and it would kill the container, and that would basically give people like, have your applications failing. So all of these examples were just to reiterate the fact that these are things which are very, very important, which you now need to consider when you're thinking about the security or monitoring of your applications. Now we're just going to give like a quick glance of like some things you can use to like monitor things at a container level. But this is something you can use, and like this is like one of the tools we picked, but there are multiple solutions. Like this was from Spiderbat, but when you do something like that, you are able to see things on a container level. And basically what we saw using OpenTelemetry for the microservices, this you can see for each services container, and you can see how things are going through the surface.
Yeah, and we put this as an example, like going back. Imagine that the scenario we showed you at the beginning, where we were injecting failures. Like this could be also like not somebody injecting failures, somebody trying to use one of our bugs to get access to the system. In this case, it shows kind of a path for a container escape. And what's important about this and why we put this here is it's about the tooling, right? It's about how can we build this practice of like looking at these things, not from the, is my pod okay? Is this container well-defined? But from a perspective of, I have a system, I have a fleet of pods, I have a group of like applications that are interconnected. How do we look at them? And that's where this idea of, for me, of cloud-native security and open telemetry share a lot of things, because we're both dealing with like the same thing, a big applications spread around, and we want to see that in a systematic way across all these things. And that's where like all of this we show you helps with understanding, is my application behaving as expected? You can do things like you can hook up a lot of these tools. We use at Octeto, we use Armo, and we can hook that up to our alert system to get notifications when like, hey, this container you have has a vulnerability, like the ones that that Arsh just showed. It makes everything more visible and accessible, because if you go back to the previous, like this is a lot easier to understand on a graph than if you're trying to dig up and read through like syscalls in your logs and all that stuff.
You might not even know, like in this crossplane example, had you specified something, like it's really tough to see like where things failed, because you might be using multiple crossplane packages, and knowing which one triggered is something which you will only know if you have implemented a solution like this in your applications. So we have one more example.
And this is going back to what Ars showed. This is an example, it's a screenshot from Kubescape. And this shows you the analysis that they make of Kubescape is the open source version of Armo, and it shows you like vulnerabilities on a certain container. And as Ash was saying, we are taking dependencies on places. It's important to understand what we're shipping. In this case, hey, there are some action required, the tool detected. But what's important is this, right? It's not me going and say every container, I have to review it every day. No, you put this on tooling, you put this on your observability stack, and just get everything together, because this is very important. Security, observability are two aspects of application development that we cannot ignore. It's no longer something you do at the end. There are CISOs, there are security teams, but everybody needs to contribute. And the same way the developers need to be part of the observability story, developers need to be part of the security story. And that's where like these tools, you can say this is like fairly easy to use. We're no longer in the world of arcane tools that only like people with certain certifications could use. Like all of these tools are built with developer experience in mind and really thought for day-to-day use.
And that was our talk. Thank you so much for listening to us. And we really hope like this talk lets you think about monitoring observability security as first-class citizens. And if I have like one action item for all of you, which I would really recommend, is go to the CNCF landscape security section, look at those tools, because a lot of those tools have now become, like Ramiro just said, more developer friendly, and you can really like provide them in a developer self-service way, wherein you just configure them once and set them once, like the dashboards he configured for me as a developer. And then your developers can themselves, have the tools to debug problems on their own, and you do not have to cater to each and individual request. So once again, thank you for attending our talk, and we hope you learned something useful.
Thank you very much.
Awesome, the two of you. You left quite a bit of time for questions. So are there any questions? I don't have any. Awesome.
Thank you very much.
Comprehensive, no questions. Great talk. Thanks again.
Yeah.
and welcome back to Rejekts EU 24. I introduce to you this person I don't know anything about, so I'm entirely impartial about presenting the most awesome Kubernetes UI ever. Please welcome Joachim.
Thank you. Right, so my name is Joachim. I'm a software engineering manager at Microsoft. I've been working in the cloud native community for a couple of years now. One of the things that I really find amazing is the amount of projects we have and the pace of innovation that we have in here. So I'm here today to talk to you about how we can hopefully make the whole experience or user experience and user interfaces a bit more coherent. So, like I was saying, we have a very diverse ecosystem of tools. I stole this picture from I think the annual report. And as you can see, there is like a very impressive evolution, right, of the number of projects that we have in the CNCF. And the next one, you probably saw it, it's the landscape. And this is not the whole picture, I had to crop it. But it shows how, how amazing the number of projects and some of the projects have this friendly competition going on. Some of them complement each other. So I think it's it's something very unique, right? And then, of course, on top of all this, each project has their own UI, their own user experience, and that's part of what I'm here to talk about. So first of all, each project has their own GUI or CLI, and that's a good thing. That's how it should be, right? I'm not saying it should not be like that. I highlighted 3 things here that are related to that. So they should have their own UI because that allows them to have a specialized focus. You know what you want to do when you have your project. You know what your users should see, hopefully, and that's the specialized focus that you get when you build your own stuff, right? There's something about independence or autonomy. Instead of depending on one big project, you have some more dependencies. If you work in JavaScript, you have quite a lot to maintain, right? Or to keep sync. Yeah, and the other thing, and all these are connected, by the way, right? But the other thing is that you have your own choice of customization, right? So if you want to have your UI be a CLI with emojis, then you can do that. You don't depend on one thing that will have to support that. So, sure, each project should have their own UI, that's fine. However, having their own UI also comes with some challenges, right? So I highlight 3 of those. Again, they're all related. So one of them is something that I think impacts something that is very important for the cloud native community, which is welcoming new people, right? So when you go and you see that picture and you want to use a couple of those, and they have different user interfaces or user experiences, that of course it will require more time to learn them, I think. So that impacts most, I think, novice users that are trying to learn those tools. There is also something about the context switching. I'm a manager that likes to code. I know about context switching and how this impacts people and myself. And so if you now want to switch, if you have to switch from a tool that is a CLI tool to one that is a desktop application, and then maybe you have a web tool running, you have to switch all the time, right? And related to that switch as well, there's the inconsistency between UIs and UX, right? So maybe in one you have buttons that, or maybe in another you have to right-click or something like that, okay? And now we pause there and we talk about Headlamp. So Headlamp is a modern, hopefully you agree, looking and generic UI for Kubernetes. By generic, I mean that some UIs, I guess, maybe they focus more on the apps side of it, on showing you the apps that you have deployed in a cluster. Others want to show you just mostly the pods. This one is generic in the sense that you can find what you expect. You have a list of events, you have the list of pods, the list of workloads, config maps, all that stuff. And it's 100% open source, and it's a CNCF sandbox project, but you of course already knew because you spotted it there, right? There's also sometimes when you talk about Kubernetes UIs, there's this distinction. So some of them support multi-cluster, others support only one cluster. We support multiple clusters. It's vendor generic, so we don't do things for them to work very well on, for example, AKS or EKS or some other flavor. We try to make things work very well on Kubernetes, right? Another distinction point is whether it's a desktop or a desktop application or a CLI or a web project. In this case, it's both desktop and web. It's basically the same UI, and you can find experience like that when you use, I don't know, like chat tools like Slack, for example. You have the same UI, and you can choose whether to run it on the web or to run it on the desktop. And then, and this is an important thing, it's extensible through plugins, right? So you have the base experience that we want to give to people, that we think it's a good experience for most users or all users. But we also support what we call plugins, right? And these are front-end plugins, so you can change stuff in the UI, and you can interact, of course, with the Kubernetes API, and you can do lots of things. And that's where I'm going with the talk. So in here you can see, an example of a screenshot with the logo slightly changed. And in fact, this application is running as a plugin in Headlamp. So this is the stuff I did yesterday. Yeah. So let me go to the next slide. Yeah. So all of this, I think, can contribute to make Headlamp kind of a unified UI for different tools, for different cloud-native tools. So for example, let me close this for a second. So this is the demo part, so nothing will go wrong. And but it's zoomed in. 1 second. Maybe this is better. Okay. So yeah, so this is the home view. I have some clusters in here. I can go to one of them. 1 second. For example, this one. And in here, even though it's kind of slightly hidden, we already have some, or maybe let's go to this one. It's the same. So for example, one of the tools we are using from the ecosystem is Prometheus. And if I choose one of these, so we have, this part of the UI, the chart that you see there is powered by Prometheus, right? So in this case, it's not a UI for Prometheus, it's a UI that is powered by Prometheus. But of course, if you want to have a UI for, that has more options for people that are used to running Prometheus and do more complex things, sometimes they also want to check the rest of the cluster. They want to go deeper into pods. They want to check the events and see what's wrong. And having this together, I think it's a good idea, right? Yeah. So another one that we have, for example, is Compose. This is a plugin that is not shipped with Headlamp. I actually created it for coming here and having another one for demoing. Let's check, for example, this. This is a YAML that is part of the Docker Compose examples, I think. And I'll copy it. And then I paste it here. And I press to convert, and it will work for sure. It actually worked. I'm happy. Yeah, so if you have run Compose before, this tool, of course, translates the Docker Compose YAMLs to the Kubernetes ones. It's very convenient to use as a CLI, of course, but I can imagine that if you're a novice user and you want to use it, of course, it's a CLI, you have to check the options and all of that. And even though it's kind of an easy tool to use, I'll grant that, probably something like this is a bit more welcoming, right? And it's a bit more, I don't know, guided, right? So in this case, this is also running in the cluster itself. When I press convert, this creates a job. The job runs composed through a Docker. I do certain hacks so it gets the input in and out in a way that I can read it. And then it ends up getting the result. If it fails, we get a nice error, and we don't go to the latest part. If it doesn't fail, which is what it's supposed to do, then we get this YAML. And then, of course, since we are in again a Kubernetes UI, we can just copy or press it here, I guess, and I can just open the editor that we have and start applying stuff in here, right? So just an example of how integrating tools in a unified UI can be, I think, a very positive thing for users that, like me, are actually not Kubernetes experts. Let's see. So let me go back to the presentation. So another one that we have is actually powered by Helm and Artifact Hub. Those are other tools, but that one is not available here. And that's because when you're running as web or when you're running as desktop, maybe some of the tools you want to say, okay, I don't want to allow this in a web environment, only in a desktop environment, or only when it's running in cluster. So I'm actually going to just stop here for a second, stop this process, and run the app. Takes a bit, but it's because it's the development part. All right, so now if we go to the same cluster that I was at, we have another menu here. So this is what I was telling, like, you as a developer, you can, of course, decide, okay, this is not adequate for the web. In this case, it's not adequate for the web because we are running certain things that we want to just run locally, not in a cluster. So this is a plugin that, like I was saying, shows charts. In this case, they come from the Artifact Hub, which is a very nice way of centralizing the distribution of at least the information, and yeah, we call it like the app catalog, but yeah, these are charts. And then we press install, and we can run install from here, right? So it's very convenient. Okay, now I go back. 1 second. It's working now, and let me show you another couple of them. These ones, I have them in video because I was not the one that I didn't configure them, basically. So this one is about Inspector Gadget, which is another CNCF sandbox project about running eBPF tools or gadgets. And that's, I'm not an expert in Inspector Gadget. I don't really understand what's going on in there, and I don't know how to use it. But one of the people in my team is creating this plugin, and if I look at this UI, I know more or less what I'm doing, right? So I don't have to go and check, okay, how do you run this command? What is a gadget? Like in here, it's kind of, if you understand more or less what this tool is about, which is about, for example, running I don't know, like traces in the cluster, understanding, okay, what kind of files are open, what is the latency like, and stuff like that. Then having this in a UI like this, I think it's very convenient. So in the demo, we're running the socket gadget. We choose the node, then we press start. It starts showing us, okay, these are the sockets in the system. You cannot really see it very well, but that JSON that is in there shows you the address, for example. Yeah, another thing is, for example, just another one. This is the TCP one. And again, the UI is very similar, so you can just quickly run it instead of trying to understand what are the options we have for running, right? So this is what I meant by having a UI, and it's kind of a unified in a way that if you have used Headlamp, you know how things more or less work, what to expect. That can be, I think, very, very useful for all users. And the next one, as another example, is Minikube. So Minikube is not really, you know, I'm trying to say that it's different from the others just because, yeah, it's also a tool that you run, but you install and then you start and you stop and all that. And I know that it made my life very convenient when starting with Kubernetes. So we are creating this. This one is still under development, but it's like we are creating this plugin that you can just run Minikube from Headlamp. You don't have to have it installed. You don't have to worry about, okay, I started, what does it do, right? And yeah, and it's basically, as you can see, if you run Minikube, this is basically just running the process and get you the output. But even that part, I think, it's very convenient to have in a UI, especially after we hopefully add more options that you can see right there, like what kind of engine you want for the containers and whatnot, right? And let's see. Let me go back. Yeah, so yes, this is the, if I failed to show all the stuff, but everything worked, so I'm happy. Right, so what about plugins? I showed you more or less what can be done. The plugins in this case, they are done in this way. We have this one package, one NPM package that is still called Kinfolk Headlamp plugin. This will get you started. You can run this command as an npx command and call create. It will create use basically the boilerplate that is needed for creating a plugin. This is the one dependency that you need for your plugin. Then, of course, if you want to use more stuff, I don't know, any other JS package that you want, of course, you can add those. Yeah, and this package also brings, of course, the APIs that you need to interact not only with Headlamp but also with the cluster. So we have a nice and convenient way for you to list pods, for example, for you to apply stuff to the cluster if needed. Yeah, and you can change stuff just like for example, the branding as you see there in the logo. So yeah, so not everything is possible to change, but just because we always try to understand what exactly do developers need, and when we have new use cases from people, we usually try to accommodate those, right? Yeah, so this plugin also grants that the common dependencies are considered external modules. If you have it as a hobby to debug Webpack stuff, this means that you have that the dependencies that are common to Headlamp will not be bundled together with your plugin. So that makes the plugin size smaller, which is important. Yeah, you can check examples that we have in the repo. Every time we open something for the plugins to use, we try to have an example plugin showing how to use that and the documentation. You can also run tests and all that. Yeah, and for a couple of versions now, we have also we created a way for the plugins to have settings for their own instead of just just saving stuff. Now there's a convenient way to do that, and there's a way to show that in a kind of a unified settings for all the plugins, right? Or for each plugin. So that's in there. And one thing that we didn't have until recently is, okay, you create a Headlamp plugin, but how to find them, right? And of course, you have the plugins that we develop, but other people have other plugins. And the way that we are solving that is by using Artifact Hub. So recently we got Headlamp plugin as a format in there, and we're going to use Artifact Hub to be kind of the it's the centralized place to find the plugins. And plugin catalog, we call it plugin store, but it's a plugin catalog. It's currently under development. It's going to be out soon. Yeah, community. If you're interested in interacting with us, that's the GitHub address. Go there, show us why it's not working for you. And if you want to chat, we're on the Headlamp channel in the Kubernetes Slack. And we also have social media stuff. This screenshot that you see there is actually not a CNCF tool. I hope I'm correct about that, but I don't think it is. But it's part of an external company that created this open source plugin called EDP for their own Kubernetes stuff. But I like to show this screenshot because it's actually, I think it's probably one of the most complex plugins out there. They do a lot of stuff, and it's available on GitHub if you search for EDP plugin from this company called EPAM. And yeah, I hope you like the idea. I hope that it makes sense, and I hope to hear from you and that you make lots of Headlamp plugins. Thanks.
Thanks, Joachim. You left plenty time for questions. Are there any questions?
Hey, so thanks for presentation. So my question would be, how flexible is UI to the point where I want to get rid of workloads, networking, like all the tabs which you showed, which are there? Because you talked about adding one, but if I want fresh start, nothing on the UI, is it possible?
If you want to add what to the UI?
I want to develop everything from scratch in the plugins without having anything what you showed in the UI present. Is that flexible enough?
Okay. So yeah, you don't get an empty canvas, right? It's not like our idea is that there is always going to be something in there that is useful for people. So let's say people maybe they want to list the pods. It's already in there. Certain functionality is already in there. But for example, if you want to say, I don't want any of these routes or sections, like I don't want to have a pod list, I don't want to have a deployment list, you can remove those, or you can override those, right? So you can replace completely what the pod list looks like, or you can remove that, or you can add more sections, right? But you cannot just go and I don't know, like, okay, instead of the sidebar being on the left, I want it on the right. Like I said, this is something that we try to accommodate as use cases come. So some of the things, in order for us not to have to support that ad eternum, we were like, okay, we only have these methods for plugins. Then somebody would come and say, okay, actually I need to do this, right? And we check, okay, how can we open that to the plugins in a way that is flexible enough and in a way that will not bite us on the hand if we have to change it in the future, right? So it's a lot of it. It's actually talking to the people that are doing the plugins and trying to accommodate the requirements, basically.
If we have the time, can you show us a couple of community plugins that are really cool, kind of as eye candy, or
Yeah. Well, I can search for that EPM one. I did not prepare for that, but let's say you go to Bing and you press EPAM ADP plugin. There you go, first result. And oh, actually, this is not the, yeah, I forgot to add headlamp. Okay, there you go. Okay, so yeah, I'm not going to show you the full 5-minute video. But you can see that they have their own section and they added quite a lot in there. I don't know exactly, I cannot explain you all this that they are doing, but they actually, like I said, have a lot of complexity. And as you see, like even the branding is slightly different. So I think that's that's what we want. We want people to build on top of this, even if that, and if that means changing the branding, that's completely fine. We want to work together. Let's perhaps show you, for example, how to, what it looks like to just run a plugin. So once you get the plugin, which I will not do for that EDP, I'm sure it's much more complex than this. But let's say you go, for example, let's do one of the example ones. So I go to, okay, you cannot really see this. 1 second. Okay, so you go to our repo, plugins, examples. Then you go to one of them. Let me show you how the UI looks like now. Okay, so this is the UI. This is running. 1 second. This one, and now what you have to do to run is just npm install, which I don't need to do because it's already I already got the dependencies, and then you do like run start. Yeah, and it runs that command that I mentioned, headline plugin, and then it basically bundles everything, adds it to the location, to the standard location where we have the plugins to be run. And so now what it does is to change your logo here. And now if I go to, for example, where is it? Home. I go to the settings, plugins. I got the change logo 1, and this is an example of a setting, for example. So if I add a URL for something in here, let me check. Maybe, I don't know, Wikipedia. I've tried this one before, that's why I'm not risking it. And now I copy the URL. I'm sure you're getting amazed by my skills. Yeah, and you got me to do something that doesn't work. but we changed the logo, but not to the thing that I expected. Anyway, but yeah, like I don't have like a big list of plugins that I know from people. I know some, and I know of some that that use this, but not in a public way. But our idea with the Artifact Hub is that once we have the plugin catalog, then it's going to be easier and also promote that people add stuff to Artifact Hub, and they're going to see it, and users will be able to install it, right? Which right now is kind of a manual process.
All right, time for one more question.
Yes, gentlemen with...
If you could pick one project that isn't integrated with Headlamp today that you'd love to see, or you think would have a lot of potential out of everything in CNCF, and I'm sure you're familiar with every single CNCF project, which one would that be?
I'll bring up the landscape picture and choose just a second. Yes. No, I don't know. Like I'm sure after the talk, what? The GitOps is, and also the, for example, yes, the GitOps stuff is something that we want to have. Thanks for the pointer. No, but it's actually something we talked about in the team that it would be nice. I think the point here is that I don't want to sound arrogant and think that everybody should have their plugin, right? But the point is that many of the tools, they want to also have a way that people can list the pods and do this and that. So it would be nice if they, if they do a plugin for Headlamp, then they can say, okay, we have this UI. If you're doing the common things in a cluster, then you also have access to this tool. That's why I was actually happy to get the Compose one to work just in time for demoing it, because it's one of those that it's also very simple to run locally. but having the UI kind of makes it much more pleasant. But yeah, GitOps is a good one. I don't know. There are plenty in that catalog, and I don't want to choose the wrong one.
All right. Thank you, Joaquin.
Thanks.
We have a 5-minute break, and then we're learning about all the secrets in the universe. one more talk in the Cloud Native Rejekts EU 24. While scientists and astronomers are more interested in the secrets of the universe, Mackenzie, security researcher, is more interested in all the secrets in the universe. Please welcome him to his talk.
Thank you. Thanks, everyone. Do we have the there we are. We have the slides. So yeah, today we're going to be talking about secrets. It's funny, you know, this conference, there's been a lot of really interesting talks about complicated vectors of attack and different areas in a few of them. This is really the lazy man's version of that, of just trying to find secrets and gaining access, but hopefully still interesting. So a little bit about me first. If you're wondering where my accent's from, I'm from Aotearoa, New Zealand, but I live now in the Netherlands, and I work for a French company, just to keep everyone guessing. You can find me anywhere at the handles at Advocate Mac. I'm also the host of the Security Repo podcast. It's my mum's favorite podcast. She highly recommends that you all listen to it. All right, so I'm sure everyone here is familiar, but we'll just race through to get everyone onto the same path. Is what are secrets? So when I'm talking about secrets, I'm talking about digital authentication credentials. And these can be anything, you know, API keys, security certificates, password, peers, anything that gives you access into different systems. And in the cloud-native world that we now live in, these have really exploded in how we use this. We're moving further and further away from building monoliths. We're building these architecture of distributed architecture systems. And secrets are really what holds all of this in place. But the problem is they're highly sensitive. And as hopefully I'll be able to prove, they're absolutely everywhere. And we can find them in all kinds of different places. So a little bit about today, we're going to look at abusing secrets in source control, so how we can abuse them in public places and private places. We'll look at some secrets in containers, and we'll look at secrets in mobile applications. And then finally, we'll have a couple of words of preventing leaked secrets, but that's basically don't hard code secrets. All right, so let's start off with abusing the GitHub API. So this is one of the more interesting parts that the research kind of takes. And my slides aren't showing properly. Never mind. On here, on my screen at least, one forward, one back. Aha! Well, there you go. So last year in GitHub, over 1 billion commits were made to GitHub. So it's a huge data of information. This is just publicly. It's happened in public repositories. There was 85 million new public repositories, and there's around about 94 million, nearly 100 million developers using GitHub. So this is a huge data source for us, but there's lots of really interesting information. So one of the things that we did at GitGuardian is we scanned every single commit that came in publicly to GitHub. I'll show you exactly how we did that. It's really quite easy. And we scanned every commit for secrets. And we're looking for 400 different types of secrets, and we have individual detectors for each one. And if you want to know how many secrets we found, again, I'm only talking about public repositories. The number this year was 12,778,599 secrets in public Git repositories. So this is absolutely massive, and it's a number that's continuing to grow. So if we look at the years that we've done this, when we started in 2020, we detected 3 million, and now we're increasingly going up. Now, some of this is because GitHub's growing, some of it's because we've expanded our search, so it's not all kind of direct native growth, but it's definitely seen a lot more. To be completely honest, we released this report last week, and I really thought the number was going to go down from 10 million. I thought 10 million was going to be the peak and then would go down. The reason being is that some initiatives that came in, such as, for instance, on GitHub, they do key quarantine now. So if you leak an AWS key, AWS is actually finding it, and they will quarantine that key if they find it on there. So I expected that the number would go down, but it didn't. It didn't go down because there's still just so much things being leaked out there, new types of keys, that it's almost impossible to keep up. And this year, there are more companies that are doing more. GitHub's just rolled out push protection, so they will stop you from pushing a key. And when this rolled out, we really expected to also see another massive drop, but it only does it for very certain keys that they can check the validity of. And we've only seen that this probably affects about 20% of what we're seeing at the moment. So whilst I keep thinking that the problem's going to be solved, the problem keeps coming, and it keeps getting bigger regardless. And some of the scary things that we see over this is that we alert people when they leak a key, and we will monitor if that key gets revoked. And after 5 days of us checking, 92% of the keys are not revoked. However, often things happen like they'll delete the repository, or they'll delete the commit, or even rewrite history to get rid of it, but it's still active and it's still being leaked. And there's so many different services that check for this that key is absolutely still out there on someone's data. So how does an attacker find credentials? There's a couple of ways. The first way is kind of dumb, but I'll just mention it because it's the easiest. And that's using the GitHub search function to look for keys. There's a bunch of dorks that you can do. The reason why this isn't very good is that most of the keys that you'll find will be in the history of your Git repository, not in the latest version. The search only looks at the latest version, and you're also going to have a huge number. So here we have 18,000 results. There will be true positives in there, for sure, but it's going to take a long time to do it. A much better method is to abuse the GitHub API for unintended purposes. So the GitHub API is here. It's at api.github.com/events. You don't need any authentication to view it. And this is a public ledger of everything that's happening on GitHub, including things like the committer ID and the committer email address. That is all out there sitting in the public. There's a bunch of events that kind of get listed on here, but the two that an attacker will be most interested in is the public event. This is the most interesting. The public event is when a private repository goes public, bringing with it all of its history. If someone working on a development branch committed a secret, then removed it, it went to code review and no one saw it, that's in the history still. And if you go public, then you will find it. And then the push event is when code is just pushed. But you can filter this via email to find interesting things. If you're looking for someone that's working just at Microsoft, looking just for keys from someone with an @Microsoft email address, or you can even use the APIs to search in the bios of GitHub to look for references to companies. So there is a way to kind of bring this number down. There is, if you're interested to know, what this is what the API looks like, and then as you can see down here, we have lots of different things, including email addresses that come through. So if you want to have a look at basically filtering it, and as I said, you don't even need authentication. You will be rate limited if you start slamming it, but you can get around that by creating GitHub tokens. So quite scary. There is a service, if you want to check if your secrets have ever leaked. I have a file in here. I don't recommend this. But I have a file called secrets.txt. And in here, I have some secrets. And if you wanted to know if your secrets have ever leaked publicly in GitHub at any point, regardless of whether or not they've been deleted, then there's a cool service called Has My Secrets Leaked, or HMSL for short. And you can check this. It will query a database of all the secrets and let you know exactly where they leaked to. Now, anyone who's got any security concerns will probably be squirming in their seats going, that sounds like the worst idea in the world, sending plain text secrets to a third-party service to find out if they've leaked, because I'm essentially leaking them in the process. There is a reason why this is really secure. It's related to hashing and sending partial hashes back, but I won't go into it now. But I can nerd out with you later if you're interested. But that's one way if you actually want to find the opposite. And the best kind of use cases for this is to connect it to like a secrets manager. And if your secrets get leaked, you can automatically kind of rotate your secrets there. But does this ever happen? Yes, it happens scarily a lot. One interesting case is with Toyota. It's interesting because even if you have no relationship to GitHub, your organization probably has some exposure to it. In this case, it was a contractor working for Toyota, working on a project, a mobile application called T-Connect. It wasn't even Toyota. It was a contractor working for them. An employee leaked some keys on their personal GitHub account. So this is really far removed from Toyota, but those keys were for databases pertaining to all the users of that. So this is an example where even though Toyota didn't have a relationship to it, their information was still leaked out. But public information is great because I can present big numbers. 12 million secrets, oh my God. But the really good stuff is in the private code. So as an attacker, one of the things you're always trying to get access to is private source code. So private source code is really leaky. It leaks all the time. And amazing companies with great security posture have had leaks, including companies like Microsoft, who I consider one of the most secure companies, NVIDIA, Samsung, Twitch. All of these companies have had massive source code leakages. And you kind of wonder why. And it's because source code is so leaky, so many people have access to this source code that you just need one malicious employee or one employee to be phished or bought out or anything to gain access to this source code. And in this source code, regardless of what company you work for, you're going to find a lot of secrets. It's just kind of the way of life at the moment. So we do secret detection internally with companies, and so we came out with a number like how many secrets are in an internal company. Now it's hard to put a number on it because you have to kind of pick a number of a company, but if we take an average company with 400 developers, we will typically find 13,000 secrets, 1,000 of which will be unique. So secrets keep sprawling, so they end up in different places, but about 1,000 unique secrets, 13,000 total secrets. Now that same company might have 4 AppSec engineers, so you can imagine their job of trying to investigate 13,000 secret incidents. Who leaked it? What does it give access to? Am I going to break production if I revoke this? All of these things that they have to do. So it's really an impossible situation. So you do the next best thing, which is ignore the problem and hope it goes away magically. But if we have a look at this, Twitch had all of their source code exposed, 6,000 repositories, including all the secret projects that they were working on. This happened because of a simple misconfiguration. Their Git repositories were remotely accessible. And to be honest, they were pretty good in terms of secrets. They were on the better side that we've seen, but they still had 6,600 exposed secrets in their repositories, including 194 AWS keys and even 4 Stripe keys. So, this is a good company, but it just goes to show how often it is. So getting access to this private source code is a huge priority for attackers. I have a funny example here. So one of the ways that people love to get access to private source code is through phishing. So here's an example from a friend of mine called Philippe, who's a pen tester. He was targeting a company, and one of the objectives was to try and get access to the private source code repositories, find secrets, move into pipelines, that type of thing. So he bought a website called getlhub.com and to try and phish them, right? You can probably see this GitLhub was just an exact mirror, so if you went to it, you wouldn't see anything wrong with it. And he was trying to get someone to log into GitLhub. So obviously, he created a nice phishing campaign, phishing email, and now is when you expect me to say that the user clicked on it and he got access to everything. It didn't happen. The user didn't click on the email, and Philippe didn't get access. I know it sounds like a crappy story, but it gets really good, trust me. But Philippe left GitLhub running, right? He'll use it again later on. It's just the mirroring stuff. It's fine. We'll worry about it later. Then something weird happened. Someone posted on Twitter an open source repository but made a mistake and accidentally typed GitLhub. Because it was a mirror, it still worked perfectly and no one found out about it. But then something weird happened, and the search engine started indexing it. And then the search engine started delivering GitLhub instead of GitHub. And Philippe didn't even know about this until one day he found out his logs were all full. And when he went to investigate it, he had tens of thousands of credentials from people that have logged into getlhub.com. Yeah, Philippe is a good guy, but I'm sure this was a very tempting moment in his life as to what to do, But he did bring down the site, and it's gone down now. But that's an example of, how you could get so much access into private source code. Other areas are misconfigurations. So, your .git folder. This is what happens. You go git init, creates a .git directory. This is where all your metadata for your Git repository is stored. All your history, everything is in this folder. But often what we see is that this folder gets accidentally leaked out there in the world. So Cyber News did some scanning, and they found 2 million accidentally exposed .git directories. So this is when you think your source code is public, but you've actually made it public by putting out there your .git directory. So this has happened in lots of where this has actually happened. United Nations had some big breaches where they had a .git directory with some hard-coded credentials. I also found this one funny. They had another breach where they had the .git credentials file publicly accessible, which obviously gave access to source code. But this is something that regularly happens. And I said at the start, this is the lazy man's version of hacking. So to kind of quickly show you how you could go about that, if we take the example of algolia.com, I'm picking them because they don't have any vulnerabilities and I don't want to expose anything. But we're not going to find an exposed .git directory on algolia.com. So what we want to do is we want to use a tool, something like Subfinder, to basically come up with all of the subdomains for algolia.com. And with a little bit of reconnaissance, we're obviously going to find a whole bunch more domains that are owned by Algolia, because it's going to be the test.staging.production.algolia.com that's probably going to have your Git directory and your credentials out there. This is taking a little bit longer than normal. It's coming, it's coming. You're just going to have to, oh, there we are. And so you can get all of these different things, and things like, demo.algolia.com or something kind of server002.lon.algolia, that might be something that's quite interesting. Once we have that list, we can use something like Git Scanner, which is just a really simple tool that can scan for a whole bunch of targets to say, you just jump in your list of URLs and it will try and find, is there .git directories. Maybe vulnerable means that there is a .git directory there. You don't have permissions, but a little bit of fiddling around, you may be able to access into individual files and move their way. So this is a really simple way of finding credentials, and it works scarily well out there. So if you're interested, this is just the process that I took for that one there. So why does this happen? Why in source code are there so many secrets? Well, there's one kind of obvious scenario where when we're building something out, often you go to a developer and you say, I need to connect to this S3 bucket. I need to connect to this service. Here's a key. Can you please do that? And the first thing the developer does is hard code that credential just to check that it works, just to get the connection established. But they're working on their own branch, and that developer's not an idiot, so he removes that key. 100 commits later, by the time it's ready, it goes down to merge, and you're looking at the latest version on the feature branch and the closest version on the master branch, and you don't see any credentials. It gets merged in there, and everyone forgets that there was a secret that was hard-coded, even for just one commit, right? It's in the history. Anyone that's tried to rewrite Git history in a large team will know the absolute torture that it is. So I'm willing to bet that it's going to stay in there for a long time. And then people say, well, it doesn't happen to us because I squash all my commits together at the end. It's still in your garbage bin. It's still there. It's slightly harder to find, but a motivated attacker can still find that, unless you take extra steps, at which point just don't hard code the credential, like seriously. But lots of other reasons. Logs and auto-generated files, debug logs have it. If you people that don't have .git ignore files in there to ignore these logs and different things, heads in there. Secrets.txt, we find a lot of these. And there's examples like Django projects or other projects give you example keys for it. So there's lots of ways that this kind of gets out. But the biggest way is we see people just kind of regularly sharing them on Git because it's easy, right? It's a central place. Lots of developers need secrets. Put all the secrets in Git, happy days. At least, so they think. So it remains to be a massive problem. But it's not by itself. We've also got lots of secrets in different places like containers. So just like GitHub, we have Docker Hub. This is the largest place to store Docker images. There's more than 10 million publicly available Docker images here. And Docker is a great way to kind of ship out your application. But we often find lots of secrets in Docker images as well. Recent research by a German university, RWTH University, found that 8.5% of Docker images contained at least one plain text secret. So they did 337,000 Docker images. They found 52,000 private keys and 2,900 cloud keys, and they did something super cool in the research. They actually connected the private keys to public keys to see which ones are real, so that they were, and what they gave access to, which was an extra step, which I thought was really cool. We also did research on Docker images and found similar results, but this one's better and bigger, so I used this one instead. This is the name, there we are. This is the name of the research. It's publicly available. These are the authors on it if you want to check it out. It's a great read. All right, but how has this happened? Publicly, surely an attack hasn't happened because of a public image and a Docker image. A very big attack happened because of this, which was the CodeCov incident of in January 2021. So they had a public Docker image. It's how you used CodeCov. CodeCov was a code coverage tool that sits in your CI/CD pipeline, checks how much of your app is being tested, right? Does something simple, doesn't have critical functionality, but it is in your CI/CD environment, so it does have access to your environment secrets. Their public image had a plain text hard-coded credential. They had a bit of a weird architecture because that gave access to a Microsoft Drive, I believe, that had a bash uploader script. CodeCov, the application, would call this bash uploader script in certain cases to be able to perform different tasks. That key gave read-write access to that bash uploader script, and the attackers were able to use that to turn CodeCov malicious. At the time, there was 20,000 targets that were affected by this, including things like Rapid7, HashiCorp, Monday.com, Twilio, and the attackers were really after one thing. What this malicious line of code that the attackers did was it said, every time CodeCov runs, dump the environment variables and send them to me, the attacker. So dump all the secrets, send them to me. Now, some of them are saying, oh, that wouldn't happen to us because we use staging secrets in our test environments, not production secrets. A lot of companies that would be true, but the attackers were after one particular type of secret, which was the GitHub access keys. They wanted access into private source code, in which they were able to move. Now, very rarely do I ever pick on companies and breaches, because I truly believe it can happen to anyone. I'm going to pick on one company, which is HashiCorp. I actually think HashiCorp is a great company. They build great products. Don't sue me. But I will pick on them for 1 minute. HashiCorp created a product called Vault, one of the best secrets managers available on the market. And their whole pitch to this was that if you use Vault, you do not need to hard code credentials. Developers do not need access to credentials. The attackers made it into HashiCorp's private code repositories via the CodeCov attack, and HashiCorp had to announce that they had secrets that they had to revoke in their private repositories. If HashiCorp has secrets in their private repositories, absolutely no one is safe. So the first thing, if you want to have a look at, is why does this happen? A lot of people think that Docker images and containers are these magic black boxes. This is probably a little bit rudimentary for this audience, but if you use a tool called Dive, you can have a look inside a Docker image, and what you'll see is as we move through the layers, we'll see in green all these files being added. Right? These files are just source code. If you have, it's not some magic black box when you create a Docker image. There's source code in there. It may not be human readable, but it can be reversed, and if you have a secret in there, it's going to be in there. So you can kind of understand it. These aren't magic black boxes. And we can very easily take a look at that. If you want to have a look at how to scan a Docker image, I can just use a tool here called GG Shield. You don't need to decompile or anything. You just put the Docker image that you want. It will save that Docker image from Docker Hub. If it's not there, it will scan it. I think the internet's quite slow, so it might take quite a while. But inside this Docker image is a bunch of, oh, no, there we are, didn't take very long. A bunch of test keys. This is how easy it is to find out if there's secrets inside a Docker container. So we're not talking about any kind of special techniques here. There's lots of examples as to why this happens. So, for example, I saw a lot of systems where they had something like a netrc file, which was to connect to a package manager, and in their Docker file, they would add this file in, but then remove it at the end. So they would add in the credentials, use the credentials, and remove the files. But like history in your Git, you have history in your Docker image as well, so in your Docker file. So that credential is still in there. But lots of other reasons, and honestly, just a lot of hard-coded credentials for no real particular reason. The last thing that I want to talk about is finding secrets in applications. This is a little bit like off topic for this conference, but it's absolutely wild, so I'm going to talk about it anyway. But what are mobile applications? So when we look on the Play Store, we see all these. What are these? These are glorified zip folders, right? That's what they are, and that you can get back. A lot of people seem to think that once you create an application, that's it. No one will be able to read that apart from your mobile phone. It's not true. It's extremely easy to get back to the original source code from this. So, and this comes from the assumption that all things non-human readable are secure. But that's absolutely not true. And we find a lot of this when it comes into looking for secrets. So with Apple, we have an IPA file. With Android, we have a .apk. Apple's slightly harder to get back to the original source code. You can literally turn this into a zip and unzip it, and you'll get access to a lot of files, but not the core binary. But the Android, you can just decompile that and get right back to the source code. So if we have a quick look at how to do that, I have an Android app in here in my folder. If we wanted to have a quick look in this, then we can use a tool called JDAX to decompile this. And in a few seconds, we'll get right back to the original source code of this Android app, which we can start to see here. And the files that we're most interested in are things like the Android manifest.xml or the strings.xml. So once we find these, we can very quickly start looking through this and try and find any secrets that we might have. So the Android manifest is one that comes up. So really easy to get back to that. We can also scan this now for secrets. This is a real app. I'll come back in a minute to this. This is a real app that I got from the Play Store that I did. I've obfuscated the name and I've removed and I've hidden all the secrets, so I'm not exploiting any vulnerabilities. But this was absolutely, what happened here? But this one was absolutely wild of what was in here. I'll come back in a second because I'm running out of time. But this is just the workflow that I used to get into here. So super easy, right? None of this is particularly amazing. Are there breaches where this happens? Yep, lots of them. This one was shared on my podcast, free plug, by Jason Haddix, who was looking into mobile applications. He was doing a pen test on a bank, and this is quite a large bank in the United States. He discovered that the bank was taking images. You could take an image of a check, because you still use checks in America, and you could cache that with your mobile phone. Those images were being stored without being encrypted on the phone, and then they were being sent to an Amazon S3 bucket, of which the hard-coded keys were in there in the app, right? Now, why on earth would you do this? I guess it comes down to thinking you're being efficient, because if you had to go through the back end, that's another step, right? Just connect directly to the bucket. But obviously, we all know that that's insecure. But how many secrets are in mobile applications? Again, Cybernews did some large-scaling scanning, and they found about 56% had hard-coded secrets. Now, this is a big sensational number. There's a little bit of context in here because it doesn't mean that 56% have vulnerabilities where I can get into their infrastructure and get into their buckets, but a lot does. The number one key that they found was Google storage buckets, but also things like Firebase URLs. Now, these aren't sensitive by default, but if you have a misconfiguration, they can be pretty catastrophic. So huge numbers of secrets that we find in mobile applications. And if I go quickly back to it, here is the application that I scanned. We have some Slack webhooks here. I have some Google APIs. This one is valid, so it lets me know which ones are valid. We have some more Google API keys. I have a valid Slack webhook. This is great for phishing campaigns because you can post directly into a Slack channel. So, really good things. There's even valid Facebook keys, OAuth, Google OAuth keys, lots of good stuff in here. And that was, I just downloaded 10, and that was kind of the second worst because the worst one was too bad to show you. So how do we prevent this? Well, the number one reason is to don't hard code your secrets, right? But it's going to happen anyway. Your developers are going to do it, particularly momentarily. We also should be using the correct secrets manager, which may not always be the best. It's counterintuitive, but use the secrets managers that your developers will actually use. So up the top, I've talked about it. Things like HashiCorp Vault are amazing, but they can be very heavy. And so if you don't have a team to manage that properly, maybe that's not for you. There are SaaS providers like Akeelis or 1Password has some good ones for there. Your cloud features have secrets managers, and these are great to use, particularly if you're already familiar with them. And then if you're going to put secrets in Git, please don't. But if you are going to do it, and I can't convince you not to, please encrypt them first. Right? There are tools out there to encrypt your secrets. But that is not a good secrets management strategy. I just want to be clear, because that gives you a single point of failure. Use automated secrets detection. I work for GitGuardian, so I'm wildly biased, but they're definitely the best. But there's also open source tools, Trufflehog, Git Leaks, Yelp Detect Secrets. There's no excuse not to do secrets detection in your pipelines. Use Git hooks, rotate regularly, limit privileges, whitelist services. So just zero trust stuff. And with that, I've come to the end. So thank you. Here's some QR codes. Oh.
Thanks, Mackenzie. I feel a lot less secure now. We have time for one question.
Do you know if your tool is used for capture of flag?
If our tool's used for what, sorry?
For CTF?
Capture the flag. Oh, yeah. Yeah, our tools are. We actually have some CTFs that were in there. And we have. There was one incident where it caused a little bit of trouble too, because there was a pretty widespread breach that happened, and then in the investigation it found out that our tools were being used by the bad guys, which was a little bit difficult to explain. But at the end of the day, we have open source tools. People are going to use them. Thank you.
All right. Thank you, Mackenzie. After a short break, we will remain in the world of catastrophes, and we're talking about data loss. Can I ask you folks Hello again to a new talk in the Cloud Native Rejekts EU 2024. Please welcome Anais and Michael on massive data losses.
Awesome. Thank you. Thank you, everybody, for joining and staying at the conference. So this talk is the bang when bad things happen to your data. Just a quick disclaimer, all personas and entities referenced in this presentation are entirely fictional unless we stated otherwise. However, the security events described are based on real-world events, occurrences. We just modified a few parts to them. Now, my name is Anais Urlich. I'm developer advocate at Aqua Security within their open source engineering team. I contribute to their open source projects, Trivi and Tracy, and also Kate's GBT, which is within the CNCF. I also have a personal newsletter, and I publish tutorials on my own YouTube channel.
Yeah, hey everyone, so I'm Michael Cade. I'm a technologist at Veeam Software, where we only talk about bad things around your data. Also from an open source perspective, so projects like Canister that's just been donated to the CNCF as a sandbox project. I'm also the author of 90 Days of DevOps, which hopefully many of you are aware of. Yeah, let's get into the fun stuff.
Awesome. So here's, in short, what we're going to talk about, what this presentation is all about. When you develop your application, you build new features, you're deploying your application stack, and then you're managing it. At some point, you will encounter the bad stuff. At some point, you will encounter the bang, as we reference in this presentation. So there's a lot that you can do beforehand to prepare for that bang and to be more ready as an organization within your runbooks, within your processes, and also the application stack that you've set up. We heard a lot about OpenTelemetry and how that can help you identify when things actually do go wrong in your application. But then also, once the bang has happened, what do you do afterwards for the remediation? So both of these aspects are tightly interlinked. What do you do before to prevent it, but then what do you do afterwards to recover from it as quickly as possible and without too many people realizing? So we introduced to you Rejekts Game Development. That's me. I'm from Rejekts Game Development. I invite you all to check out one of our latest games, Pac-Man. You can go here to the link and play. if you have your phone in your hand. And this game is actually, it's based on the GitHub repository that you can see here. So just a quick shout out to the original developers that this game that we provide today is based on. So I'm the software supplier in this scenario. And I'm working on the software supply chain and everything that goes in. So basically anything that's involved in me developing Pac-Man is part of my software supply chain, is part of me making sure that everything runs smoothly, that we can develop and deploy, update features and release features to our clients in a quickly and accessible manner. That involves developing the code, the ACD pipelines we have, as well as the testing that we implement. So this is our quick overview of our stack. We have a MongoDB backend and a Node.js frontend, all running on Kubernetes, and we call this Pac-Man as a service. Now, our technical solution from a security perspective involves 4 main components. One of them is security scanning, compliance checks. So we are checking our code base and our configuration files, whether they're compliant with certain benchmarks within the industry that define best practices. Then we also have set up our own policies to enforce specific rules that we want to have as an organization. And we implement continuous monitoring of our application stack on your own clusters as we develop our application. So here are some of the solutions that we integrate with. We're using Trivy, an open source all-in-one security scanner for scanning on the local development machines, but also on our CI/CD pipelines. For compliance checks, we're using CAS benchmarks. And then for policy enforcement, we're using Rego from OPA, which is in the CNCF, and there's an alternative that you could use on your Kubernetes cluster as well, in addition, called Kivano. And then we also have, as part of continuous monitoring at runtime versus static scanning that you can do continuously of your deployed resources. Now, in addition to that, we also take great care in actually training our new employees. So everybody goes through a comprehensive program to know about all of our security standards. And then we also have a very comprehensive policy handbook that we hand out to everybody to study. Now, in terms of the distribution, this is how it looks. We basically provide conference games, which is one of our clients, one of the vendors, with Pac-Man in this case. And this is a Helm chart that we release, and they then deploy and run for their conference games. Now, in addition to that, as a supplier of my software, I can do several other things from a security perspective to provide the clients, the vendors, with further reassurance of what vulnerabilities might be present in the code, in the software that I supply, and also what steps they can take in case there are security issues. So VEX is fairly new in this space and basically details that if there's a vulnerability in the software that I provide, then I can release a VEX document and detail how does the vulnerability actually affect that software that I release. Now, this talk is not going to go into more detail, but I'm sure throughout KubeCon there are lots of other amazing talks related to the topic. And then I can also release SBOMs, software bill of materials, that detail all of the dependencies, everything that's part of my application that I release. So even though my clients only get the release that they actually deploy and run, I can also provide them with an inventory list of everything that's within that release. And before we move on, I'm just also going to give a quick demo of everything that I've part of my software supply chain to, here's the game. More? Okay, cool. So first of all of everybody who is part of Rejekts game development is required as part of our runbooks to also do local security scanning before they actually push changes to Git. So we encourage everybody to do file system scanning with Trivy, and that will show the developers, the engineers, first of all, if there are any new vulnerabilities that they have added to the code base, but also if there are any exposed secrets, for example, if they included anything as part of their testing. Oh, you can't see it.
Just go down a couple.
Okay. Can you see it?
If you run that same command again.
Okay. Cool. Okay, so Trivy file system just scans the local file system. Now, this being a Node.js project, this is pretty impressive that there are no vulnerabilities detected, which is what we want, right? So this is our standard, 0 vulnerabilities. Now, something else we can do, we have actually, as part of our security policies, we have developed a Rego policy that basically specifies what container images are allowed to be part of our Docker file, for example, as part of the base image. So we verify that only the base images that we have approved are actually part of then the Docker file, in the Docker file, and are then actually part of the release. Because everything that I include in the Docker file in the different layers will ultimately end up in the final version that's going to run on the different machines. Now, I can check this policy against my Docker file in this case, just as an example of one of the policies that we implement. And that's also done with the Trivy file system command. It's just a bit longer command. And basically here we pass in, we say that we want to have a misconfiguration scanner, so we want to scan all of, in this case, our Docker file for any resources that are anything that's misconfigured. It's not configured as part of best practices within the space or as part of our policy, and we pass in here the policy to scan that Docker file. Now in this case, we have here our own policy that we defined. So we can't use the node latest image. We have to use the current image for node, for the node base image. And then also in the same time, the best practice in the industry tells us basically that we should define a tag as part of our base image. So we can do that instead. So this is just one of the scanning we do. Then also as part of our CI/CD pipeline, we do continuous scanning of our container images of the base image before we actually build the container image. And then further down, we also implement security vulnerability scanning of our built container image. And then we generate as well an SBOM of every new container image that we built. Now, as part of the file system scanning, that's also something we do every time we merge new changes into our main branch. In this case, our main branch is called Rejekts. And then we also upload the vulnerabilities, if there are any found, into the GitHub security tab. Now, lastly, before we release any new software, we also scan the Helm chart that's ultimately released to our clients for vulnerabilities. So these are the different steps that we take from a supply chain perspective.
Awesome. So that was very much the prevention. How does a software company deliver a more tighter security model when it comes to releasing their software? Now, I'm the user, the buyer of the software, so I'm using the Helm chart that is deployed out of the back of that software that enables me to run my conference games, Pac-Man as a service out there. You could argue that it could be called YOLO games instead of conference because I'm just using the defaults, and that's what we're going to get into, is that it's very easy to get a default application up and running from a Helm chart without really looking at all the Helm chart values, and it's really just about raising awareness of what the defaults aren't probably the most secure. In fact, I would argue that they're definitely not the most secure in most instances. So hopefully with that rejekts.upthestack.io, hopefully some of you have added some critical information to our, there's some giant swarm guys in the room, good stuff. So, and feel free to play on my newly created Pac-Man as a service, PAS. But ideally what we want to show here is, so I've spun up an EKS cluster using Terraform. I'm going to touch on that, what that means from our side as well, as a software or as a gaming engine, which is quite fitting given the location that we're in. And with that, we're going to start picking away some of the vulnerabilities. And the reason why I'm stood down here in the heat of the lights with a hoodie on is because I'm going to flip into a different persona, and we're going to cause some problems and cause that bang that we spoke about. So hopefully, okay, some more giant swarm guys, awesome. Clearly you've been spending a lot of time and not listening to Anais. Bad of you. Bad of you there. So before we kick off, so one of the things that we've got is obviously Pacman is exposed. That Node.js front end is there. That's what we're serving out to the internet. But if we take a look into the terminal, if we clear this but jump down and we do a kubectl get service and we look at the two services, please don't copy this because that will ruin the demo. The external IP that you see here, one is the Pacman, so the Node.js front end, but the Helm chart that we're deploying actually exposes this service, which is our MongoDB backend. So what that means is that, and when I look at the Terraform, you'll see some more mistakes that have been made in YOLO games. And if we look, I've got MongoDB Compass connected to that. Yes, I have authentication into that, but ultimately, we don't really want to be exposing our mission-critical data, them being the scores, out to the public, just internal to the Kubernetes cluster. So what we first want to do, now that we've got some high scores and mission-critical, what I want to make sure is, as part of that right of bang, that remediation, we want to make sure that we're secure and protected if bad things happen. And let me give you the spoiler, is that bad things are going to happen, so we better take a backup. Now, normally you would integrate this into your CD pipeline to be able to run this on a bespoke schedule. I'm doing this here because I want to prove that I'm taking a fresh backup of our application. So let's just run that, and then what we'll do while that's running is let's jump back into our terminal. Okay, we're going to have to do some diving around. So let's go here, let's go into, because I literally just went onto the Terraform site and downloaded the Learn Terraform Provision EKS cluster. And obviously with that, there might be something bad in there that causes us. So I'm going to run Trivia again against my ISE. Again, an open source project that everyone should be using, or at least having some insight into this. And you can start to see network rules on my EKS cluster are pretty open. The whole CEDAR is open, 000, bad practice. But again, Terraform, it's not really Terraform's fault. It's for their learning modules. So, but again, this is how I built my EKS cluster. YOLO games, right? Hopefully by now, we should have a backup. And so under the hood with this backup, so I'm using Casting K10, and we're leveraging Canister. Canister is an open source application framework that allows us to dive into the data service, the database in this instance being MongoDB. It allows us to run a pre and post hook so that we're pausing I/O and stopping that transactional, so that we're taking a good, clean, consistent backup. And we're sending that off to S3, an S3 bucket, which is an immutable bucket for that. But if I just show you what that blueprint looks like, and we can use Canister as a standalone tool, but there's no scheduler, there's no orchestration. What K10 allows me to do is orchestrate everything in one place against multiple different data services. And we can even use things like pgdump when it comes to Postgres as well to orchestrate that. But ultimately, what we're doing with this blueprint, it's really saying, this is what I want to do at whatever point. So if it's a pre-hook, this is us telling we're going to take a backup, pause I/O, and then we're going to release that after the backup is complete. Now, hopefully, our backup is complete. We're getting there. So the snapshot is completed. We were actually just upstairs at another session where it was talking about CSI and backups. And actually, the first question was around snapshots not being backups. And I fully endorse that. It's not. But snapshots are a very good way in which we can recover very quickly versus having to go off to our S3 bucket to pull back that data. So I want to leverage both of those, especially EBS snapshots that are quite durable. I want to be able to use that. So what we're doing is we're sending our backups of our mission-critical high scores with the giant swarm guys. And you can see in here that we're using another open source project called Copia to basically lift and shift that data in a consistent fashion off to object storage. So you can see we've got our Pacman backup in a load of blocks, load of blobs into our storage. Okay, let's. I don't know if I can put this hood over my head and cause a notice now that I've transitioned into a bad person. Remember that I've got my service exposed, and then let's just say, for example, we've lost well, we've given away access. Access can be bought online, and I'll touch through this and recap on the slides as we go through as well. So if we jump into VS Code, in fact, no, terminal. Don't want you to see any of these credentials. So CD is really hot in here. And an appropriate hacker directory. So I have two scripts that I'm going to run. One is a bucket attack, so I've been able to get hold of my S3 credentials. I can buy them online. If you go on the dark web, you can pay for anything from $500 up to $10,000, depending on your target. Don't ask me how I know all of this. And then the other is that DB attack. So that service being exposed means that, well, really anyone can get it, because obviously my secret is just stored in a Kubernetes secret, base 64 in decrypt. Job done. I can get into that. So let's do the DB first. Okay, so we're connecting to that MongoDB. We've found your database. We've connected to it. The Rejekts is the name of the hacker group that I'm part of. The mission critical data has been compromised and encrypted. And if any one of the Giant Swarm guys are still on there, if you go and look at your high scores, and I'll do it with you. Oh, so the top one now, so Giant Swarm haven't won anything today. Everything's been encrypted. The Rejekts hacker group have control of this data, or do they? So really the key part there is obviously the database has been compromised. Actually, when I've run a couple of honeypots around MongoDB being exposed to the internet, and it's amazing how fast. I was actually really nervous coming into the demo that we actually might have been attacked for real. And I'll show a live example of that in the slides as we get into it. Did I say it was hot in here? Okay, so let's then run our bucket attack. So I showed you our existing bucket. So it's going to connect to our S3 bucket. We found the bucket called Rejekts Immutable, and we're attacking that bucket. Oh no! I don't really want to show you the M for that. Or do I? In fact, I could put it to the top line, then you won't see it.
Oh, no, they have to, wait, they have the screen there. So you would have to unplug it. And just unplug it. You see?
Don't worry about that. It'll be gone before you've even copied it. Don't worry, YouTube. This won't matter afterwards. Anyway, I've got to be quick. Right. But it doesn't matter because we've got a backup and it's immutable, so it's fine. So I've just encrypted it again. That's a bad thing. And then let's do the bucket attack. Love a demo. Love a live demo. Okay, so the objects are deleted. If we go and check that in our bucket, which has probably kicked me out already. Okay, bad times. We don't have any backups, but we're sending our backups to an immutable. I can finally take this off now. We've been paged. It's 2 o'clock in the morning. Bad things are happening. People want to get on Pac-Man. Luckily, we have show versions, immutability. We have object lock enabled. Good stuff. So we've got our backups. Okay, so let's start that restore while I then jump into some of the slides. So I go to application. Again, this is going to use that MongoDB blueprint to bring back that application in a consistent state. Let's make sure we choose the right one. And before anyone actually gains access to my cluster, let's restore that. Now, because of time, I'm restoring everything back as it was. So this is going to actually restore the whole application. I can be granular from a K10 point of view. I can bring back just that PVC with that database, or I can bring back certain individual items. I can also transform what that application looks like. So one idea would be is let's not expose that database anymore via a service. If I do a clear and a watch, we should start to see, one, we're bringing down the whole application, and then we're bringing up the good copy, the one before anything bad was to happen. Just so that you see that. Okay, so, and now what we're doing is we're going to bring that back from S3 into our EKS cluster and restore that. Then in an ideal world, that service, we should actually fix that in our repo. so that we're not deploying that software again or that service again as in an exposed fashion. So fingers crossed, as long as anyone hasn't used those keys to get in. And to be fair, if anyone has on their phone, fair play, that's very quick. Now I'm nervous. So if we go to the dashboard, we can start to see. Okay, so something is restoring, that's good. So what we'll see here is what Anaïs talked about was we're going to see that Node.js front end, and we're going to see that Mongo database pod come back up. And then everything else will start getting it back into that desired state, and hopefully the giant swarm guys are going to be back on top. Okay, good. Phew, no one's deleted the cluster just yet. Again, YOLO gaming. So fingers crossed, and I'm sure the giant swarm guys are refreshing that web page just to see if they're back in. Okay, the moment of truth. If we go back here and we look at our high scores, oh dear. Oh dear. Oh. Okay, that looks good. That's a success. But we should never really get to this point, right? So ideally, you want to lock down that service. You don't want anyone to gain access to that. So whilst I jump back to the slides and think about how people are using my AWS credentials that only have access to that bucket, but still. So one of the things, what can bad look like? You saw, so from an access perspective, from a database perspective, from services, just from default configuration. I don't really know anything about Kubernetes, and I just went and did Helm repo add and then Helm repo or Helm install, and I now have Pacman, and I started selling that to you guys to go and play with that game. What I also made sure, though, that I do have a backup of that. So from an access point of view, what does that look like? So ransomware is pretty hard, right? If you're going to concentrate your life career on exploiting and extorting companies and getting that money from them from a ransomware perspective, then you're going to have to find some sort of entry point. You're going to have to compromise some sort of user account or authentication within that business. You're going to find some misconfigurations, and then you're going to find some way of being able to get into that environment to cause damage. Or you could just go and buy it on the dark web, like I mentioned. And really, you could go from anything from $300 that will give you an SSH into a random company, or you can pay a bit more of a targeted approach and pay up to 10,000, and I'm sure there's much more than that as well. You can target by industry. It's basically a shopping cart to find access to a business, because we all know there's vulnerabilities out there that can be exploited. I'm going back really to the end of 2022 when we started to see what ransomware, what cyber attacks look like from a Kubernetes point of view. So Hildegard was a malware attack on Kubernetes, which would not necessarily extort data and ask for ransom, but they would take over that compute and they would start scaling up that cluster, and they would start to leverage that to mine cryptocurrency on your Kubernetes clusters. So it's been around for a while. This is a live picture of my honeypot that was an unsecured Mongo database. It was actually Pacman again in that demo. It was publicly accessible, misconfigured, encryption. Again, it was the default. Defaults aren't always good. We all have backups, don't we? And that's a question. But equally, so we've done the bad thing around like the hoodie up, the hacker, the cyber threats. But equally, we all make mistakes. We make accidental deletions and corruptions to our database, our data services, and generally that's the mission critical. Over lunch, I was talking to a few people about how many people have dropped a database in production. Yeah, I imagine quite a few of us have done such a thing. But it's not all bad, because we've obviously got, and a lot of the talks today have been the doom and gloom of bad things happening, which is great that we're raising awareness of it, but we have to consider how do we fix that? And we have a whole, to coin Engin's vending machine, we have a whole vending machine of security products and projects that we can take advantage of, but we have to think about what that access looks like, what that control looks like, but equally, what does bad look like for you and your application out there? And then think about that offsite backup location, that immutable that immutable location. And A's, I'm still conscious about my AWS key.
Oh, you need your laptop. Yeah, so this was just a demonstration of things that could happen, as well as, for example, me as the vendor providing insecure default configuration, providing the services as load balancers, and not thinking about them actually just taking the default configuration and going ahead and deploying it. Now, here are some of the resources that we've used, so you can check those out. Different resources as well as the main application. And then this one is just a set of lots of different, like a long list of how different misconfigurations led to entire databases and millions of records being exposed by hundreds of companies, which is super interesting. So 2021 data. And I have a KubeCon talk on Friday, actually, jumping in for a coworker if you want to learn more about S-bombs and how you can leverage Harbor to manage your S-bombs. Thank you.
Now I need to get onto the console.
You have any questions?
Thank you both. We're running a bit late, but we were encountering technical difficulties before we started. So I'll say there's room for 2 questions. Any questions?
How? No, that's a ghost. That's a ghost image. That's not what's on the screen.
Oh, yeah.
Yeah, are there any questions?
Are there any questions?
Yeah, in a second, no worries. As soon as I've deleted it.
Yes, I know you need to change it.
All right. We'll have a number of 5-minute talks after
What's
this.
that?
Oh, there's one question.
Yeah, exactly. I don't know if it was streamed.
It was?
I think so.
Yeah.
All right, no one accessed it. Thank you. That was my TED talk.
Hey guys, thanks for the talk. I just have one question regarding your MongoDB honeypot. How long did it actually take until it got accessed, and what did these guys do with it, and what did you do afterwards?
So it was really about it. So it was for a demo, similar to this. It was 8 minutes. So where there's a port scanner around the particular MongoDB port, it's 27,000 something, I think. There was obviously something happening at that point that picked it up, and yeah, that's when they encrypted all the data in there. Now, luckily, working for a backup company, I had a regular cadence of backups that were happening, so I could restore it just in time to go on stage and do the talk. But yeah, it was a fun little project. So I actually, so there was a ransomware message in there and a Bitcoin address, but I didn't hang around too long. I went and closed the service off. I went back, I restored it, and then went and did the session. So I didn't really dive into it as you would normally from a honeypot point of view. But I imagine it was very automated in that they're going to do a port scan, they're going to find the vulnerability, they're going to jump in, they're going to encrypt your data or take your data as well. There's a lot of exfiltration threats out there as well at the moment. But yeah, that was fun.
Thanks, Michael and Anais.
Awesome, thank you. Now I can take this hoodie off.
First speaker is MJ from Cast AI. Let's give him a round of applause. Welcome.
Okay, can you hear me fine? Okay, so this will be shortest 45 minutes presentation in 5 minutes, unlocking new possibilities, bridging Linux and Kubernetes. I work at Cast AI. We do cost optimization and Kubernetes automation, and I'm a maintainer and contributor at kcp.io, and this presentation is based on that. So does this look familiar? Like, we use Linux file systems, we daily basically traverse file systems, and we take it for granted. Like, this is built in our daily routine. And what if we start doing same things in a Kubernetes land? So this is where I'm traversing workspace tree in KCP, and I'm accessing some of the workspaces. I can list my pods, I can do a home directory, and wait a minute, that's the longest slide on this presentation you will see. So I can go to some other workspace and to see some API resources. And you might think, what is workspace? So it's the wrong question. What is KCP first in speed dating style? So what is KCP? KCP is Kubernetes control, shorter one. In short, it's nodeless, podless Kubernetes API server, which can host many clusters globally with sharding. So again, what is workspace? So this is your usual Kubernetes cluster, which you all know, love, and use. Basically, you have some etcd in a corner, a few namespaces. You can deploy some operators, these two guys in a corner, some pods, happy days. Put it aside where KCP is. So KCP has this additional concept of workspaces. So now you can see you can have multiple instances of virtual clusters. So CRDs objects are namespaced. And so basically, it's a multi-tenancy in a Kubernetes API server. And I mentioned, so a bit of cleaner image to have that. And I mentioned sharding. So now you can have multiple KCP instances wired together from the API standpoint to do, and you have all your usual operators and things like that. In addition to that, we have some other machineries too. Instead of running 20 operators around 20 clusters, you can have one version running them all. Cool, so workspaces. So workspace is Kubernetes cluster-like HTTP endpoint, which basically you can do everything what you can do with Kubernetes without nodes and pods. And workspaces can be nested like file systems, and I have no idea where my picture is. And you can mount things into workspaces. So how does it look like? So KCP doesn't have pods and nodes, but that doesn't mean you can't bring those things into KCP. Meaning now you can start mounting your Kubernetes clusters into the KCP hierarchy, and that becomes like very familiar to like Linux file system, where you can mount remote devices, file systems. Just here it's remote clusters. And again, picture is gone. We're looking how to potentially do even more, like mount single namespace from remote clusters into one workspace, where you would be able to see that. So how does it look like? You create a workspace in KCP. It's ready. You mount it by providing local context where your remote cluster is. And that's it. So want to know more? Basically, we are a CNCF project. We have new kid on a block. We meet bi-weekly in our community meetings. Thursdays, you can hit up on Kubernetes Slack, KCP Dev. And if you have no idea what I talked about, I just put my doggo picture, so you look at that. If you want to know more, catch me after the presentation, and I have 45 minutes to spare.
Very good. Very well done. And even finished early. That rocked. Next up, we've got Edith, who comes from Peru but lives in London. She's going to be speaking about operators. Can we give her a round of applause to welcome her to the stage? Yes. She's going to get set up. All right. Edith, you even get an extra 30 seconds.
Hello, hello, hello. Could you hear me? Yes. I cannot to myself. Okay, let's start. Hi everyone, this is Edith Pugja from Peru, Tech Evangelist at Percona and CNCF Ambassador, Docker Capian. I moved UK the last year with a global talent visa, and I also contributing to translate Kubernetes website from English to Spanish. I will talk today about Kubernetes operators, but let's start with a little bit of history. 8 years ago, CoreOS introduced the operator framework. The operator framework is an open source toolkit for Kubernetes native application called operators. With the time, this gained traction. Why? Because with the excellent way how we can manage complex Kubernetes applications in an effective, automate, and scalable way. How Kubernetes with the operators works? We have the control loop, which is the core concept in Kubernetes. The control loop observes the state of the cluster, compare it to the desired state, define it by a user, and take the actions to reconcile these differences. Then we have the user that creates a Kubernetes resource or default resource, also called as a deployment, and we have the YAML file that specifies the desired state and for the deployment resource. The deployment is deployed in the Kubernetes cluster, and the control loop entering action to match this current state of the cluster with the YAML desire. But what happens now if we want to scale our application, make some changes, set secrets, and environment variables? We will need to create new Kubernetes resources or edit the existing ones. So we need to add something and change something with it, which looks like a lot of work. Now let's see how Kubernetes with operators works. We have the same control loop. For this, we need Operator Lifecycle Manager, or also called OLM. The OLM is part of the operator framework, which is a set of tools designed to manage the lifecycle of the Kubernetes operators. Now we install the operator, which has two parts, the custom resource definition and the controller. The custom resource is where we define the behavior for the new Kubernetes object, and the controller is similar to the control loop, but acts over the custom control definition. Let's say that we want to deploy a custom application. Instead of running multiple objects, deployment, secrets, posts, or services, we need just a single file for a single resource. And we deploy that single resource in the cluster, and the operator takes over that. The operator interprets the custom resource definition and starts to create the objects. Also, the operator manages the control loop and monitors the state for all the application. This is definitely a better approach to managing complex applications in Kubernetes, because as an end user, we need just to worry about a main custom resource. We can use Kubernetes operators for stateless or stateful applications, but more and more people now are using them for stateful applications. This is the case of the databases. Running database in Kubernetes cluster over time is challenging, especially when we talk about the day 2 of the Kubernetes application lifecycle, when we need constantly to optimize the application. There are many operators over there for different categories, and they are all in Operator Hub. This is similar to Docker Hub. You can find operators for databases, monitoring, security, storage, and most of them are certified by Red Hat OpenShift. How do I create my operator? The operator framework provides an SDK to build your operator and instructions also for certified this as well. The operator framework also indicates how to reach each capability model in our operator. A capability model indicates the maturity of our operator from level 1 to level 5. For example, here, the database for database operator for MySQL, the maturity is the number 4. If you're curious about operators for databases, check our open source Percona Kubernetes operators for MySQL and also Percona Everest that gives you a graphical user interface to create database Kubernetes clusters. And see you at KubeCon, where we are raffling this Lego in the booth F17 in Percona. Thank you.
Very good.
Did it on time.
Excellent job. Yes, 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 yes. Rocked. Rocked. Absolutely amazing. Also, is anybody else accustomed to doing a talk in a second language or a third? Raise your hand. Yeah, it's hard. So let's give her another round of applause for that too. That fucking rocked. Good. Next up, we have Joao. Do we have you? Very good. He's going to be joining us to speak about Cell and all things wonderful there. So that being said, is anybody's first time at Rejekts? Raise your hand. All right. Wow. Whoa. That's fucking cool. All right, good. Do you think you'll be repeating? Raise your hand if you're going to repeat. I want to see the same show of hands. And more. Good. All right. We'll be seeing everybody in Salt Lake City then, or in KubeCon next year. Spoiler, I heard KubeCon next year in Europe is going to be in London. I know. I was waiting for that. Good job. Not in Europe, but somewhere. That being said, Joao, stage is yours. Go for it.
Hello. I will talk about Cell or CEL and how it can help you. First, sorry for my bad English. It's a joke for a partner. Who am I? I'm João Brito. It's like John. You can find me as this arroba. And we do podcast in Portuguese mostly for Brazilian community. I'm the palestrinha and CTO of Kubernetes and distro. Okay, so Kubernetes isn't secured by default. A lot of people already say this here today and yesterday. So what's the solution? How to do this best practices, validation rules, custom rules. How do I validate all these on my clusters? Cell is the solution, common expression language. It is made for YAML engineers like me, or maybe someone. And we made a playground. Marcus Noble showed about Cell yesterday. And you can learn about from examples and test directly on your browsers. All the hype is here. WebAssembly, Kubernetes, Cell, all in just one browser. And you can use Cell. The expressions is easy. It's just YAML. You can search for requests like object, spec, template, spec, containers, requests, and check if it's CPU limits or memory limits. I don't enter this fight of CPU limits. And another examples of expressions. So don't run with root user, pods running on with some tag or some region. Use labels and don't run on default namespace, please. And we are accepting contributions. The playground, it's almost a CNCF project, so you can join and send us feedback and join us on this journey. And thank you so much for this opportunity. Join us. Thank you.
Yes. Very good job. Well done, dude. Good job. Let's keep it going. Next up, we have a wonderful person. He happens to be 26 years old. Once upon a time, I was 26 too. That was a while ago. Fact. But he is doing incredible things at a very young age. His name is Matteo Bianchi. You can come to the stage. Don't be shy. He's also, let's give him a round of applause. All right. When Matteo is not doing Kubernetes-related things, he's a vocal coach, a voice coach. He sings heavy metal. He takes KubeTrain. Did anybody come here by train, by the way? Yay, cool. That's awesome. Is anybody going to the KubeTrain party later? Maybe? Yay, cool, awesome. Very, very good. So yeah, that being said, Matteo, like I said, is doing all sorts of wonderful things, and he will be starting his talk very soon. In the meantime, keep up the energy, folks. Take pictures, tweet, share the love, and it's all you, Matteo.
Okay, can you hear me? Perfect. So, I explained Kubernetes to my grandma. How many times at Christmas or in whenever occasion you get to with your family, you get someone asking, hey, what's your job? What do you actually do? This talk is going to give you some tools to explain, even to your grandma, what's Kubernetes. So, this is me, who I am. Oh, too much. This is me. I'm a developer relations engineer at Omnistrate. We basically take your image and compose spec and make a SaaS out of it. Check us out. And I'm a former startup CTO. I was building the usual platform engineering tool, DevX, Kubernetes, all of that. I built operators as well. So, and then I'm a metalhead, export aficionado, like I used to play in this kind of arenas, which is pretty fun. And I'm a full stack nephew. I mean, my grandma gives me a lot to eat, as you can see. So you can find me on all social media as mbianchidev. Check me out. Anyway, one day at lunch, it was around Christmas time, by the way. So I was in Italy, as usual. And my grandma was cooking my favorite plate of spaghetti. And she asked me, how are you doing in your new job? And I was like, what should I say to her? Is Kubernetes easy or is Kubernetes hard? I was having a hard time at the moment. So it's either blue pill or red pill. What would you choose? How many hands for red pill? Blue pill, okay. We have a blue pill. So we chosen to explain to our grandma what is Kubernetes. And she already knew about a few stuff, okay? Because I'll be honest. I already had this question a lot of times, and I get to explaining what a computer is. I mean, we got there. So basically, I can look stuff up, and I can do calculations and all my stuff. Then she knows what servers are. So they're basically someone else's PC where you run stuff. And then the cloud, they are servers, but they are shared by multiple companies. Very easy. And then we got into new concepts as virtualization. So we turn one server into multiple ones. Yeah, it's like using the same oven to cook 2 meals. Yeah, I mean, we're going to go with that. We're going to be satisfied with that. Then containers, like giving a packed lunch so you can cook wherever you are. That's a good one. Actually, my grandma came up with that explanation after mine. So I'm going to just say what my grandma thinks about this stuff. Orchestration, like at Christmas, when she's managing the kitchen, because she's actually managing and orchestrating my dad and my mom when they cook. And then, Kubernetes. So, like a very famous chef, like Gordon Ramsay, it's actually pretty true. So imagine you have 3 hungry nephews, you have to feed biscuits to them, and you want to bake for all of them at the same time. You have to distribute these biscuits, but they also have different quirks. So like, Alessandro doesn't like chocolate, actually allergic probably. Filippo doesn't like fruit jam, and I love chocolate chips. So you need a grandma to orchestrate all of that effort of baking and overseeing this cookie prep sesh. And this is what you get. So this is an actual schema that I designed to make my grandma understand. Like, she's the control plane, okay? She's in the master node. She's like scheduling stuff, so giving instructions. She's chatting with other grandmas, actually other copies of the grandma, which are kubelet, which is pretty fun to think. And she has to check the status, so she's a controller, but she also has all the recipes, so in etcd. And then there are worker nodes, so you have one node in which you have your vanilla cookie pods, actually one pod with the jam as well, because it's 2 containers in the same pod. I had to explain that. Didn't venture into namespaces and all that stuff, of course. So you have 2 pods for chocolate chips and 3 pods for butter, and those are actually also my cousins. So, and then we got to the Kubernetes features, just very quickly: load balancing, availability, scalability, and self-healing. I mean, these ones were a bit tricky to explain, but she's gonna get there. I'm gonna make my grandma become a better engineer than I am. So at the end of the day, my grandma asked me, so are you a grandma for your customers? Yes, let's say I am. Let's say I am. These are my contacts, and if you ever need to explain Kubernetes to someone of a very old age, you can share the video.
I think we can all agree that was absolutely incredible, so high five to you. After having worked in the Kubernetes ecosystem for quite some time, I've heard different analogies or metaphors, sometimes about a bartender, the one in the Kubernetes documentary, Kelsey Hightower talking about a post office, but grandma's cookies resonates pretty well with me, so I want to give another round of applause to Matteo. That was really good. Our next speaker is Kyle. Kyle, can you please come to the front? Have you signed up? All right. The talk? Yes. Okay. Yeah. Sorry, didn't get that far. And also, while he's getting set up, has anybody ever organized an event before? Is it easy? No, it's fucking hard. It's really hard. I don't know why we do these things. But this wonderful event that we're able to attend has been put together by a lot of people, a lot of patience, a lot of deep breaths, sending lots of emails, lots of phone calls, etc. I just want to give a shout out because he was volunteering earlier at the registration desk. But to all the volunteers who participated, can we please give them a round of applause? All right. Obviously, massive shout outs to Andy, to Lexi, to Benazir, to all the people on the organization team that keep bringing Rejekts, time and time again in this wonderful venue that we're here at today. But all the other editions that I've been to as well have been absolutely phenomenal. So yeah, it's really a lot of hard work that goes into it. That being said, whenever you're ready, we're going to hear about debugging.
Hi, everybody. Can you hear me? Okay, so I don't have any slides, but a little intro. I'm the Docker Slim guy. So I talk about slimming containers, and I'm going to show what it's like to use those containers. So you have minimal container images, right? Maybe you created them by hand, or you used one of the chain guard images, or you used Docker Slim. So you can't have one without the other. You have minimal container images, you need to be able to debug them. And that's what I'm going to show. So with the latest version of Docker Slim, you can debug container images, minimal container images, or any container images with 3 runtimes. With Docker, obviously. Kubernetes, that's another one. And then containerd, that's what I'm going to show. So I'll start by slimming Nginx. That's kind of a classic go-to. It'll take a few seconds. Okay, I have a slim image there, and I'm going to run it. So it's running, and I'm going to try to debug it. I'm going to use the interactive prompt mode. That's a lot easier to use. So by default, it's going to pick Docker runtime, but I can pick it explicitly. And then I need to pick the target. And right now it's also right there. So if I do ls, I see that I'm actually in the Nginx container. And that's not quite what you get by default usually. So let's get out and try to debug again. But this time, we're going to try to, oops. right. Target. I'm going to pick the same target, and then I'm going to pick a different parameter to disable the magic. There's this parameter called run as target shell, and it's on by default. And I'm going to disable it. So when you do that, you'll get something different. You don't see the Nginx container anymore, but you can get to it the old-fashioned way through the proc file system. Right there. So that's one of the enhanced user experience benefits you get there, in addition to different runtimes. So what does it look like to pick a different runtime? So it's pretty much the same. Instead of picking Docker as the runtime, I'm going to pick Kubernetes. And right there, I have a small pod running ChainGuard Nginx, and that's a minimal container image. And I can pick the namespace, but it's actually pretty good picking the defaults. But I'll pick it explicitly. I'll pick the pod, example pod, and target. And right there, I have my target. Connecting, it takes a while to create the ephemeral container and connect. And right there, again, I'm actually in the target container. Nginx. And then I can do which, and also I can access the binaries. Now if I look at the hidden files, there's a little bit of magic there with the binary directories, with the bin, user bin.
I'll wrap it up soon.
And that's pretty much the same thing you get for containerd. I have a VM with containerd. I pick the runtime. And I pick the target. And I also have Nginx running there. And again, it's right there. All three runtimes, one tool. That's it.
Oh, good. Well done. Excellent. Oleg. All right. Our next speaker is Oleg, who's an awesome person, who I've been very fortunate. I realized I didn't even introduce myself. My name is Bart Farrell. I'm a freelance content creator. I'm based in the north of Spain in Bilbao. Has anyone ever been to Bilbao? Yes, good. We have a wonderful CNCF meetup in Bilbao. I'm one of the organizers. If you'd ever like to give a talk, you are more than welcome. You can reach out on Twitter, LinkedIn, etc. But yeah, we were lucky enough to have Oleg at one of our meetups last year. Excellent speaker, wonderful community person. Looking forward to what he has to share with us today. Go for it.
Okay, thank you. Am I audible actually? Yeah, so thanks a lot for coming to my second talk, and let's continue. Well, no, of course, I'm not talking about Jenkins today, second time. I actually want to talk about test containers for your Golang projects. So who does develop in Golang? Who does know about test containers? Well, it's more than 1 year ago when it was basically 1 or 2 hands at KubeCon. So that's really nice. So yeah, I work on developer tools. Actually, I'm a serial DevTools developer and maintainer. So every time there is a Ignite talk, I have something to present. And yes, test containers has been one of my most favorite tools for API mocking, prototyping, including protocols like gRPC. Oh, yeah. Is it? No, it's not happening again like last time. Okay, so at Gradle we actually do quite a lot of stuff, not just Java build tool automation, not just. So Okay. No. So it's not working after all? Oh, yeah. Okay. Yeah, and we have Velocity, and actually we do quite a lot of developer productivity engineering, which is all about metrics, etc. So if you know about SRE, so DPE is basically SRE, but for developers, or something like that. And there are metrics, and of course there are tools that are needed to improve these metrics, to automate them, etc. And one of my favorite tools are local stack, well, because I have to develop with AWS, also microx and YMock for API mocking and development, and test containers, which I'm about showing to you. So do you want to see more slides? No. And I do not want to show more slides, but you can find them on my speaker deck account. And let me just show to you quickly what we have. So there is Test Containers website. Test Containers is a popular project which is available on multiple platforms like Java, Golang, .NET, etc. And in each language, it has quite a simple implementation that allows you to just quickly spin up a container within your test, and then you can manage your unit test framework to automatically tear down this container, and all you need in your code is just say, I want this container, this image with these settings, with these ports exposed, and then you just write unit test and you let test containers to care about everything. So there is implementation for Golang. It's called Test Containers for Go. And there is quite a lot of documentation, and there is repository that actually creates, provides everything around test containers for Go. And of course, there is also Go package documentation, etc., etc. So there is a lot of stuff. I will just show you how it looks like in practice. So there is a bunch of models that you can integrate, and one of these models is YMock. And when you develop, you can just say that, is everyone familiar with YMock? No. Microx? Okay, so basically it's Microx, but all the one written in Java. And when you do development, so you say that I need YMock test containers Go. In fact, it pulls in, well, a lot of dependencies. And there are things like Docker client, YMock, Go YMock, OpenTelemetry embedded, etc., etc. Fortunately, everything is mostly for testing purposes. And when you go there, so you just say that I want to run a container and stop on cleanup. It's a wrapper that basically instructs a testing container to tear it down, and then everything is provisioned. You send HTTP request, for example, or here's your basically client application code, and then you can verify what's being returned by just calling another method. And everything is being run in a container, so whether you have a database, whether you have a Kubernetes cluster, there are K3s model, for example, with all the capabilities, you can just write like that, and everything gets provisioned for you. And how it looks from testing perspective, so I just call go test, and well, that's it. So it provisions container, it does all the mappings, it acquires random ports, you work with it, and then it tears down. That's it. And if you develop microservices, etc., consider doing more integration tests with tools like that. Done.
Great. Thank you very much. Good job. Well done, dude. Cheers. All right, next up, we have someone who's speaking about cube color. All right, ready? Ready to go? Ready to rock?
Okay, 1, 2, ready? Okay, Hello, my name's Sebastian Prune on Slack and whatnot, CNCF ambassador, meetup organizer in Canada, specifically Quebec City. I'm here, I'm now also the maintainer of KubeColor. Who knows KubeColor or use it already? One hand, okay, so if you're using it for a long time, the old project is now archived and there is a new project which was cloned with a lot of new features into it, so upgrade. So now for all the others, most of you are presenters. Who are presenters this year, today, or okay, so I don't want to see any demo where you tap a kubectl or something and it's black and white or white and black. Stop that, that's disgusting. So that's what we're talking here. Okay, so this is, the first one is what you usually get, and I'm sorry for you if you're working all day long and watching this kind of stuff in your terminal. And the other one is, well, using KubeColor. I'm sorry, but like I totally see there's a problem with some pods right away. I don't have to think or look at the lines. It's straightforward. Same thing when you describe. Of course, this one is very small, but the idea is just check the colors. You don't mind. The only important thing is the reason, like crash, look back up. You see that straight away, ready, false, like you know it. It's very easy to see. So that's a very great tool. It's a single Go binary that calls kubectl undercover. So what you usually do is like you just install kubectl. It will use your regular kubectl below it. So go to the, it's very easy to install on whatever the platform. For Mac, you can brew install kubectl. It's very simple. You then just alias kubectl equal kubectl, and you're done. And you have colors. So go test it. And you love it. I'm pretty sure you will never go back of black and white. Thank you.
Very well done. Excellent job. Excellent job. Respect the color. Cool. Our next speaker is David, who's going to be talking about OpenStack. Yes. Come to the stage. I will say that this lovely human is by far one of the most fashionable people in this building. So we're giving him a round of applause. I really dig his style. Fucking sick.
In fact, I came to the idea to make this lightning talk like yesterday, and until like before 10 minutes, I didn't even have slides. So it's very improvised, and I hope you will like it. So you know, like this question you get always at those conferences, like, hey, how are you, what's your name, what you working on? And I say like, yeah, I deploy OpenStack on Kubernetes. And then people say, yeah, you mean you deploy Kubernetes on OpenStack? And I say, no, I deploy OpenStack on Kubernetes. So that, I think, like I had, people were always fascinated, so I thought, like, okay, maybe I make a lightning talk about this. Who I am. So this is me. This is my more colorful picture, which is also on GitHub. And I work for Sys11, a wonderful company, since 2022. And I actually have been playing with Kubernetes since version 1.3. That's pretty much 9 years ago. And I started before as a Java engineer. Okay, I tell you a secret. I've been doing PHP before, yeah. So but it's part of my past. So, what would be a good reason to use OpenStack upon Kubernetes? And we had such a wonderful talk about operators, and I feel like OpenStack is probably one of the nicest examples why operators are great. So, what is OpenStack? OpenStack is one of the most complex distributed systems with awful dependencies I could ever I could imagine. Like you have like these Python libraries you need for each component, which might differ from one component to the other on the same system. This is a hell. But then you also have, you know, like this the different databases and memcache, and you have RabbitMQ. So that's actually something like a really big microservice architecture. And on top, it's something which is crying for being containerized. So that's actually a first good thing to take OpenStack into containers. But then it's still a complex distributed system. So rather than just deploying it with some like Puppet or Ansible or something, you would something that is taking the lifecycle management over time and in a cycle. So that's something you could do on operator. So what makes sense that you start deploying bare metal Kubernetes, and on this bare metal Kubernetes, you use something which we found out, it's YAUK. It stands for Yet Another OpenStack on Kubernetes. I just found this graphic by Googling for 5 minutes. Just don't judge me for that one, yeah? So that's how YAUK presents itself. Yeah, you just deploy a bare metal Kubernetes cluster, and then you have a set of Kubernetes operators, each for one component. So you have a keystone operator, you have a glance operator, a cinder operator, and stuff. You follow me, yeah? So, and for all of these components from OpenStack, you have this like of a bunch of CRDs, which is configuring that component in a distributed manner. So, and something what we developed internally, I just put this graphic from another presentation I held a few weeks ago, just to show that we solve bare metal deployment using, operator which operates the CRDs of other operators. So like we have like operators operating operators. That's what we actually do. And to just, also make the bare metal deployment working using Tinkerbell. And then we deploy the operator from YAUK on it, and then actually we just use OpenStack then on top. So I hope if you're interested, I can, that's the quickest demo I could show you. It's actually what the cluster which which I'm working right now on. You can see that there have a lot of parts, and the bottom top, that's like the operator for all components, like you see here, like what I was saying, Cinder, Glance, Gnocchi, Heat, Horizon. You have the operator for the keystone and stuff like this. And then if you look up this, we have components deployed by the operators, some as deployment, some as stateful sets, some as daemon sets, like what is fitting better for the entire opponent. Also, we have, we have also like a Ceph completely using Rook. So we use Cinder complete with Ceph. So actually, that's all I can tell you in 5 minutes about why and how we operate OpenStack on Kubernetes. And just that's it.
It's great. Very, very well done. All right, our next speaker, well, he's already coming up. I will say that this, we have one fashionable individual. This individual has really, really cool sideburns, so massive applause for that. I respect. That's some serious effort. Going to be speaking about in-place upgrade in Kepi.
Hi everyone, I hope you can hear me correctly. So yeah, you should see I just deployed on OpenStack a Kubernetes cluster. Just one control plane and one worker nodes. So you have to trust me, I just deployed it right now. So basically, we just need to see the version of Kubernetes being used. It's 1.28.5. Now let's get back to the slides. So today we are going to talk about system DCSX and in-place Kubernetes upgrade with Cluster API. So hi everyone, I'm Mathieu. I work as a Flatcar engineer inside Microsoft. Flatcar is a container OS in case you don't know. Systemd SysX, what is it? In the last release of Systemd a few releases ago, a new feature appeared, which is Systemd SysX. Basically, it allows you to mount an image on /USR and /OPT. What is an image? An image can be a SquashFS image, it can be a directory, it can be whatever you want. So this is an example with an actual SysX image with Flatcar ZFS raw image. So you can see there is the binaries folder, the libraries folder, everything you need to run an application. So in this case, it's to run ZFS tools. So this is quite handy if you can't extend your system because it's immutable, for example. The feature comes with a timer, which is quite handy because if there is a new Systemd SysX image available on a web server, for example, Systemd SysUpdate will just download that file and create it on the system. So you can manage updates with SysX images. Now, Cluster API. I won't go deeper, but this is how I can explain really quickly what is Cluster API. Deploy Kubernetes from Kubernetes, that's it. That's all you need to know. Now, as an engineer, you know that everything is going to be deployed on your provider using Cluster API. So the network, the security groups, and the instances. And the instances are going to use images, of course, operating system. So what is a Cluster API image? Basically, it's an image with all the Kubernetes dependencies, the container runtimes, everything you need to run Kubernetes. It's inside the pre-baked image. So that's quite handy if you have only one version of Kubernetes, but what if I have a couple of versions of Kubernetes to support? It means that for each version of Kubernetes, I need a new image. Then what if I want to support multiple architectures? I need more images. And what if I want to get new images for each OS version of my Ubuntu or Debian or whatever? Well, it becomes to be a nightmare to manage. So what if we could use the regular OS images instead of using pre-baked images for Cluster API? So that would be nice because we can remove the strong bonding between the Kubernetes version and the OS version of the system that we want to deploy. And bonus, we can have the auto updates of Kubernetes because of the Systemd SysUpdate mechanism. So the current state of this feature is that it's already available on OpenStack Cluster API provider. It's already available on the Azure provider, and AWS vSphere are going to follow. So let's go back to our cluster. We can see that while I was talking, the nodes have been updated to 1.28.7 without doing nothing. So the SysX Systemd SysUpdate services has been pulling the images, and then we have the Kubernetes reboot daemon that has been able to coordinate the reboot. But yeah, we have in-place update with Kubernetes and Cluster API. Thank you.
Very well done. Very well done. Our second to last speaker is Francois. You're here, you're there. Very good. He's going to be talking about searching 40 petabytes of data of storage for logs and metrics, I believe. Very good.
Hi. Is the sound okay? Okay. Hi everyone. I'm here to talk about searching a lot of logs on your cluster. I hope you don't have this kind of issues because it's very painful, even if you have a good engine. Who am I? I'm one of the co-founders of QuickWit. QuickWit is a new engine cloud native for logs and traces. And so I'm work mainly on the engine and also on the Grafana data source so that you can play with the data in it. So first question, why would you want to start a new engine? Typically, you want to be able to scale from up to petabytes or more generally to terabytes. When you handle manage logs, it can add up quickly. So that's one pain point. Also, you want to manage this very simply. And lastly, you want to be fast. So we build a new engine from scratch to fix those 3 pain points. We build it in Rust. It's powered by a well-known search library, which is used by many big companies called TonTV. To play with petabytes, you have to decouple computed storage. So we did that. All the components are stateless, and also as a nice to have, we also have a schemaless indexing, so you don't have to take care about your schema. So how does it work? First, you have to decouple compute and storage. So on the left part, you are indexing, if this is the right path, you are indexing data, and you have one pod. You can start with one pod, but you can add others. This pod will just produce what we call split files. This is the unit of search in QuickWit, and they will just upload it on the object storage. And once it's uploaded, it will also update a small file called the metastore.json file. It's just a list of all the split files that are present on the object storage. And then you're done. And on the read path, you have the searchers who can have access to this, and you can also add many searchers on it. And then here you have a decoupled computed storage architecture, and you can scale up, scale down your indexers, your searchers, shut down everything, or start everything in 1 second or a bit more. The secret of QuickWit is relies in the split file. The split file is made of 3 data structures. One data structure is for accessing document from their document ID. This is what we call the doc store. Then we have the inverting index. So this is for the search part. So it's basically a hash map. You have got a term, and it will return the list of documents matching this term. And lastly, we have also columnar storage. It's for analytics purposes, so you can do fancy stuff also with it. And the last part, the tiny part, is route cache. It's a kind of index of indexes. So we store a bit of metadata to access the object storage very fast. And with that, you can search 40 petabytes. So obviously, it's not me playing with this data. We have a client called Binance, and they program to reach like 100 petabytes soon. So as I'm talking, I hope that they are above 40 petabytes. And they have one cluster, for example, for indexing. So they can decouple also the clusters for indexing and searching. So here, for example, they isolated like one cluster for indexing. They have 200 pods, and they are indexing at 1 petabyte per day. So it's possible to build an engine like this, and it's possible to make it work at this scale. And we hope like to increase this scale very soon with them. And that's it.
Well done. Excellent. Good job, Francois. Cheers. Oh, you can just leave it. Fine. High five. Good job. High five. Good job. All right, our last speaker. Does anybody know Divya? Raise your hand. Are you lucky enough to know Divya? Divya's going to rock the stage right now. Divya, come up, please. Let's give her a round of applause. All right, so Divya is our final speaker, who's going to be speaking about community. She's a wonderful, awesome community person. For the folks of you who don't know Divya, you will be fans in the next 5 minutes. Also, since we are getting towards the end, Chris, can you actually just take a picture? Can we do like the selfie moment now? Divya, can you come up here? Everyone raise their hands. We have extra lights. Are there other lights? Also good. Let's give a round of applause to the photographer who knows what he's doing. It's all you, Divya.
Okay. Bart really threw me off guard when he said that the person before me was the second last speaker, because I was expecting another lightning talk and I was sort of not prepared to be the last speaker, really. So today I'm going to be talking about community as a pond. And the reason I'm going to do this is not because I work on the community side of things and not because I want to flex my really bad Duolingo French skills, which I've just been practicing for 2 weeks. It's of no use. But the thing with me is when I say that I'm a principal technology advocate at SUSE, a lot of people come up to me and ask me, but do you not really work on the cloud native side of things? SUSE is actually known for Linux, right? And anybody here in the audience who's actually worked on SUSE Linux Enterprise or even any of the open source SUSE distributions? Can anybody show? Oh, that's quite a number. And hi, Rob. I see you there. So, and this is a conversation that comes up ever so often when I have to explain my job, like the real good gentleman who spoke about explaining Kubernetes to his grandma. I have to do that ever so often at family functions, and a lot of them are in the IT side of things. So they're like, yeah, SUSE is Linux. SUSE is known a lot for SAP and Linux, but not like cloud native. So I'm going to take you through the TLDR history of SUSE so far. And essentially, it started off right when I was 2 years old. I actually, on my second birthday, SUSE was founded. The acronym for SUSE is software, and I'm not going to say that because essentially I'm going to butcher that language as well. Let's just stick to butchering French for now. So SUSE was founded on 2nd September 1992. After a lot of mergers, acquisitions, we ended up acquiring Rancher and a bunch of other stuff along the way, and also New Vector, which is our container security and management tool. And if you look at the thing that has been consistent with respect to SUSE so far, is its focus on open source, on being truly open source, on being, respective, or on being respectful of the community and the collaboration that the community brings with it. So when I say that we have these as our unofficial ideals, please, take me really, really seriously, because honestly speaking, I think this is what we live by every day at our company. And when we talk about open source and when we talk about the business of open source, right, a lot of people look at the technology, but a lot of the people don't look at the actual people behind the technology. And I think that's important because, people create tech. We haven't yet started creating tech that creates people. And I hope we don't come to that stage. So when we talk about those people, that community, it's what we help foster with our open source communities on the Linux side as well as the container side of things. Now, a lot of you might be familiar with the projects on the CNCF landscape, like K3S, Longhorn, and KubeWarden. I know that some of you might at least have heard of it. But did you actually know that we also have an equally active contributor community on the Linux side as well? And honestly speaking, we are here because we not only look to these communities, but we also actively build out these communities with the help of collaborative efforts. A huge, huge shout out to Celium folks. I know there were a couple yesterday, and there was a talk about eBPF today. But honestly speaking, our collaborative efforts with them over the course of time has helped us reap the benefits of harnessing the power of eBPF, sorry, oh my God, how can I get that wrong? But harnessing the power of eBPF to secure your cloud native workloads. And whether that be on your local workstation like Rancher Desktop, or whether it be on your container management platform that we offer, that is Rancher, or your K3S distribution or our RKD2 distribution, we have it, across these distributions because of these collaborative efforts that we've engaged with another community. And similarly, we've just recently announced this, the integration with another open source project that is Spin. And this is just the start of things to come, because WebAssembly is another whole new ecosystem that we are integrating with and we're just stepping into. So given the industry trend and given the direction in which the industry is headed, this is collectively broadening our technical horizon. And it's not just for Rancher or for SUSE alone. And when I talk about broadening horizons, it's absolutely essential that I also talk about our advocacy efforts with respect to the community. The reason community advocacy is a little difficult is because it's a little difficult to measure and quantify when in a real world context. And I mean, we always have these conversations unofficially, but bringing value is different when it is in the community side of things, as a lot of y'all would know. And our efforts are always to give the people that are our audience, irrespective of whether you're an enthusiast or whether you're an experienced person, the actual value that you came for, that is learning about new stuff. And that could mean non-technical stuff as well. For example, when I think last week, before coming over to KubeCon, we had a session around the legalities of open source, which is something I personally did not know a lot about myself. So I am going to wrap this up right now, because I know that I'm probably a little over time. But the whole motto around open source, around cloud native is this. We could sort of get the best minds in the business in any company. A lot of us have budgets. And we could hire the best minds, and we could probably do it all by ourselves. But open source has taught us that if you actually go together, you achieve so much more. And you can pioneer innovation in ways that was previously not possible. And that is the end of my short keynote. And I hope it made a little sense to you, because that was also a sneak peek into how my mind works. But yeah, we're going to be there at KubeCon. So this is a QR code. If you want to find us, we'll also be very, very prominent at the KubeCon booth G5. So yeah, that's pretty much it. And I hope you had a fantastic event. And I'm looking forward to all the conversations that we'll have after this. So thank you, everyone, and have a very good evening. But, just a minute. I'm not going to give it to you right now. I want to actually invite the organizing team on here, if that's okay. I know this is impromptu. But can we have the organizing team on here, because they deserve a huge, huge round of applause, and they're the unsung heroes of this conference. So can we have them here, please? No, this is purposely to put you all on the spot, really. So, So a lot of this wouldn't have been possible without these, and the volunteers and the program committee, and a lot of the people. This is just I think, the tip of the iceberg, as they say. And there's a lot of community effort involved. And I'm really thankful that y'all put up such a fantastic conference, primarily because I'm also a first-time attendee, and this is my first time attending Cloud Native Rejekts. And it's been an awesome experience so far. I've been telling Benazir that all through the day. She'll probably kill me if I tell her anymore. So thank you so much, and a huge round of applause for all of them, by the way.
Thank you for coming.
Thank you for inviting me.
Yeah. Now all the volunteers. Okay, all volunteers to stage. Volunteers to stage.
And now I get up close and personal shots. Oh, no. Now we want to get the picture with everybody. Everybody come down.